Hello, and welcome to the specialization on user interface design. I'm Joe Constan, Distinguished McKnight Professor and Distinguished University Teaching Professor of Computer Science and Engineering at the University of Minnesota. And we're delighted to have you here. This first video is a chance to meet your course faculty, hear a bit about what user interface design is about, and get a glimpse into what we have in store if you join us for the next 20 or so weeks. So first things first, I'd like to introduce, or in fact have introduced to you, the rest of our faculty, starting with my right, your left.
So my name is Brent Hecht. I'm an assistant professor of computer science and engineering here at the University of Minnesota. Starting in the fall, I'll be an assistant professor of communication and computer science at Northwestern University.
And my name is Lana Yarosh. I'm also an assistant professor in computer science and engineering here at the University of Minnesota.
Hi, my name is Haiyi Zhu. I'm an assistant professor in the Department of Computer Science and Engineering at the University of Minnesota here.
And I'm Lauren Trevine. I'm a professor of computer science and engineering at the University of Minnesota.
You'll be hearing a lot more from each of us as we go forward. But first things first, what is this user interface design about? And I want to start with a bit of a history. I hope you can't tell looking at me, but I have to admit, I started programming in the era of Fortran and COBOL and key punch machines and card readers. Back in the days when, let's be honest, nobody worried about user interface design. Nobody worried because computers were immensely expensive, and all of the engineering was put into the idea that we were going to make this machine as efficient as possible. I worked for a bank writing COBOL, and there were immense complex systems designed to make sure that this machine, which cost the bank $1 million a month, was continually being fed by different people so that it never sat idle. The idea that we, who were making far less than that, I was making $150 a week, were important in the process was never even dreamed up. In fact, there was a team of 12 people whose job was to just keep the printer running by feeding paper in all the time because the printer was more expensive than any of us. Well, fortunately, things have changed. You probably have in your cell phone, maybe even in your watch, a computer more powerful than the ones I was programming. And as computers became not only more powerful and cheaper, but available to everyday people for everyday tasks, we started to realize that the vast majority of systems built with computers were really miserable to use. I'm sure you've all had this experience, whether you've been trying to figure out what's the cheapest hotel room or airfare if you used an online reservation system. If you've gone to a web page and you wonder, why is it that as soon as I go back to this, it clears all the fields away and I have to start over? There's lots of examples of systems that are clunky, systems that are painful. As you'll learn later in this specialization, systems that have hurt people and caused financial disasters, all because they were very hard to work with people. On the other hand, every once in a while you come up against a system that's beautiful, elegant, fluid, where using it just feels natural. You come up to it, you stop thinking of it as a computer, and you just get your work done. You get the money you want out of a bank. You figure out that you're listening to music and you stop thinking that you're programming some sort of computer device. Well, the goal of user interface design is to make these experiences fluid, not clunky. And that's what we're going to teach you in this series of courses and in the Capstone project. So let me give you a very brief overview of what those components are. We're really going through three major components. The first one is user research. What do you have to learn about the people who might be using the system that you're designing? What do you need to know about the tasks they're trying to complete, their technical skills, the distractions that they might be experiencing while they're using your system? All of the things that might help you, not only learning directly from them, but learning from research others have done before about human capabilities, limitations, the way people perceive and think. Once you have that user research, we're going to move into part two, which is design. How do you go from an idea of what problem you're trying to solve to first quickly and then perhaps in more fleshed out detail, sketches and prototypes of the idea for how you're going to address that solution. We'll take you through the design process, both the quick parts where you come up with lots of designs quickly and the refinement as you start fleshing out a design. Third, how do we evaluate those interfaces and most importantly, improve them? Design as we teach it to you is a process. It's an engineering process. It involves getting something out there, critiquing it, both critiquing it with your own expertise and the expertise of others, including your users, and then making it better until you finally have something that stops being so clunky and starts being more fluid. Finally, we're going to wrap all of these pieces together with a capstone project. That capstone project is a group design project because these kinds of designs are really done in groups in industrial practice, where you'll take on a challenge and a group of you together will learn about the users, apply your design ideas, do the evaluation, and present a final design along with the report on its rationale and what you've learned in the evaluation along the way. And when you're done with all of that, you will be introduced into the wonderful field of user interface design. So one last word, who is this specialization for? I should say we've been teaching user interface design collectively over the past 24 years. I taught my first course in it 24 years ago. Lauren here joined me already now. This is going back 14 years, and the rest of the team here has been teaching it in recent years, and we continue teaching it forward. We found this course works very well for people who are interested in building computer systems, computer scientists, software engineers, people who are learning about information technology. But we've always brought in people who are interested in designing and specifying systems who are going to work with implementers. That includes people who come from domains where these systems are important, in healthcare, in education, in finance, but also people who've come in from schools of design, people who've come in just out of general curiosity. This course series and capstone do not require that you program. They require that you be willing to work hard in design, that you talk to people, that you observe. We will, by the end, refer you out, if you're interested in also doing the programming, to a number of excellent courses that can help you learn the specific programming skills that you can match with your design to turn it into an executing reality. So we welcome all of you, and why don't we move on next into what makes this course unique, and I'm going to turn this over to Lauren.
Now, even though you don't need to program for this course, we expect that many of you do have a computer science background. And if you think back to your classes you've had in computer science or software engineering, a lot of those courses are about building software systems right. And what does right mean? It means things like efficient code, elegantly designed, well-structured and modularized, maintainable, things like that. And those are very important things. That is not the focus here. It is not the focus of user interface design, and particularly this course or sequence of courses. Instead, what the focus is here is on building the right software. What do we mean by the right software? We mean software that actually solves real problems that people have, that does something that people want to do, and that is actually usable, and we hope even enjoyable for people to use. So that's the distinction between traditional computer science courses many of you may have had and this course. And now let's hear a few words from Lana about sort of the nature of this field.
Another thing that makes this different from other computing fields is its interdisciplinary nature. So as you can see here on the slides, there are lots of relevant disciplines that contribute to the field of human-computer interaction and user interface design. And in fact, if you were to Google user interface design disciplines and look at the images, you'll see lots of other takes on the different Venn diagrams that contribute to the field, depending on who's making them. So here I kind of tried to summarize it through three related fields. So some fields focus on understanding humans. social science, psychology, linguistics, anthropology, communication, all these things contribute to understanding humans. Now, once you understand humans, you may want to know how to design for them. So there's lots of fields that contribute to design of technology. So whether it's interaction design, industrial design, graphics, or even arts, like media arts, for example, that may contribute to the content that goes into the system. And finally, you may be interested in actually building the technology, building out the designs that come from this process. And that's where computer science comes in, related fields like robotics, and different forms of engineering, depending on the kind of system that you're building. Now, HCI work happens in all of these categories, but it's particularly valuable at the intersections of these categories. So when people from design and technology come together, when people who understand humans come with people who are trying to build the technology to support them. And I think that's what's really unique about this field, is this interdisciplinarity of it.
So why studying user interface is important? Designing user interface is not that simple and intuitive like many people might think. One common mistake interface designers and developers make is assuming that their users think like they do. However, the fact is that it's often not the case. You are not your users. As a designer and developer of the interface, you know your interface inside and out. You know everything about your interface, you know the interface even when it was just a few sketches on a napkin, and you know the every iterations that the interface has been through. However, many of your users are coming to your site or using your product for the very first time. A little confusion might just leave them feel that they are dissatisfied, they are angry, they are frustrated, and even abandon your product. The problem of you are not your users are even more significant when you are designing product or software for the elderly, for the children, for the people from very different culture, for the people with disabilities.
Yeah, I think that's exactly right. You know, I taught this course the first time last semester here at the University of Minnesota. And in the introductory lecture, I made some of the points that we've been making here. And it was very clear to me that a lot of my students, many of whom had a strong computer science background, had this experience of, you know, putting their blood, sweat, and tears into building a website or a mobile app or these types of things. You know, they think they have the next big startup, these types of things. And then, you know, the disappointment comes crashing in because while they thought they had a great application, their intended users didn't agree, right? They didn't ask the users beforehand, didn't employ many of the techniques that we'll be teaching in this class. So I was surprised at how easy it was to convince many of these very technical people how important it is to adopt some of these interdisciplinary techniques, to adopt some of these techniques that require you to go talk to a lot of people all the time. And they really bought in quite easily.
Well, one example of this that is certainly a commercial success everybody knows is Apple. You know, my first experience with Apple was the Apple II line, which no one would claim was easy to use. I mean, the fact was it didn't do lowercase text, and they said if you wanted to do lowercase text, you could solder a cable from the shift key into the joystick port and bring in lowercase text yourself. It was a machine for hackers. And it was actually a wonderful machine for hackers. But I also watched Apple as the years went by with the Macintosh. And that Macintosh was a brilliant design. Parts of it that had come out of Xerox, parts of it that were then refined further by Apple, with teams that included social scientists and experts on people, that led to Apple having this amazing reputation for ease of use. And those of you who were around at the time when everyone was wondering, well, what's next? And Apple probably should have started to fail because Microsoft and others started catching up, realized that reputation Apple had for being user-centered sustained the company right up until the point where it came back with the iPod and the iPhone and these other new devices that still feel like they were just natural to pick up and use. And this is a company that at various times has been the most valuable company in the world as a result, because they've had a relentless focus on making this experience something that's pleasurable and comfortable.
And, you know, it makes me think too, natural and easy to use is just not easy. We've heard some of our colleagues at places like Microsoft say, as they've started to try to be more systematic and data-based about the decisions they make, that they'll have their design team members make guesses as to, which of these particular interface techniques users will prefer, which feature is best, which font, which color. And these are experienced people, and they can't get it right. Even their intuitions are not sufficient, so they need to have good processes, good methods, and good evaluation in order to make things that people can actually use.
Oh, and I think this is particularly important when working with users who are very different from you. I've done a lot of work with kids, and I never fail to be surprised. I kind of take my first stab at a problem, I have my first intuition about what might be important to children in a particular system, and yet they always kind of surprise me with what they actually prefer and what they want to do. And it's only working with them that I begin to understand what are the challenges that they face, what are their priorities, what are their motivations in this problem. And you were saying something?
Yeah, I was just going to mention, in a couple of videos, you guys will see all of us run down a list of very famous success stories of design and very famous, or I should say infamous, failures. And these failures include cases where people died, billions of dollars were lost, companies' reputations were irreparably damaged, these types of things. So in terms of, value for your time, this is just an incredibly important subject matter to study, in my view at least. I'm sure in your views as well. So if that discussion didn't convince you as to the importance of this particular material, we thought these next couple slides might do that. What you're seeing here is a listing of Google's current job openings in this area. You'll see just tons and tons and tons and tons of listings. It's not just Google. Here's a Facebook's list. There's 51 current openings in the domain that you're going to be learning about in this specialization. And then here's Microsoft with hundreds, right? So this is not only an area that's important, many prominent companies recognize how important it is and are hiring extensively in this area.
And it isn't just down in the trenches. There's so much interesting stuff going on that there's a really strong professional and research community around the area as well. There's many professional societies, including the User Experience Professionals Association, or UXPA, the Interaction Design Association, IXDA. And then coming out of the computing area where we all come from, there's the Association for Computing Machinery and its Special Interest Group on Computer-Human Interaction, or SIGCHI. Where most of us are heavily involved with this. It's about 4,000 members of the organization. And one of the things that SIGCHI does is sponsor a bunch of professional conferences where researchers and practitioners from around the world get together to discuss new ideas that they're developing, share stories of successes and failures, and learn from each other. SIGCHI has about over 20 conferences every year. They're held around the world. And recently, over 9,000 people have been participating in these conferences. So our flagship conference is the CHI conference. Now, as you'll see, this map shows where some of the conferences sponsored by the Special Interest Group on Computer-Human Interaction are happening over the next few years. Many in North America and Europe, as well as an increasing number in Asia, and moving to other areas like Africa and Latin America as well. Now, as a sign of the interest and growing interest in this area, the CHI conference, this is the leading research and practitioners conference in the field, it's been increasing in participation for the last decade. Used to be 10 years ago, it was about 2,000 to 2,500 people, and recently it's moved up to being 3,000 to 3,500 people. So a great deal of professional and research interest in this field as well. And it isn't just in places like North America. This slide shows participation in one of the most recent CHI conferences by country. Lots of people from the United States. In this case, lots of people from South Korea, China, Japan, Germany, many other European and Asian countries. So it's really a vibrant, growing, and international field.
So I wanted to talk a little bit about how I got into this field. I did my undergraduate in computer science in a very traditional computer science program in the University of Maryland. And, as I was thinking about all of these kind of technical questions about how to write good code, about how to connect with databases, about how to think about your data and how you handle it, I was kind of feeling increasingly frustrated by the fact that I felt that all of these things I was learning, I wasn't really applying to real problems and real challenges that people face in the field. And all of that changed when, as a junior, I took my first human-computer interaction class. In that class, one of the challenges that we were posed with was designing technology for the elderly. We were trying to design an ebook reader that the elderly could use. And this was way before Kindle, not to age myself, but it was significantly before Kindle that we were working on this project. And I remember thinking, I think we can do this. Here's kind of what I think it should look like. And all of our kind of sketches, all of our ideas really changed when we started to actually talk to people who were elderly, who were living in assisted care, and who were able to provide us with a lot of insight about what the design should be like. It was very different for me to see the ideas come not just from my own head, but also integrate kind of my own intuitions as a designer with what users brought to me by telling me about their challenges and their motivations and what they wanted to get out of the project. In the end, I was able to see that this field let me as a computer scientist have this opportunity to make a change in the world and change individual lives by creating technology. It really was something that really changed the trajectory of my career. And I hope this course is as influential for you as it was for me.
So I think, like you, Lana, I have a similar story where I didn't go in, to college thinking that I would study HGI. In fact, my background is in both computer science and geography. I have a very traditional computer science degree from a liberal arts college right near here, actually, as well as a geography degree. And I was just fascinated with both of them. I decided to pursue geography at the next level as I thought it addressed some of the most important problems in the world. And what I learned in my 2 years in geography, getting a master's degree, was, I think geography does address some of the most important problems of the world, but how you address those problems, well, that's getting computers to understand humans and helping humans understand computers. And so that led me back into computer science and to get my degree in computer science, my PhD in computer science in HCI, and has created a great deal of professional satisfaction for me in getting to teach this stuff and research it as well.
Yeah, similar to Lana and Brent, I also had a traditional computer science undergraduate degree. And during when I was an undergraduate student, I became more and more interested in those large-scale online socio-technical systems like Wikipedia and Facebook. So I was wondering, what are the underlying principles of these large-scale socio-technical systems? How can we make these systems better, more efficient, more productive? And if we want to design a new technical systems, socio-technical system from scratch, what can we do? So with these questions, I went to Carnegie Mellon University to pursue my PhD degree, and now I'm still working on these areas here at the University of Minnesota.
So I too came to the field a little late. I did a classic computer science undergraduate degree, wrote grad school essays about how I wanted to work on parallel programming languages. And in my first year of grad school, took a course on what was then thought of as user interfaces. And it was all about user interface technology, how to build the toolkits that put the menus and the scroll bars on the screen. And I actually did a dissertation on user interface technology where we built a toolkit that had exactly one user. And we were really frustrated that we had one user, because with no users, we wouldn't have had to support it. And with one user, we had to support it and had no fame whatsoever. And when I became a faculty member, I realized that the people I was seeing in the user interface technology conference were all also getting together at this CHI conference. So I figured I'd better go there too. And it opened up this world of, wait a minute, if you start thinking about the humans first, you can do these interesting and powerful things. And I got hooked on that. I built on a bit of psychology background I had had from school and started shifting what I did from technology first to building technology in support of things that made sense to humans. And I've been happy with that ever since.
Well, I think I zigzagged a little bit to get to human-computer interaction and user interface design. When I went to college, I had no idea about computer science. I was going to be a political science major and go to law school. And for whatever reason, I decided pretty quick that wasn't the right path for me. And so I got into computer science. And I wasn't quite sure what I was going to do with it. And then my senior year in college, I sort of discovered linguistics, and I thought, this is really cool. We can actually even have computers try and understand language. So I went to grad school to do AI and natural language processing. And, I thought, well, we'll teach computers to understand language. And I thought that meant to understand sentences. And it didn't take too long to realize, well, first of all, that was really hard. And it's even hard for people. And one of the things we do is we don't just understand sentences. We have conversation, we have dialogue, we go back and forth. So I got into that area. And it didn't take me too long to realize, interaction involves a lot of things. And in order to succeed at interaction between people and computers, maybe the right way to think of it isn't just that computers should understand language and produce language. It's a perfectly fine thing to do, but that we should think more generally about what computers are good at, what people are good at, and how to create systems such that the system, the people and the computer together can work more effectively. And that's an approach I've always been interested in ever since. And also, as soon as I sort of hit that perspective, what was really interesting is I felt like I could work on real problems that really matter. And that's what excites me as well about this discipline.
So if we're going to spend the next 20 or so weeks together, it seems like you should know a little bit about us and maybe even a few things that you would have learned if we were face-to-face in the classroom spread out over time. So I'm going to actually ask everyone here to say just a few things that you might not know about us that will help explain when, over the course of the videos that follow, we might appear to be a little, well, I guess the polite word would be quirky. And so why don't we just start with Lana to my right? We'll come around the circle. I'll go last.
All right. What can I say about myself? I was born in Moscow, Russia, and in fact, from time to time in the course, I may be whipping up my Russian accent, which many people find quite amusing. But I actually spent most of my childhood in Belarus, and then my family immigrated to the United States when I was 10 years old. Let's see, something fun about myself. Well, one thing that people find unusual is that I'm kind of obsessed with Legos. So every time I accomplish a big work task, like, for example, submitting a grant, which is something that professors have to do a lot of, I buy myself a Lego set because I think that's really the best reward for a task done is a new Lego set to explore. Now, how about you, Brent? Something fun about yourself?
Well, I'll start out with where I was born like you. So a much more boring origin story. I grew up in the San Francisco Bay Area, right outside of Berkeley. It's been interesting to see that area shift a lot as I've grown older. In terms of fun stuff about me, as you can see, I have a somewhat alternative appearance. There are 7 of these. I often get that question. There used to be a lot more. You can maybe try to find some pictures of that on the internet. Let's see, I like to travel a lot, and hopefully I've been to your home country. And Lauren, this is my latest fun thing. Lauren and I recently did some research on emoji that was featured both on National Public Radio, which is our very distinguished public radio network, as well as in Teen Vogue, which is a magazine for, I think, young women between 14 and 18. So that's definitely a first for me.
Good. Well, I guess I get to do my origin story now. I was born in South Dakota, a small rural town, actually, and I grew up on a farm, and that's where I lived until I went to college. And what else? More origin story stuff. What do I like to do? I guess a couple things I like to do. My family and I like to watch Marvel movies, so the ones with Iron Man, Captain America, all those people, and so we watch those a lot. And take pictures of my cats, believe it or not, and post them on the internet. So
about my story, I grew up in China. My hometown is Suzhou. It's a city near Shanghai. And one fun fact about myself. So while we are collectively preparing for the birth to this specialization, I'm also preparing for the birth of my first baby.
Yeah.
Which is quite a specialization in and of itself. So I grew up in New York, and actually was born in the hospital across the street from where I went to high school. 2 sort of interesting pieces of trivia. One, I'm an avid poker player, and so if I come to your hometown and there's a place you can play poker, the odds are you'll find me there some free evening. The other is I own an almost limitless collection of blue shirts. which in the first MOOC that I did was apparently a topic of great discussion as to, does he own any other shirt? And I had to clarify that, yes, I do. I own 12 of this exact shirt, and I'm very happy buying in bulk because I have no sense of fashion. But really, the one thing I want to make sure to close with is I have about the world's greatest job. I work with an amazing team of people that is just incredibly accomplished. You will see as we go through that the name GroupLens, either as GroupLens Research, or the GroupLens Center for Social and Human-Centered Computing, they all refer to the lab that we lead together, where we have about 24 students and a handful of staff to work in areas of social computing and human-computer interaction. And it's just been amazing over the more than 20 years of this lab to see the work that we've done, featured on the evening news, the New York Times, public radio, to see the people involved interviewed in all of the places you can imagine, radio book tours, startup companies, and some really impressive software systems. I'm not going to brag about all of the things. If you want to know what we do, you can go to grouplens.org and see a glimpse of that. But I will brag for a moment about the quality of people we've been able to attract. We have some phenomenal students, but really more than anything else, I have a bunch of phenomenal colleagues. Several of them have joined our group recently, and they're the reason that we decided it was time to come together and create this specialization for you. They're also really nice people that we enjoy working together. We're going to enjoy working together with Brent even when he heads southeast to Northwestern. And if you don't have a geography degree, that may not make a lot of sense to you, but it's true. And we think we're going to have a wonderful time with you over the next 20 or so weeks. And so we look forward to spending that time together. And we'll promise we'll keep the videos a little shorter than this introduction and maybe even a little less emotional as we go through. But we're going to launch right in with the structure and then the content of user interface design. We look forward to seeing you there.
Welcome back, everybody.
Now that you've met the faculty teaching this course, we want to go into detail as to what the course covers. And this is the chance for a first secret about teaching online courses. We're giving you the details here in a broken out video so that we don't have to change any of the substance videos that we have if we choose to add new topics and new assignments as we go along. You'll see this as we break things out into special videos that are easy to insert, remove, and replace as we go. So first and foremost, this is part of a specialization in user interface design. Specializations in Coursera have a couple of different formats. This format is 4 courses that will take you 4 to 5 weeks each. An intro to UI design, a user research and design, prototyping and design, and evaluating user interfaces course. And then a capstone project, which is a group UI design and prototyping project. And that will take you anywhere from 4 to 8 weeks, depending on how you coordinate your group and how quickly you move through the steps of the project.
So let's talk a little bit about the beginning of our course on user interface design. We're going to start out by giving you a basic introduction where we give examples of why you would want to study this, of what you can do with the kind of knowledge that you're going to gain from this course. We're going to go through various things that give you information about the process you'll be following that will enable you to produce good and useful user interfaces. And we're going to give you an introduction to some of the basic psychological and human factors knowledge that helps you understand the people that you'll be designing for.
Then, in our second course on user research and design, we'll go through a wide variety of methods for user research, from analyzing artifacts to interviews to going out there and observing people and their work and activities. We'll talk about how we take the results of that research, analyze it, and deliver it in a form that can be useful for starting a design process and evaluating your designs later. And then in the last part of that course, we'll start moving from research to design as we look at the process of ideation, of forming design ideas, and then idea selection, identifying the most promising designs to move forward to into the next stage of development.
In the next course, we'll actually really dive into how you're going to be creating your interfaces. We'll introduce you to some prototyping techniques that let you quickly get your idea into a concrete form so that you can immediately start to get feedback and iterate on them, on the ideas. We're going to give you some information about design principles and design patterns you can follow to create good and effective designs. We'll introduce to you the notion of a design rationale so that when you're creating a design, you're also, along with it, creating a good explanation of why it is that you made the decisions you made, why you think it's going to be an effective design. We'll also introduce the notion of universal design or accessibility so that you'll be aware of the challenges of dealing with diverse populations and you are able to understand how to create interfaces that can be used by wide varieties of people. And then finally in this course, we'll talk about different platforms and contexts of use, from mobile to different specific mobile platforms.
And in the fourth course on evaluating user interfaces, we're going to take you through two forms of evaluation, starting with evaluation without users, techniques that range from formal analysis of interfaces to walkthroughs to checklist-based heuristic evaluation, and then evaluation with users, including testing interfaces with users in a lab or in an informal setting, and all of the forms of field studies, A/B testing, what you can learn from log analysis and beta tests. Finally, the last piece of this specialization is a capstone project. The pieces you've learned so far will all come together in one group design project. Why a group design project? Because that's how design is typically done in the field. It takes many different points of view to put together an effective design. We will help form groups of learners and give you a list of topics you can choose from. And then you're going to go through a full iterative design cycle. You will be doing user research, doing an initial design round and prototype, evaluate with and without users, doing some revision along the way. And in the end, you're going to put together a design brief and a presentation using slides and audio or audio and video that presents your project and how that project responds to what you learned about your users, how it improved along the way, as a way to document what you did and complete the entire specialization.
So throughout these courses, there's going to be a number of recurring features. So first of all, there's 5 of us doing this course. We have diverse expertise, diverse methods, and so you'll get to see a little bit of that as we go. You'll also be seeing something interesting. We have interviews, a number of interviews with leading experts in the field, so you'll be getting even more perspectives. We'll also make good use of interactive discussion forums in the course where you'll be able to share ideas with other students, get feedback on your own ideas, and in some cases, do structured activities where we ask you to do something and we ask you to give particular types of feedback to others. There's going to be a lot of hands-on activities and assignments in this course, mostly peer evaluated, where you're going to be either analyzing things and then having your peers give you feedback on how good your analyses were, where they could be improved, or you're going to be producing something, a design, let's say, and then getting feedback from your peers. And throughout these courses, we're going to be following an iterative learning process where we're going to introduce concepts, demonstrate them in lectures, and often then you will do them as a standalone activity then, either through a peer evaluated assignment or in a quiz. And as part of that, you also will be evaluating what others do, another really good learning activity. And then after you've done this in the 4 courses, in the final course, the capstone project, you'll be going through all of the concepts and techniques that we've taught you in the first 4 courses and practicing them in a full context.
So we're presenting this to you as a complete specialization because indeed that's how we think of it and how we designed it. But we do welcome learners who wish to pick and choose topics as they come along. If you came in and said, you know, I really know this, but I'd love to pick up some information about user research or about log analysis, come, take advantage of those pieces. We're delighted to have you. We welcome people who want to browse, or we welcome people who want to take a specific course from the process. If you're going to take a course from the collection out of order, understand there's stuff you're expected to know as you get through. They were designed in order. And if you're going to take several of them, we strongly encourage you to take them in order. The one exception is the capstone. The capstone's not open to people who don't come through the complete specialization because we need people to work together in teams. And we need those teams to have the same common grounding so that they work through the same process as they complete that project. We do hope you'll see that the whole is greater than the sum of the parts. The parts are wonderful individually, but when you take this together, this specialization very much matches a typical undergraduate or introductory graduate level course in user interface design. And the fact that you get to see things demonstrated to you, done individually out of context, and then done in a project context very much mirrors the way that we teach students at the University of Minnesota, where we've taken those first 2 parts in a classroom, and a 3rd part out of the classroom, and woven them all together into this online format. So back to course 1. This is an introduction to your first course as well. The key concepts in this course start with what we would call the basic introduction. What is usability? Why does it matter? Over the course of the next several videos, you'll see examples of great interfaces, awful interfaces, immense successes and disasters to get you acquainted with the range of things that turn into problems with or successes with user interface design and usability engineering. We follow that with processes for ensuring usability. In this course, we'll teach you about a task-centered process, but we're also going to introduce you to many other processes, including ones that are design-focused, so that you're aware of the range of processes that are out there in industry practice. And then we finish this course with a topic on understanding humans, the whole notion of human factors, and of the basic psychology of perception, decision-making, and action are shortcuts that allow you to go forward and design for people without having to understand each and every person as an individual. Once we understand people's memory limits, people's ways of perceiving, we can use that information to craft it into our designs.
And in this course, you'll be doing 3 key activities. First, you'll be doing what we call a Hall of Fame, Hall of Shame interface analysis. And this is an activity where you look around, you notice an interface that you think is particularly good, particularly bad, and you give an explanation of why that is. Why is it good or bad? And you'll be sharing that with the class and getting feedback on that. The second key activity will be documenting tasks and walkthrough scenarios, where you're going to go through and actually develop a set of well-defined tasks that someone could do with an interface and procedures, specific steps by which they could do them within a particular interface. And then finally, we're going to do a third activity, a principle-based interface critique. Sort of like the Hall of Fame, Hall of Shame, where you're going to be analyzing an interface design, but in this case, you're going to be analyzing an interface design that we give to you, and you're going to be doing it specifically in terms of principles and concepts that we will be teaching you in this course.
So we're glad that you're here. We hope you will enjoy and learn a great deal from this course and the entire specialization.
And we'll see you next time when we introduce the notion of Hall of Fame and Hall of Shame interfaces. Welcome back. The topic for this video is an introduction to the concept of User Interface Hall of Fame, Hall of Shame. What do we mean by this? Well, this topic is really based around the power of specificity, of looking at particular examples of good and bad designs and developing a habit of observation, of noticing whether something is really good, bad, easy to use, or hard to use, and then developing a set of analytic tools to help us understand why something is good or bad and what makes it good or bad. Now, I'm going to begin by illustrating this concept with some simple real-world non-computer examples, about as simple as you can get, namely doors. And these examples are based on ideas introduced by Don Norman in his book, Design of Everyday Things. Now I'm showing you a picture, let's call this door number 1. It's a door that leads from my building at the University of Minnesota to the adjacent building. And the question I have when I look at this door, and I want you to think about this, is, do you think I open this door, door number 1, by pulling or pushing on it? Okay, you can think about that a minute. And then here's door number 2. This is the door that leads back from the adjacent building into my building. And do you think I push or pull door number 2 to open it? Now, if you want, you can go look back at door number 1, look at door number 2 again. And after you've given this a little thought, I can tell you that when I've shown these examples to my classes at the University of Minnesota, about 1/3 to 1/2 of the students guess wrong. Well, maybe I'm not playing fair. Maybe there's no problem here. So let's look closer here. If you look back to door number 1, you can see that somebody taped up a sign that says push to open it. And if you look at door number 2, somebody taped up a sign that says pull to open. So maybe everything's actually okay. Maybe figuring out how to open a door is a hard problem and you need signs to help out. But before you decide about this, let's look at another door. Let's call this door number 3. How about this one? Do you push or pull this door to open it? Well, when I show this example in my classes, pretty much everybody guesses right. You push door number 3 to open it. And if you take away that little graphic I had up, you can see there is no need for instructions on door number 3. And we can answer then the question I asked before. Doors should not need instructions. Simple things should be simple to operate, and if you need to provide instructions, that's a sign of failure. It's a sign of bad design. And there are design principles that can help us avoid failures like this. A powerful and simple one is visibility. The possible operations of a system or of an artifact should be visible, and their purpose and how you use the object should be clear. Now, this course is primarily about the design of user interfaces for computer systems, so let's take a look to be sure there's design principles that apply there as well. So here on this slide, you can see a very simple example. I brought up a menu from Microsoft PowerPoint. I had typed in some text. Is this a good design feature? I had selected the text design feature. Then I clicked on the font color picker tool, and I hovered the cursor over red, the standard color red. And notice all the small visual changes PowerPoint has made. The color of the selected text design feature has been changed to red. There's a small highlight around the red square under standard colors to indicate that's what I'm hovering over. And the word red has popped up. So now all of those subtle forms of feedback that you might not even notice are there to let me know that the system is reacting to what I'm doing and how it's interpreting what I'm doing. Now, this is an example of another important design principle, feedback. And the use of feedback, as I just showed you, made that a good design. The system provided visual clues or indicators that showed, as I said, how it was reacting to the user's actions and even let me know as a user that it was reacting to my actions. Now, we'll cover these and other design principles in detail in this course. These are scientifically based principles for analyzing and creating good designs, And we'll often base our learning around examples, both bad and good. And that is where the notion of Hall of Fame, good designs, Hall of Shame, bad designs comes in. They'll help us illustrate and practice these design principles and concepts and habits of observation that we'll be learning throughout this course. And that was it for our introduction to User Interface Hall of Fame, Hall of Shame, and that's all until next time.
Hey folks, in the last video, Lauren talked to you about this famous notion of a User Interface Hall of Fame and a User Interface Hall of Shame. In the next couple of videos, what we'll be doing is walking you through a couple of user interface case studies, some of which fall on the Hall of Fame side and others of which fall on the Hall of Shame side. I get the honor of starting out with a couple of case studies that are definitely on the Hall of Shame side. In fact, they are major user interface disasters. And the key takeaway from this video here is that design really matters, not just because it'll help your company make money or it will make your users happier, but also because it can save lives, it can prevent injuries, and it can prevent other major types of disasters. So the first small case study I'm going to be talking about is this one here. As I mentioned earlier, in addition to doing a lot of work in human-computer interaction, also do a lot of research in spatial computing. And this case study definitely falls at the intersection of those two topics. In this case, this is a Washington Post news story describing what happened. An elderly couple was going to meet their daughter in Brazil, and they typed in the address of where they were meeting their daughter. And it turns out the address of where they were meeting their daughter, that street name, there were multiple streets with that same name. They ended up going to the wrong one, and this one happened to be in a very dangerous area. And unfortunately, one of the two people in the couple was killed. Now, oftentimes this type of disaster is attributed just to the user, right? Oh, they didn't notice it was the wrong place. How could they be so stupid, right? But the design view is that we need to find ways to prevent people from making these types of mistakes, right? Every human makes mistakes. How can we prevent them from doing so? And in fact, one of the key principles we'll be learning later in the course is called heuristic evaluation. This is just one of the frameworks that we can use to analyze what happened in this disaster. But it's a very effective one, and it's also one that's very straightforward. Heuristic evaluation outlines 10 or around 10, depending on who you ask, different heuristics that we can use to evaluate our interfaces. And heuristic number 5 is about error prevention. And let me read it to you here. So heuristic number 5, even better than good error messages, is a careful design that prevents a problem from occurring in the first place. Either eliminate error-prone conditions or check for them and present users with a confirmation option before they commit to the action. So let's unpack this with respect to what happened to this Brazilian couple. Well, can we eliminate error-prone conditions? It's unlikely that we'll change all street names around the world so that each one of them is unique, right? Here in the United States, there are probably maybe tens of thousands, if not hundreds of thousands of streets named Washington, streets named Adams, these types of things. In many other countries, it's the same way. It's unlikely that we'll be able to give every place a unique identifier. Algorithms that can help you figure out which Washington Street you want, which Adams Street you want. These are getting better, and in fact, my students and I work on this problem. But again, it's unlikely that these are going to be perfect anytime in the near future. So the good news is the heuristic number 5 also tells us what to do, and this says we should check for these error-prone conditions and present users with a confirmation option before they commit to an action. So how might this look in the case of this Brazil situation? Well, they were using their Waze app. So you can imagine Waze adding a warning when you start routing yourself to an area, for instance, that has a government advisory, right? It says, maybe, if you don't live there, maybe you shouldn't go. So it says, warning, are you sure you want to go here? There's a government advisory against non-residents visiting this area. Then you have to tap, I meant somewhere else, or I understand the risks and I want to go here, right? So this probably would have saved that poor person's life, right? Design can save lives. Now, another way that design can save lives is this very famous case study in user interface design about the Therac 25 radiation dosage machine. Effectively, what happened here was the machine was designed in a series of terrible ways, one of which was its user interface. And ultimately, 6 people either were seriously injured or actually died because of this machine, right? They were going into the hospital to get healed, and due in part to poor user interface design, they instead were harmed. There were a series of problems with the user interface design, and again, with other parts of the system too. But some key lessons that came out of this was, again, trying to find ways to avoid errors. This system allowed a technician to deliver way more radiation to a patient than anyone would ever need, right? So had they built into the system a threshold, right, it would have been very easy to prevent those 6 major accidents. Another problem was system visibility. We'll be talking a lot about system visibility later in the course. The technician could not see how much radiation, or could not see very easily how much radiation they had delivered to the patient. And that's just extremely dangerous in that context, right? So if you can't see that you've already done a full dose, it's easy to say, oh, I don't know, I saw this light, this error message. Did the full dose get administered? Oh, it seems like it didn't. I'm going to give another dose. Speaking of which, very famously, there was a terrible error message in this machine that said that no dose had been delivered when in fact a dose had been delivered. A very deadly mistake, even though it's a small bug in code. There was terrible documentation. And then critically, this speaks to a lot of what we'll be discussing in the course. They failed to involve users in the design and testing of this machine, right? A lot of these problems could have been sussed out very easily had they engaged in some of the practices that you'll be learning in this course. Okay, the next disaster is one that's very recent. This happened as of this recording in late June, about a week ago. I know probably many of you, like me, are Star Trek fans, so we were very sad to learn that the new guy who plays Chekhov, Anton Yelchin, died due to what was called a freak accident with his car. And it turns out that this actually isn't a freak accident, right? It was a design error. And what had happened was he had bought a car that had a new type of gear shift, a car by Chrysler. And this gear shift didn't operate like typical gear shifts, right? Typical gear shift, you shift it up, the gear shift stays there. But in this one, it's more of a toggle. You shift it up, it goes, the little P or the R or the N lights up, but it goes back. So it goes back, it goes back. And it turns out this was a well-known problem. The US government had actually recalled a lot of Chrysler cars because of this. It confused people. They're used to seeing the state of the system very visible in the location of the gear shift, but in this car, the location is always in the middle. And this confused people into thinking that their car was in park when in fact it was in reverse or neutral. And that's actually what ended up killing Yelchin. And another example here, right, of how a poor design can lead to tremendously sad events. So again, here the key design lessons are about system visibility. We'll be learning a lot about system visibility. You always want to make sure that the state of your system is very, very visible to users. This matters for minor annoyances like figuring out whether or not you have caps lock on, and it also matters for potentially saving your life from your car running over you. Another design lesson that comes out of this incident is standards. So if you're going to change a standard that's incredibly important and incredibly common, like how a gear shift works, you have to be very, very careful. Chrysler has some great engineers. They probably thought they were very, very careful, but violating a standard, changing a standard, that's always something that's difficult to do. We'll talk more about the importance of standards later in this course. And then finally, had they just used the best practices in user-centered design like you're going to learn in this course, this problem probably would have shown up, right? Had they brought enough people in and done with user evaluation with these people, this probably would have shown up. They would have realized, hey, some of these users are having a hard time understanding what gear their car is in. Maybe, we shouldn't do anything major with this gear shift. Let's just use the standard one that we've been using for decades. Okay, so a lot of sad stuff in this lecture. I wanted to close with a UI disaster that wasn't quite so sad, or the impact wasn't quite so large. Earlier this year, an American made a very similar mistake to the Brazilian we talked about earlier. Instead of the same name, though, this person just typed in one wrong letter or slightly misspelled where they were going when they were visiting Iceland. And they ended up traveling from Reykjavik, which is in the southwest part of the island, all the way to the far north of the island, something like a 7-hour journey. When they left the airport, meant to go to their hotel in Reykjavik, 30, 40, 50 minutes away. They ended up going 7 hours away. And word got out, and this actually was very famous in Iceland. The Icelandic news came and interviewed this guy. He was in all sorts of newspapers and these types of things. He ended up getting all sorts of Icelandic delicacies from folks who wanted to have him over at their restaurant and whatnot. So I guess even though some of these disasters can lead to very bad things, occasionally can also lead to some humor. All right, with that, I will turn things over to our next case study, and I'll be seeing you soon.
Glad to be back. In this video, I'm going to tell you a bit of a historical story, perhaps a story with a moral about learning from other people's design mistakes and taking advantage of them. And it's a story about what are now ubiquitous, automated teller machines. The machines you go to get cash, today do many more things. But at one time they were not so common and in fact a little bit scary. So let's talk for a minute about early cash machines. Even in the late 60s, people were developing prototypes and deploying the very earliest of these machines, sitting in the walls of bank branches. The first one believed to be in England and then spreading in different places around the world. And they existed for one major purpose, so that you could get money when your bank branch was closed. If you wanted to deposit money, you would actually take an envelope, and if you were a business, a heavy fabric envelope, and you'd have a way to put this into a night depository where it would go into a vault and be open the next day. But to get money after hours was a big deal. I know this. I was growing up in New York City, and I remember that getting money from a bank was a challenge because banks were open bankers' hours. 9 in the morning till maybe 3 in the afternoon, Monday through Friday. If you were lucky, they might have been open till 6 one day a week and in the morning on a Saturday. And going to the bank meant perhaps taking time off from work or using up the few hours you had on a weekend. And if you needed money in the middle of the week, you needed some other way to get that money. For most of us, the way we got that money was that we wrote a check, often to a supermarket, where the grocer would cash your check as long as they knew you and you hadn't had problems. But that era was changing. And as I was growing up, we started to see some of these machines appear on bank branches. In fact, I remember one at a savings bank where I was living. And my father was one of the early people who got this special card to use the cash machine. Now, to tell you how paranoid everyone was, I have to tell you some of the rules of this machine. One, it didn't take money out of your regular bank account. You had to have a special account just for the money you might want to take out of the machine. You also had to have $200 in the account plus anything you wanted to withdraw. So that if you had $250 in the account, you could withdraw $50, but no more. Because no one was really sure if you might trick the machine into taking more money. And $200 was the most you could take out in a day, so that was a little bit of a safety valve. And by the way, a day meant a banker's day. So you could take $200 out over the weekend. But most of all, this bank machine, this cash machine, had all sorts of circumstances under which it would do something to protect itself and your money. It would eat your card. When would it eat your card? Well, you had a 4-digit PIN code, and if you entered the code wrong, I think it was a third time, it would keep your card. If you tried to withdraw more money than you were allowed, it would keep your card. If you tried to withdraw any money when you had under $200 in the account, it would keep your card. People had stories about the machines that ate their cards. And researchers had shown that at that time, once somebody had that card eaten, you could go back to the branch and get it back. But the majority of people who had their card eaten basically told the branch, keep the card, close the account. I don't want to deal with this thing. Well, there was a bank that learned something from this lesson. This user experience, usability lesson, was First National City Bank of New York. It deployed automated teller machines based on a DIP interface. That DIP meant that instead of putting your card into a slot and having it disappear and given back to you, you would dip your card in and pull it back out, as about half the machines today do. And they promoted aggressively the fact that your fingers never leave the card, so the machine can't eat your card. Now, this was remarkably successful. Now, we've got to go a little bit further than this. It wasn't just that the machine couldn't eat your card. They deployed them everywhere. They had a huge marketing campaign. They adopted a new name, The City Never Sleeps, and a new motto, The City Never Sleeps, and the name Citibank. They actually had originally been Citibank with a Y, then National City Bank, then First National City Bank, but they came back to Citibank. The person who was in charge of their ATM deployment, John Reed, later became the CEO of Citibank, largely because they did something that was virtually unprecedented in banking. They got huge numbers of people to leave their current bank and change to move their accounts to Citibank because they had understood that they could make getting your money easy and pleasant, and most important, comfortable and risk-free. So what do we learn from this study? A little design mistake can cause a miserable user experience. People hate the idea of having something that was theirs eaten by a machine. And if you do this right, maybe you too one day will come and become, the CEO and president of a top corporation when you learn from your competitors' mistakes and adopt user-centered design.
Welcome back. In this video, I'm going to give another user interface design case study, this time having to do with the Microsoft Office ribbon. So let's review what the ribbon is. So I'm showing you here just a picture of a screenshot of Microsoft PowerPoint. And the ribbon is this area at the top. It's a toolbar that contains a bunch of buttons and objects that you can click on. And the idea is that the ribbon is this strip across the top of the window that exposes what the program can do. And a key driving idea is that it is the single place to look for all the functionality in the program, whether it be Microsoft Word, PowerPoint, Excel, etc. And if you think about designing, if you're the person who's designing the ribbon, there's going to be a bunch of design challenges that the design team will face. And, there's a really nice blog online from one of the lead designers on the project that really goes through the background of the design of the ribbon, what they were thinking about, the problems they were facing, and how they went about it, and then talks through the final design. So if we think about the design challenges the team faced, there's going to be a lot of obvious things like, well, how do you design the icons? What is the rendering of the icons? What text they use, what fonts, what colors, how things are laid out, and so on. But I want to focus on one other particular challenge they faced. So which commands, which functions of the program should you include as buttons in the ribbon? So this is, taking up screen real estate. It's making a commitment or making an assertion that these are important things for the user to do. So how do you decide which command should get buttons? And if you think about it, maybe there's commands that don't need buttons. Like let's say saving a file. That's Control S in Microsoft. Well, maybe you don't need to put up a button for that because everybody just uses Control S, you might think. Same thing with things like copying and paste. Maybe you don't actually need to put up buttons for those things because everybody knows about like Control C and Control V, Control X for cut and so on. So you might think that at least. Now, how would you go about deciding which commands actually required buttons in the ribbon? Well, a good way to do that might be to ask yourself, well, which are the most popular commands that people actually use? Because those are good candidates for creating buttons for them. And how would you answer that question? Well, this blog that I was referring to kind of goes through the old way that they had been doing things at Microsoft, which was to basically use the intuition of the designers themselves. Now, you might have heard us already. You might recall that we've already talked about how you as a designer are not the users, that you need to use evidence. And the experience here really reinforced that. So again, this blog post sort of says, well, how would you decide which features people use the most the old way? Well, you'd ask experts who'd been around on the team for a long time, and the experts might say something like, everybody uses auto text a lot, or, no normal users like to save all the time. They just save when they're done. So those are the kinds of things that, intuition might tell you. But by the time they were designing the ribbon, they had a new way of guiding their design decisions. This new way was data-based, and data came in through what they called the Customer Experience Improvement Program. This was basically a feature that was introduced in Office 2003, Microsoft Office 2003, where users could choose to opt in, and if they opted in, a bunch of data about how they were using this system, Microsoft Office products, would be automatically uploaded to Microsoft. The data was collected anonymously. It couldn't be traced back to the users. And again, very importantly, it was opt-in, so it didn't happen automatically. And they collected all sorts of data, including all the commands that were used and how the commands were issued. Were they issued by clicking on buttons? Were they issued through keyboard shortcuts? Many other things. Now, at this point, I want to do something that the Microsoft Office designers did in this blog post that they wrote, which is to challenge you to think about, if you're a user of Microsoft Office products or similar products, what do you think the most popular commands are? And when the designers asked that question, they got a bunch of people who emailed them in to give them answers. Some of the people said, well, Control Z, undo is very popular because everybody tries things out and changes things. Or changing the format of text, bold and italic and so on. Some people might say, nobody uses cut or copy and paste. That's something people are not familiar with. Nobody likes to do print preview because it's kind of a weird concept. And those are all ideas that people have based on their own experience. Now, there's a great quote from this blog. The only difference between your wild guesses, the kinds of things that I just mentioned to you, and ours, that is the people on the design team, would have been that ours would have become reflected in the product. So designing a product based on guesses doesn't sound like a great way to do things. And Indeed, in this case, they didn't have to. They had data from the Customer Experience Improvement Program, and those data let them determine what were the top 5 most used commands in Microsoft Word 2003, which had been the previous, most recent version of Microsoft Word. And the answer was paste was number 1, save was number 2, copy number 3, undo number 4, and bold was number 5. 32% of all the commands issued in Microsoft Word were one of these 5 commands. And paste alone accounted for 11% of all the commands that had been issued in Microsoft Word. So pretty astounding. Now, more things that they found from the customer experience improvement data. They found that if they looked at Excel and PowerPoint, in Excel, 15% of all commands were paste, and in PowerPoint, 12% of all commands were paste. And after that, it was interesting. The data, the usage of commands exhibited what's called a long tail distribution, where a few commands are used a lot, like paste and save and the ones I just showed you. And then most of the commands are not used very much. They're only used infrequently by not that many people. That's the so-called long tail. And so if you go back and look again at what the Microsoft Office ribbon looks like, you'll notice at the upper left corner of the ribbon is a paste button. It's large, it's labeled, there's an icon, and this was put there specifically because they had data that showed that this was the most frequently used command. Furthermore, the data also showed that even though often people used Control-V to paste it, a keyboard shortcut, they also still very frequently used a button. They clicked on a button. And therefore, this design decision was informed based on actual usage rather than designer intuition. So if we collect the insights from this simple case study, the first thing I want to leave you with is that knowledge is power. The Microsoft Office team went from intuition-based to evidence-based design. And this is really crucial because people's design intuitions differ, and that means often people are wrong in their intuitions. And so it's much better to guide design with data. You will make better decisions, and it's easier to convince people, both within and outside your design team, that there is grounds for what you're recommending. It's also important to remember this long tail of command usage. And what that means for a product is, you might think, well, here's a command that's not very popular, so maybe I can get rid of it. But it turns out lots and lots of commands, even though they're not used frequently, in the aggregate, they're still used by quite a few people some of the time. And that helps explain why it's hard to simply cut down the functionality of a product. And then finally, it helps to be explicit. Once you have data, you can build a model or even a sort of an informal theory of how people will use your software. You understand what they do with it, and then that can help you make sure that the design that you create or modify will actually support what people actually will do with your software. So that's it for the Microsoft Office ribbon case study. Thanks for joining me, and that's it until next time.
Hello and welcome back. It is my turn to share one of my favorite success stories of user interface design with you. And I want to talk about the International Children's Digital Library. But before I talk about the specific system, let me posit this problem for you. So let's say I come to you and ask you to design a digital library for kids. In fact, let's even keep it simpler. Design just the search feature of the digital library for kids. So if this task was given to me before I learned how to do good interface design, I would have said, okay, no problem. There's lots of searches that I can just copy. So maybe if I have a search page, I just need a search box and a go button. And with the library, maybe I'll need to give some options for how to search, maybe by title or by author. And then once somebody does a search, all the books are going to pop up here. But oh, right, you wanted this to be for kids. So yeah, kids like color. So let's just throw some colors in there. And kids also like wacky cartoon mascots. So let's get that there. And maybe it can encourage them to read and stuff. So this is the approach that bad design for kids frequently takes. So it's kind of very superficial. It's just saying kids like color, kids like cartoons. Let's throw that in on top of an adult interface. And let me talk about an alternative instead. This alternative approach was taken by the HCI lab at University of Maryland in developing the International Children's Digital Library. So instead of guessing at what kids would like, or going with superficial features like colors or cartoon characters, they worked directly with children as design partners to understand how the children would design a library search feature. They called their intergenerational design partnership KIDS team, and it was led by Professor Alison Druin. She's a professor at University of Maryland. So this makes sense, as one of the kids team members said that making technology for kids without them is like making clothes for someone you don't know the size of. In this case, trying to make a library search without understanding how kids remember, search for, and explore books, that would have been unthinkable. So by going through this process, they found out that kids wanted to look for books in very specific ways. For example, kids remember books by the color of the cover, not the name of the author or the name of the book. They also may be looking for a book of a certain length because maybe they only have time for a short bedtime story, or maybe they need a long book for a book report. Or they may like books with certain types of characters, like kid characters or real animal characters or fantasy characters. This is really how children think about books and how children search for books. And this is very different from the kind of search that I would have come up with as an adult. Oh, kids also have this distinction between picture books and chapter books, which I think is very important for us to understand, and adults don't frequently understand. The result of this creative process is that the International Children's Digital Library has 3 million unique visitors. It has thousands of books in over 50 languages and is used around the world. It has been named one of the 25 best websites for teaching and learning. That's incredibly impressive for nonprofit research projects, given that most of it was really programmed by students. And by the way, the creative search is part of this success. After the site's creators analyzed the hundreds of thousands of searches done on the Children's Digital Library, they found that the visual kid design search was used 71% of the time, compared only to 10% of the time that people try to do the text-based search, the naive design that I presented at the beginning. So I picked this project for my case study because when I was an undergraduate in computer science at University of Maryland, I saw this project and it totally blew my mind. As a student, I thought that making cool technology was just about being a good programmer. I didn't think that it was about asking questions, working together, and being open to new directions. The Children's Digital Library project really opened my eyes and made me rethink my approach. My takeaways were that users may have a different way of conceptualizing problems, especially when users are different from you. Maybe they're kids, maybe they're experts in some topic, maybe they're elders. A good designer works to understand the issues from the user's point of view. And good design is made possible when working with users rather than trying to guess at what they will like or going for superficial features. If you want to find out more about this project, you can read more about it on the Kids Team Project website. This is through University of Maryland HCI Lab website. You can try out the digital library at childrenslibrary.org. And if you have access to papers through the ACM Digital Library, you can read Alison Druin's original paper on cooperative inquiry with children there. So thank you for listening, and I hope to see you in the next video.
Welcome back. I have one more favorite case study for you. It's actually a pair of case studies taken together that look at the example of user interface design as making hard processes easier. Now, we know that you as learners come from all over the world, but I'm going to use an example that starts out as a very US-centric example, though I know there are some other countries that have exactly the same problem. And the problem I'm talking about is tax preparation. A little background for those of you who may not do this yourself. In the United States, taxes are withheld when you have a paycheck. In some other cases, they may be withheld. But the amount that you owe is not a simple computation from what you earned. It's related to all sorts of other things, money that you may have earned from other sources like a bank account that paid interest or an investment or selling your house, a side job where you may not have to pay taxes, and an immense number of deductions. Deductions that you get for buying an energy efficient car or making certain home investments or paying taxes to your state instead of the federal government. All sorts of things come together. This is a table that I actually took from the U.S. Internal Revenue Service, and it estimates the average burden for people in preparing their taxes each year. And the average for all taxpayers, and most of them are much simpler than this, is about 13 hours of total time, of which 4 hours is just filling out the forms. For people who do the simplest form, what's called the 1040EZ, which means I don't have a complicated tax situation, they're still estimating an average of 2 hours just to get through the simple forms. And then they turn that into a cost based on the things that you do. But the important message here is that this is a burdensome enough thing that for a long time people have paid other people to fill out their taxes for them. Now, they still have to keep records, they still have to do a lot of the work, but just filling out the forms was immensely burdensome. I'm going to add a personal note here. I was one of those people who refused to pay anybody to do my taxes. And for many years, I took pride in the fact that I not only did it, but I did it by hand. I would get the forms, I would fill them out. And then a number of years ago, it's probably now between 15 and 20 years ago, I got immensely frustrated with the fact that while I was capable of doing the work, every time I would run into a situation that required a new form, I would have to go get the form. This time they didn't even have these online. You'd go to a post office or a tax office to get the forms, bring them back, start working again for an hour or two, and then suddenly it would surprise you and say, guess what? You need another form. And at that point I gave up and I decided to start using tax software. There's lots of tax software out there, but probably the most popular tax software in the US is TurboTax. I just want to show you a couple of examples of how they took something painful and turned it into an opportunity to make things work more cleanly. This is a set of screenshots I took from 2015 when I was preparing my 2014 taxes. And this is relevant because you're going to see some dates and numbers in here, otherwise it wouldn't matter. And so the first thing that's sort of obvious, but not obvious to the people who do this by paper, is that most of the things that you do in taxes are the same year to year. So the first brilliant thing they do, 60 seconds out of the box, is they say, gee, if you used our software last year, would you like us to start by copying last year's return and just wiping out the numbers? What does that mean? We'll have the list of all the places you got income from, your bank, your employer. We'll have the list of all of the charitable donations that you made. We'll know all the types of income and deductions that you used last year, and we'll know to go through all of those. Wow, that's a lot better than a paper form which just starts empty. Cool, I'd love to do that. And here it comes, and it gives me a bunch of information about me and my wife and the forms that we used last year. And the next thing it does is it comes back and it does what's probably, this is not the first version of TurboTax, but probably the way that all of these have come to realize is the best thing, is it says, you actually have choices. It doesn't say this, but you have 3 choices. It gives you 2 of them. One of them is to say, you take over. I trust the software. Just guide me through everything, one section at a time. Ask me all the questions you need to ask me. And when you're done, I'm done. I'll point out that along the way, as you put data in, it starts giving you information about your refund. If I had purchased the state product, which I hadn't yet for this, I did afterwards, It would show me how I'm doing on my state taxes. Come back to that. And when I'm finally done, it will do a wrap up and finish up and allow me to file. There's a second option, which is relatively newer in this product, saying I'll explore on my own. I could go in here, I don't have the screenshot from that, and it will give me a list of all of the kinds of income that I want to do, and then all the kinds of deductions, and say, go into whichever ones you want to do. What are you ready for now? What do you think you need to do? And you tell me what topic you want to cover, and I'll drive once you get there. I'll ask you when you say I want to look at employment income, we'll go through your employers and record your employment income. Now, there's a lot more in this that makes it a successful product. The key things: it simplifies the process. It turns something that was lots of paperwork into something that's somewhat centralized. It is immensely effective at reusing data. Now, I talked about one example of reusing data from prior returns. It reuses data from place to place. If you're filling out taxes on paper, there's lots of cases where you go to a form and it says copy the number from this other form, line 28, or fill out this workbook and copy the number that appears on page 25, line 16. TurboTax does all of that for you. That's what computers are good at. It reuses data from your federal return to your state return. Whereas if you go to a state return on paper right now in the US, it almost always starts by saying, get out a copy of your federal return and start by copying numbers. But it does other forms of reuse as well. One of the things that's been a feature that's added in recent years is the ability to look up much of the data if that data was posted to a national repository. So most employers and many banks and investment companies will put their data online, and you can get TurboTax to just go get the data and import it. And in fact, if you want to use their system to keep your books, if you run a small business, it will just import it from your small business software or your personal finance software. It makes your progress visible as you go along, and it integrates help along the way. I didn't show you this, but at every step along the way as you're going through questions, there's a list of possible help topics on the side and a place to ask or search for answers if you don't know already. They took a simple process. I'm going to take one more of these. And that's the process of buying secondhand tickets. Sometimes this is called scalping. In different jurisdictions in the US and frankly around the world, the rules about what happens when you've purchased a ticket to an event and want to sell it, or when you want to buy a ticket that somebody else has already purchased, vary. There are places where it's completely illegal. There are places where it's legal but not on site. There are places where it's regulated in different ways. But it was a pretty common practice, and actually still is a pretty common practice. If you wander up to a stadium in the US, in Europe, in many places I've been in the world, and don't have tickets, and maybe the event is even sold out, or at least all the good tickets are sold out, that there's a bunch of people hanging around with signs that say something like tickets, or I have tickets, or I'm buying tickets, or I need tickets. And these people are ticket brokers or ticket scalpers. They make a market by buying tickets from people who are trying to get rid of them and selling tickets, they hope, at a higher price to people who want them. But it's always been a sort of, well, how do we put this politely, sleazy market. You don't know if you can trust these people. For one thing, you're not always even sure that the tickets they have are real, or when you try to go to the gate, will they say, wait a minute, these were stolen, you can't use them, or they're counterfeit. You don't know if the price is any good. This was an opportunity where computers could make things better with an easy-to-use interface. And I'm going to just show you one screen from a site, StubHub, that has been one of the leaders, not the first, not the only, but one of the leaders in doing this. For those of you who like local information, I'm showing you a picture of StubHub for the Green Bay Packers playing at the Minnesota Vikings at their new stadium, US Bank Stadium, fall of 2016. This screenshot was taken in the summer of 2016 before that stadium opened. And the first thing you'll notice is there's a map of the stadium. There's a list of tickets for sale with prices. And I can actually hover over any section in the stadium and find out how many tickets are available at what price. I only did that for one of them here. This is among the better sections that you can watch a game from. And for just $2,850, I can get a ticket to watch this momentous and historic game. I'm not planning to go. $2,850, not $28, $2,800, a little beyond my budget. Actually, if I came over here, I could get tickets in this area for only $1,000. And in fact, this is sorted to show me the cheapest tickets. I could, if I wanted to go, and the problem, of course, is you sort of have to go with the family. You can't just take a ticket and go by yourself. But if I did want to go by myself, I could sit in the upper corner, section 303 or 302, row 21, for just $272. Okay, you're not going, I'm not going, but what do we learn from a site like this? For one thing, the computer system created visibility. Knowing what the going price is, and people who buy and sell tickets know that when you try to sell them early, you try to get a lot of money, and as the game gets closer, you see if you have to lower your prices. If I did have tickets, let's say I was lucky enough to have a bunch of tickets here, I would recognize that, wow, if I want to try to get money for them, I should probably ask for close to $3,000. That seems to be the going rate. That's useful to know, and I could watch that going rate. If I'm thinking about buying it, I'm not talking to a guy in the, on the street who I don't know and I don't know whether to trust. I can look and say, well, if this person told me there's nothing available, but I've got 2 tickets in the corner and there's only $600 a piece for the 2 tickets, I can look up here and say, well, buddy, you're full of it. I can see there's lots of tickets under $300. And they're just as good as those tickets. And similarly, with all that information, I can make effective decisions about where do I want to be on the field. In fact, if I select a subset of sections, it will let me sort. It will let me filter by how many tickets I need, other requirements that I might have. There's other properties I can look at, like do I really want to be on an aisle? Do I want to be in an enclosed section? Other things like that. It makes browsing convenient, and this is not something that was innovative for StubHub. The ticket sellers who were selling first-run tickets started doing this as well. Those of you who are older, like I am, know there was a time when you wanted to buy tickets, you had to go somewhere. And you'd go and you'd say something like, well, I need 2 tickets, what do you have? And originally there would actually be stacks of tickets, but in the first round of computerization, they'd say, well, the best we have is this. Here are the price ranges we have. And there was no good way to get a map of what was really available because what they said was the best may not be what I like. Maybe I'm willing to be higher up in order to be central compared to other people. Well, places like Ticketmaster and its competitors put in systems where you could see that online and you could actually even look at it if you were buying them in person. And that's evolved into systems like this today. And finally, you're seeing the idea of technology serving as an intermediary. The technology is connecting the seller and the buyer. That intermediary was always there most of the time. You could buy tickets through classified ads, but mostly people would feel they had to sell to a broker and buy from a broker. And now it's just a more transparent, easier, and sometimes even instant intermediary. So what are the lessons learned from these case studies? First, if you really want to make a difference, go find a painful process and make it easier. Second, when we talk about the user interface, It's really easy to think that all you care about is buttons and labels and menus, but the interface is about more than just the look on the screen. It's more even than just the usability of can I figure out how something works. It's about the control that a user gets. It's about transparency. It becomes an agent for building trust and much more. The interface is the way that your system interacts with people, and that's a huge step as you're going forward. Finally, if you're thinking about, gee, I wish I could do something innovative and successful, there are an immense number of opportunities out there. For every process that somebody has come up with a great solution for, there are still processes left out there that are sitting painfully difficult. Now, you could pick your favorite one. Maybe it's the challenge of getting a driver's license in a particular area and waiting in line in order to get a ticket so that you can wait in line. And could you turn that into a system that speeds it up and makes it more efficient for both the workers giving you the license and the people getting the license? Government processes often fall into this painful step. But there's also lots of private processes. And let's remember, that's where the big successful companies, the Amazon.coms and the others out there, they made their money by finding something that was a hurdle for people and removing that hurdle. Good luck, go out there, learn what we have to teach you, and go do great things. We'll see you soon.
Welcome back. From previous examples, we learned that product designer can specify functional and aesthetic features of a product interface in order to create a desired user experience. In this video, I want to discuss how to design user experience in socio-technical systems. A socio-technical system is a social system operating on a technical base. Examples of socio-technical systems include Wikipedia, eBay, Twitter, Facebook, and YouTube. Compared to traditional software or hardware product, designing the user experience in socio-technical system is quite challenging. Even if a designer wants a socio-technical system to be larger, to be more active, or more friendly in tone, he or she may not be able to make that happen. The reason is that people are the key factor that influences users' experience in socio-technical systems. People are interacting with other people in these systems. However, people's behavior, reactions, or responses cannot be shaped or programmed the way that the physical materials of software can. However, socio-technical system design is still possible. Today, I want to share two successful examples. The cases of Airbnb and Couchsurfing. Airbnb and Couchsurfing both help users host strangers in their homes. However, Airbnb and Couchsurfing have very different goals and try to promote very different user experiences. Airbnb describes itself as a trusted marketplace for people to list, discover, and book unique accommodations around the world. In contrast, Couchsurfing describes itself as a global community of people who share their life, their world, and their journey. In sum, Airbnb is more about providing efficient marketplace for people to rent their homes, while Couchsurfing is more about building a community of travelers. So, how the interfaces of these two platforms reflect and reinforce the different purposes of these two sites. So let's first see the interface of Airbnb. On the main interface of the Airbnb listing, first the users can see the price of the homes. Then lots of space on this interface is used to describe the features of the homes, like the space, availability, and safety features. Airbnb also encourages the hosts to upload lots of pictures of their homes. Also, users can see the neighborhood of the place. In contrast, Couchsurfing uses lots of space on their interface to describe the host's characteristics, such as their age, gender, languages, degree, education, and birthplace. Couchsurfing also allows the hosts to provide more details about themselves, such as why I'm on Couchsurfing, my interests, and one amazing thing I have done. Compared to Airbnb, Couchsurfing has a much simpler interface for hosts to describe their homes. And also, one interesting is that Couchsurfing actually only shows the city-level location information, not the whole address or neighborhood of the place. I believe that this interface design is on purpose, so that the users of Couchsurfing would pay less attention to the location, but more to the hosts. In this case study, we learned that good interface design in socio-technical systems can influence how people interact with each other on these systems. The interface of Airbnb reflects and reinforces the idea that Airbnb is a platform for people to find places to stay over, while the interface of Couchsurfing helps build an environment where instead of finding places, people find other people to stay with. Thank you for watching this video. I hope we can see you in the next one.
Welcome back, everybody. Today I'd like to give you a quick overview of your first assignment for this course, which is going to give you a chance to come up with your own Hall of Fame or Hall of Shame interface. So you'll remember at the beginning of the course, when I introduced this concept, I gave you a few examples of doors, a couple of which failed at a pretty basic requirement of being a door, namely, is it clear whether you have to push or pull the door in order to open it? We also saw a door that had no such problem. So I said these were 2 Hall of Shame doors and 1 Hall of Fame door. I also gave you an explanation of why they were good or bad. And at the same time, I gave you an example of a graphical user interface, talked through some of the features that, in my opinion, made it a Hall of Shame design. So I'd encourage you to go back and check out that video if you'd like to refresh your memory of that analysis. Now, what you're going to be doing in this assignment is to find an example of a design that you consider especially good or bad. So find your own Hall of Fame or Hall of Shame interface design. Write up a brief explanation of why you think that, then post the design and your explanation to the course forum. And after you've done this, you'll need to give feedback on at least 3 examples from other students, so to help you learn and think more and reflect on what is good and what is bad out there. Now, to help you out, I'm going to give another example. Well, actually, I'm going to give 2 more examples of systems. I'm going to call 1 Hall of Fame and 1 Hall of Shame. They're both websites of authors. And actually, this brings me to another point. Often when I'm trying to understand whether something is good or bad, I find it's helpful to look at multiple instances of the same type of interface design. So 2 social network interfaces, or 2 e-commerce interfaces, or 2 travel apps, or something like that. Because when I do that, I notice differences between the sites. I notice ways one site has done things, one app has done things that are different from another, and I start to then see that some of them seem to me to be better than others, and it helps me deepen my understanding and give me a richer basis for evaluating designs of this type. So what I'm going to do is evaluate, as I said, 2 websites for authors, and I'm going to start out by taking a look at the website for Suzanne Collins, who is the author of the Hunger Games books. Okay, well, here's Suzanne Collins' website, and so let's look around. So when I look at this, I guess the first thing I notice is, well, you know, there's lots and lots of empty space kind of right in the middle, and that's not too appealing. And the layout's kind of weird. I mean, I see this picture here at the top, a picture of her, and then there's this picture below it, which is the book cover for Mockingjay, the last book of the Hunger Games trilogy. Well, they're not lined up in any obvious way, and there's really no text here. Well, it says "Fly You High." I'm not quite sure why it says that under her picture. And Also feels like the most important information is not really front and center. So off to the side here, I see information about her books. And right at the top, it's a picture book, Year of the Jungle, and then another one, When Charlie McButton Lost Power. Now, I'm not familiar with those books, but I do know that Mockingjay, Catching Fire, and The Hunger Games, which are a little further down here, kind of in the middle of this area, are super popular. So it's not very obvious to me that this is a good way of organizing things. Over here, there's a welcome message that's just sort of semi-random information. Takes up kind of a lot of space here. And then, well, gosh, I can't click on these big images, so that's kind of too bad. It's kind of a not a good use of that opportunity. So especially if I see Mockingjay, I think I have to be able to click on that to get information about the book. So not a good design, I don't think. So unfortunately, I'm going to have to call this a Hall of Shame. Now I'm going to switch over and look at the author's site for Ann Leckie, who is the author of a really popular science fiction series called the Imperial Ratch series. And if I look at this, things look pretty different to me. So first of all, things look pretty nicely laid out. It's attractive, good use of colors, good use of pictures, I would say. Things sort of make sense. Here it says about Anne, a picture of her, and some bio information. That all makes sense. Latest news, well, that makes sense. I guess this is a link to her blog, and here's the latest blog post. Oh, and look, that's active, so it's a hyperlink, so I can go to that, so that's great. Over here is her latest book, so that's great, the book cover, and here's a little, I guess, summary of the book, or a teaser for it, so that's good. So I'm looking at that. The layout makes sense. The organization makes sense. Good use of pictures, I would say. What else? Discrete, well-defined areas. Here's the author area about Anne. Here's the area for the blog. Here's the area for her latest book. At the top, there's good tabs for navigating home, about, blog, books, bibliography, contact. So that all looks good to me. And I guess maybe another thing I can say when I look at this looks like modern web design. It sort of follows the conventions and norms that we expect websites to follow, while Suzanne Collins looks like it's a really old site that doesn't follow those norms, and frankly, I think wasn't as well designed even when it was first created. Now, there is one thing that does bug me a little bit. I wish that the image here for her book, Ancillary Mercy, was active. I don't know, it makes sense to me, but it's not. But if I go down, I can see, well, read more. And now I can find out more about the book. And even nicer, I can go purchase it here. So it gives me links to sort of all the things I want to do and find out about this topic. So definitely a Hall of Fame interface. Now, back to a last word about this assignment. A main goal of this assignment is to help you develop your power of observation, of noticing whether an interface design is good or bad, and to be able to begin to start explaining why it's good or bad. Now, coming soon in this course, and in later courses in this specialization, we're going to introduce you to more systematic concepts and principles that will enable you to give more focused, more formal evaluations of interface designs. But for this assignment, however, we just encourage you to be creative. Look around, see what looks good, see what looks bad, and have some fun. Well, that's it for the overview to the Hall of Fame, Hall of Shame assignment. Do go out and have fun, and we'll see you next time.
Hello and welcome back. Today we'll talk about the UI design process, and this will be the topic introduction. So what is a design process and why do you need it? A design process is a systematic method for designing user interfaces. It helps you increase the probability of success of your interface, and it helps you incorporate some best practices. There are a few key elements of the design process. One key aspect is that it's not just about the goal of designing for people to use your system someday. That's part of it, but it's also about including the users, including people into every stage of the design process. So it's really user-centered and is driven by the needs of the user. Iterative design is also a key part of this process. It's much easier to try to sort of take your first stab at the problem and then try to iterate on it and improve it to really get it right, than trying to get it perfect the first time. There are 3 parts to this design process. The place where people usually start is user research to try to really understand the problem and the needs of the users. Then you come up with some solutions and you prototype them. You evaluate your ideas and your solutions with users, and usually in this process you find that something is wrong and you need to go back to the stage of user research to again try to understand the problems and address them. And as we said, this process is iterative. You do it over and over again.
So at the end of this topic, you should be able to do a number of the following things, starting with identifying a set of different fundamental design processes for user interfaces and articulating the common elements of these user interface design processes. You should be able to compare design processes, identifying the assumptions behind each and the strengths and weaknesses of each. You should be able to identify the appropriate process for particular design situations and design teams. And you should be able to describe in detail the steps of the specific process we're going to be focusing on in this course, which is a usability engineering process known as task-centered user interface design. In particular, you're going to be able to draft and evaluate task and task-centered scenario descriptions, which we'll be teaching you about as we go forward in this topic. The structure of material in this topic starts in our next 3 videos with examples of the types of things you might need to be doing interface design for. We'll look at fresh design, where there's a problem without even a solution idea yet. We'll look at targeted design, where the solution direction is there, but it's not fleshed out into an actual solution. And we'll look at improvement, taking an existing solution where it's deemed to be for some reason inadequate and evolving that into the next iteration of a user interface design. Then we'll talk about the common elements in these processes, take you through an introduction to usability engineering and task-centered user interface design, including talking through the specific elements through which we're going to capture the user information that drives that design process. We'll take you through a tour of several other user interface design approaches, talking about the areas where they may be most applicable. And as we bring things together at the end, you'll have one assignment on creating some of the artifacts of task-centered user interface design, preparing you if you're going forward into the second course in this specialization, where we'll be doing that in more detail anchored to user research. And finally, a quiz on the design processes and how they apply, which will include within it a set of example situations and some questions about the merits and drawbacks of different processes for those situations. So sit tight, and we look forward to seeing you as we go through these design cases.
Hello and welcome back. So let's say that you want to design an interface to help somebody. You want your system to be useful, but you may not know exactly what problem needs to be solved to best help your users. This is actually a very common situation. Many of the most creative solutions are successful not only because they're good at solving a user's problem, but because they have identified the most clever problem to solve. In situations like that, your job as a designer is to find the right problem to solve. And personally, I found it really helpful to answer 4 questions. I need to identify my target audience and other potential stakeholders who may influence the context. I need to understand the challenges they currently face and the strategies that they're currently using to address these challenges. People are generally clever and inventive, so beginning with their solutions is generally a good idea. I think it's also really important to understand what values users have that influence the kinds of technological approaches that they may see as acceptable. This sounds a bit abstract, but let me give you a concrete example from my own research. Generally, my students like it when I provide examples from my own research in class, and I hope that you will find it interesting as well and not too outdated, even if you're watching this video maybe years after it was recorded. I wanted to help people who were trying to maintain recovery from substance use disorders. I knew that this was a huge problem worldwide, and there are many ways to approach it, but long-term recovery really benefits from a strong social support network. And for many, the most accessible and free way to find a group of like-minded people in recovery is by attending 12-step meetings. You've probably heard of these from movies or books. So these are meetings like Alcoholics Anonymous and Narcotics Anonymous. My research has always focused on supporting human relationships, and I thought that this was a fascinating context where strengths of relationships could mean the difference between recovery and relapse. My first step was just spending a lot of time with people in recovery. I conducted a 6-month study using a technique known as participatory observation. During the course of this time period, I attended 132 open 12-step meetings where I announced myself as a researcher. I also participated in 18 organizational service structure meetings at the group and regional level. I conducted a literature review of currently available technologies for recovery and reviewed and documented the artifacts of the program, like the bulletin boards, information pamphlets, and meeting scripts that were used in meetings. This immersion period really helped me understand who my audience was and begin having some ideas about the challenges that they face. To find out more about these challenges and the strategies they used to address them, the values my participants had, and just in general more about what their life was like, I conducted in-depth interviews with 12 recovering addicts and alcoholics. All participants that I interviewed had multiple years of continuous abstinence from drugs and alcohol and were very familiar with the program. Every participant who volunteered already used technology to support their recovery in multiple ways. For example, they might try finding a meeting online using a directory or an app. They took part in online recovery forums. They augmented in-person sponsorship with Skype or email. And they used apps that tracked various aspects of their recovery, like how many meetings they went to. However, one of the challenges is that it may be hard for people to discuss their values in general. Values are frequently implicit and in the background of our daily lives, and we don't really think about it until something feels like it's going against those values. To make it easier for participants to reflect and explicitly discuss values, I provided them with brief sketches and write-ups of 6 technology ideas that they could critique. Now, I'm not going to go through each of these here, but to give you 2 examples. MeetingSpot is a rating website, similar to Yelp, if that's a thing where you live, where people can discuss, review, and provide logistical information about the meetings they go to. RecoveryTube is like YouTube for recovery stories that lets people share their stories with others through anonymized animated videos and support its search, tagging, and commenting on these videos. Participants in my study were able to discuss at length which features of tech ideas they found appealing and which seemed like they would be problematic or may even go against the values of 12-step recovery programs. Based on this process, I was able to identify key implications to guide the sorts of problems I should solve. I began having a general understanding of how to design and how not to design for this context. I learned about the importance of supporting social interaction rather than just delivering information. I learned that anonymity in these groups is not just about protecting privacy, but rather about this idea that everybody in a meeting is equal. And I learned that face-to-face contact is absolutely at the core of these programs and should be supported rather than replaced with technology. These implications are tenets that I can use both in deciding which problems to tackle and evaluating whether a proposed solution is sensitive to the values and priorities of the community I'm working with. I could now take the opportunity to generate a diverse set of potential solutions within the constraints outlined by my formative work. Now, this is just one example, and this approach is really most relevant when you're looking for the right problem to solve. One thing I want you to notice is some questions that don't appear on this list. The naive approach is directly asking the user what solutions they want, what technology you should build, or for ideas on how to solve the problem. And these are just not the right questions to ask. Usually users are experts in their own lives, but they're not experts in technology. You're the technology expert, and knowing what's possible is a big part in figuring out the right problem and the right solution. You can't expect your users to have these answers for you unless they're very unusual users. Instead, work with your users to understand the challenges, strategies, and values. These are points where your users are experts, and these can really help inform your work. Use these points as inspirations and implications. So in this video, I gave you an example of a context where the designer didn't know what problem to solve at the outset. I went into detail in one such example. I didn't really explain all the methods, but you will learn a lot more about the specific methods and techniques for carrying out user research when we get into course 2 of this specialization. But I hope this video gave you a basic idea of when a more open-ended approach may be appropriate. You can read more about the described work with people in recovery from substance use disorders if you have access to the ACM Digital Library. I'm providing you a link on the slide. Thank you for listening, and I hope to see you in the next video. Hello and welcome back. This video continues our discussion of 3 types of user interface design problems. In this case, I'll discuss the situation where you already know the problem that you're trying to solve in the general direction where you want the solution to go, but you don't know exactly what the solution will look like. In situations like that, your job is really to try to find the right solution given the assumption that you've already identified the right problem to solve. If you haven't yet, it may be useful to watch the video on designing without a specific solution idea to learn more about some considerations in identifying the right problem to solve. Once you know the specific problem, I personally find it helpful to ask myself 3 questions. What are the key challenges that my solution must address? So, for example, knowing some ways that people currently attempt to achieve their goals, where do they struggle? Those are the areas my system should address. I also find it really helpful to consider a wide variety of solutions. Committing to a single solution too early may mean that you're not considering some viable and clever solutions that may be a bit more off the beaten path. And finally, we all work in the real world, which means there may be constraints in our solution space. So, for example, if you work for an iPhone app company, the constraint may be that your solution has to be an app, and it has to work with the specific sandboxing that Apple requires of their developers. So this sounds a bit abstract, but again, let me give you a concrete example from my own research. I find it helpful to talk about my research because these are examples that I really know inside and out. And I hope that yourself will find it interesting. And I also hope that it's not too outdated by the time you watch this video. It could be years after it was recorded. So first, let me tell you a little bit about the problem that I identified through the earlier process. As a result of many factors, primarily divorce, about 30% of children in the US don't live with both their parents. Now, you can probably look up the statistics for your country as they vary quite a bit, but this is certainly a problem in lots of places worldwide. In fact, a significant portion of children live in a different city from one of their parents. And even intact families may experience separations for reasons such as work travel, incarceration, hospitalization, and more. Continued contact between parents and children is really important for both sides, for both the parents' well-being and the child's well-being, but it's not usually easy. So I worked with divorced and work-separated families to find out why continued contact was hard. I found that they still use telephone as the primary way to stay in touch, but both parents and children seemed to dislike it. So it was really hard to keep the child engaged and interested in conversation over the phone, and it was extra difficult for young children because they hadn't yet developed these communicational competencies to understand the more nuanced and finer points of language, like irony or humor or fantasy. In co-located communication, they're really aided by these visual cues that they see on the person's face, but over the phone, things are more difficult. Video chat may be one way of solving this problem, but I found that it was still a long way off from being used routinely. So one problem that it was still too complex for children to set up, and it required the help of a co-located adult to actually set up the connection. And so what ended up happening is that most of that contact was scheduled. The adults would set up a time, then they'd bring the kid in, and they'd talk. And so the children very rarely actually initiated these connections. And in the end, both telephone and video chat suffer from a common problem. Sitting and talking is not the natural way to build closeness with children. Most parents and kids have their best interactions when they're actually doing something together, whether it's doing the dishes, helping with homework, or driving them to soccer practice. And so based on this process, I was able to better understand the requirements for a potential system to support the parent-child relationship. The system needed to provide visual channels for communication. It needed to be as easy to use as a phone, specifically so the children could do it on their own and without help. I wanted it to be something that they could do on their own and be empowered to actually initiate that connection. And lastly, the system couldn't just be about talking, it had to support activities together, preferably a wide variety of possible activities. So this is the very, very first sketch of a solution idea. Basically, we thought about combining video chat with something like maybe a smart board or a projector tabletop. And now we could have stopped here and just begun developing this idea. But generally, I feel that the better approach is really to try to take the time to explore the solution space and come up with a few alternatives. And also, this solution doesn't really consider this idea of it should be really easy to turn on and off and to actually initiate that connection. So we needed to come up with a few sketches to actually try to consider it. So the next step was really to understand the variety of alternatives available to solve some of these challenges. I think sketching is a really powerful way to articulate these early ideas and explore a variety of possibilities. It also lets you show your ideas to people to encourage feedback and discussion. So we'll talk a lot more about generating and communicating design ideas in other courses in the specialization, but let me give you a few examples. So first, there was nothing that said that we had to go with a smartboard. So we knew we wanted to stay horizontal-ish because many activities with kids occur on a table instead of on a wall. But we wanted to consider some alternatives. So what if we projected on a tent? We could project on the floor of the tent and even on the walls of the tent, so it could be kind of an immersive cave experience. Or maybe we could go simpler. Maybe a projector and a camera could be built into the light on a desk. And the video chat could just be on the tablet or laptop or whatever device the kid already has. Or maybe this could be like a special table or cabinet with everything already built in, so it's easy to learn and easy to use. Additionally, we also consider how to turn the system on and off. Now, early on, we decided that we didn't want to go with kind of a conventional way of doing it like a menu or a button, but rather maybe consider a physical approach because kids find that easier to understand. So we thought about this idea of maybe you could have doors that could be opened to initiate a call and closed to end the call. Or maybe you could have a roll-up screen, kind of like the way you would have one on a window. Or maybe it would be something that you could flip down to use, and that would initiate the call to the parent. Now, some of our ideas would actually be pretty challenging to implement. So we really focused on those ideas that met our specific constraints. So we had a few constraints. One was that our particular projectors were pretty large and required a few feet of space above the table that they were projecting on. So the lamp idea wouldn't really work for us. We also needed this to be very robust. And if you've ever done anything with kids, I'm sure you know why. They always do kind of things you don't anticipate them doing with the system. So it needed to hold up to everyday use by real children. We also wanted to support 3 key tasks, which we identified as being very important for our process with users. So homework help was seen as a very good way of parents providing care remotely. Reading together was something that both parents and children really appreciated. And lastly, play was really important for kids, whether it's a board game or a tea party or something else. And so as we considered this, the tent could be really cool for play, but maybe not, doesn't make as much sense for something like homework help or reading together. And so based on these constraints, we selected the option that really suited the needs of our users while still being something that we could legitimately make happen. The resulting system is called the share table. So a parent and child would each have a table in their home. It presents a dedicated connection, and it's as easy, if not easier, to turn on as a phone. Basically, to place or answer a call, you simply open the doors of the cabinet. It rings on the other side. If somebody else opens the doors there, it makes the connection. And to end the call, you simply close the doors. Now, in addition to this kind of simple, easy on and off system, each table consists of the standard video chat system, so like a monitor, speakers, webcam, microphone, and a camera projector system that allows video of one table surface to be overlaid onto the other. Now, in this video, I can't really cover testing alternatives or how we evaluated whether our idea worked in the end. There'll be future courses that address this. However, I do want to make the point that our idea evolved significantly from our first stab at it. The final system gave a lot more consideration to this idea of easy to use by incorporating the physical metaphor of cabinet doors. When we tried it out, we saw that it was very easy for kids to understand it, and it really increased the number of sessions that the children initiated without having to have the parents start the connection. Also, in considering options, we transitioned away from the rear projector to a top-down projector, which ended up supporting a lot of neat interactions, like being able to write on top of that worksheet and having that writing be projected on top of the kid's worksheet, or being able to play a board game and having the physical pieces be projected onto the cardboard game rather than onto the bottom of it. The point is that if you take the time to answer some questions in your design process, once you actually begin zeroing in on the design solution, you'll come up with better solutions. And once again, these questions are, what are the key challenges that your problem must address? What are the design alternatives available to address these challenges? And what are the constraints to which the solution must adhere? In this video, I gave you an example of a context where the designer knew a design direction and a problem to solve, but not the specific solution yet. I went into detail into one such example, and I know I didn't really explain all the methods, but you will learn more about the specific methods, like doing ideation and idea selection, when we get to course 2 in this specialization. But I hope this video gives you a basic idea of when you should start coming up with solutions and what questions you should ask about these potential solutions. Now, you can read more about the share table and what happened when we asked people to use it. If you have access to the ACM Digital Library, I have a few links for you here. So that's it. Thank you for listening, and I'll see you in the next video.
Welcome back. So now that you've heard about designing for a completely new system or a system where you've got some specific directions for design. I want to talk to you about designing to iterate on or improve an existing system. And I'm going to use a case study of the MovieLens system, which we've been running here at the University of Minnesota. In fact, we launched MovieLens in 1997, and I can't claim it was a great accomplishment in user interface design. It was an early movie recommender that stole its interface 100% from another movie recommender that was shutting down and told us if we were willing to get the system up and running, they would give us a bunch of data. And I'm not even going to show you that design because it was really quite poor, but we got it running in a month, and that allowed us time to start thinking about design and iteration. In order to make sense about talking about a particular system, you need a little background on its goals and its users. MovieLens has this weird set of hybrid goals. It's a movie recommender that suggests movies to people who tell us about the movies that they like and dislike, primarily by rating those movies on a 0 to 5-star scale. But it exists primarily to create a research system that we can experiment on these users with their consent in and explore new ways of doing recommendation, better ways to make predictions and recommendations. And so our goals are the goals of a research system that wants to retain its users. And our users actually are somewhat skewed for just that reason. They're people who like the idea of being part of an experimental system. And when we've studied them, when we've talked with them in focus groups and through their comments, we know that they value certain things a whole lot. They like the non-commercialness of the site. We don't sell them anything. We don't link them to anything to buy. They like the fact that they can trust us because we're out trying to do things right for them. And that all falls into the interface and the way that we design it. So the case I'm going to bring you is the design challenge of transitioning from the third version of MovieLens to the fourth version of MovieLens. And let me start by just showing you what that third version of MovieLens looked like. This is a screen of it. I'm going to blow it up a little bit, even though some of it won't fit as well, so that you can see it. And the things you should realize about MovieLens are that it starts with a little bit of information at the top about who's logged in and how much you've rated. In my case, I've rated 61 movies, and I'm the 56th visitor to the site in the past hour. A little bit of information about the movie scale from awful to must-see, and a central area which starts by showing me new movies. But if I'd rather see movies that were recently released on DVD, I can click there. Oops, we don't have any new DVDs at the moment. You'll see why, because this is the outdated version of the system. And a bunch of different things, question and answer, news and updates, almost all of which are fairly old. We'll come back to that in a minute. There's some recently edited movies, but the whole point of this was around a set of shortcuts and searches. And so I could get a shortcut and say, take me to top picks for me. And it would give me movies I've not seen yet that it thinks I'll like a lot, starting with Barry Lyndon, which I don't really know much about, but it's a Stanley Kubrick movie. Barton Fink, which I've heard a little bit about. It's a Coen Brothers movie. Casino, I actually know a fair bit about. Some of the Harry Potter movies. And this is really the heart of where most people would interact with the system. There are other places people would interact. You may notice that shortcuts took me into search. I could constrain this search and say I'm really feeling like I'm in the mood for a comedy right now. And when I do that, suddenly it suggests Sabrina, Lost in Translation, Meet John Doe. You might get the sense here that my own taste in movies may not match yours. If you think these are great picks, you might like my movies. But that's the whole idea, is that it was designed to be personal. And this was the basic structure of the MovieLens site for a fairly long period of time. This version of MovieLens was running, with changes as it went along, but for about 10 years. So what happened? Why did we need an update? The first thing is we started hearing from people that the site felt dated. There's a reason it felt dated. It was dated. It was a web design sort of for more than a decade ago. It's probably 15-year-old web styling. We noticed from our usage logs that many features were simply not being used. We built them with good intent, but people weren't clicking on them. And some of the features that we made very prominent were used very rarely. So we were using up good screen real estate for things that didn't make sense. It was getting harder to do research on recommendation because we didn't take people to recommendations overall right away. So we had a goal behind the scenes that we wanted people to get recommendations not just of what was new in theaters, but overall on their first screen. We wanted more recommendations, and that confirmed with what we heard from users that recommendations were why they come to a movie recommender. The new user experience turned out to be fairly complex. Now, if you look at this site, there's a lot going on. There's a whole bunch of shortcuts to things. And the place that most people wanted to go, search, was buried away. We used a bunch of screen real estate up here in the corner to teach people a 5-star scale that might have been necessary to teach them in 1997, but everybody knows that today. And they sort of get it. If you give them a 5-star scale, they get that 5 is better than 1, and 5 is even better than 4. So we've created something where we're helping people with what they didn't really need help with, and we weren't helping them enough getting to the core features of the site. So all of those were reasons for a redesign. There was one other reason that doesn't deal specifically with user experience, that we were redesigning the back end of the system. And as we did that, some of the interface features didn't make a lot of sense. We're no longer maintaining an independent database of movie content. A lot of this was built around the idea that users would edit that content themselves. So this was all a challenge. So what did we do? We decided up front we were going to have a 2-track strategy. We were going to keep MovieLens 3 up and running while we developed and designed first and then developed and deployed to volunteers a MovieLens 4. So this is a soft upgrade strategy. For a period of about a year, they could get a preview of what the new site would look like, and then they could go to the new site if they chose to, but if they logged in, the old site was the default. And then eventually we made the new site the default, but users who liked the old site could make that a personal choice. And really soon now, but not yet, we will hit the point where we finally decommission MovieLens 3 because it doesn't make sense to keep the software running to keep it alive. The other big step that we made was that we consciously accepted, maybe even embraced, a reduction in functionality. We had all these features that were not heavily used, and our decision was both for labor savings, but mostly for interface simplicity, we were going to cut these back. The ones that people did use occasionally and seemed important, we would implement, but we would demote to less prominent parts of the interface. And the ones that just didn't seem that important, we would not implement and simplify the interface with the idea that there will be feature growth over the next period of this interface, whether it's 3 years or 10 years. And we want space in the menu system, but also space in users' heads for putting those features in. Finally, we decided to gear our process completely around user feedback. That was true in reducing functionality, but it was also true in what we preserved and in where we put things. So let me show you what we came up with. This is the live system today. If you log in, and I'll make it a little bigger again, you get movie tiles so that the movies are no longer names, they're visual. Top picks for me, Band of Brothers. I can click on this. I can actually watch the movie trailer. I'm not going to do that here. That was a new functionality that people seem to really like. We have an integrated page with a lot of information and a much cleaner layout, including a lot of the feature that we'd had in community tags. But most important, that major screen, which is refreshing right now and recomputing recommendations, has a bunch of different categories that had been separate things. If I want to rate things, it's going to suggest a set of movies it thinks I might have seen. Turns out it's wrong. I've rated just about everything I've seen, but these were good bets for things that had a chance that might be helpful. Maybe some favorite movies from the last year that a bunch of people have liked and have given high scores to. Or those new additions, or even my wish list, which sadly I still haven't seen any of yet. So there is stuff that you can do, but a lot of things were demoted. You know, adding movies is now down near the bottom. Seeing my ratings, it's there. It's not something people did very often. If I want to get there, I can see every movie I've rated. I can even do better than I used to be able to do and say, well, I'd like to see the movies I like more than other people like them. And apparently, King Kong was not as popular with other people as it was with me, or among my favorites still is The Producers, which I don't know why they needed to remake it and put it on Broadway, but apparently, as I can see here, the average person only gave it 3.8 stars, and I gave it 5, which means I like it more than many people did. So you get the idea. We have a consistent design. It's built around these rows of tiles. We removed features. We added features. Let's just wrap this thing together with what we did in this process. So number one, user research, which we've told you and we'll come back to as essential in any user interface design process. Our user research, because this is a system we've been running for almost 20 years, focused mostly on user logs, user comments and discussion, the input we've gotten from our current users, and the substantial investment we had made earlier in calling people and bringing them in labs and studying them. We followed a two-branch strategy to make it easier to get user feedback on this earlier by putting out a beta version that was public, and then slowly transitioning so that what we've done most recently is gone to just a handful of users who still use the old version and contacted them individually to find out what is it about the old version that stops them from moving forward. What's their favorite feature that they're missing? In many cases, these were only the ones who really used the old version. There was a feature that we were able to reincorporate. In some cases, we were able to explain why we can't keep that feature around. In some cases, despite our best efforts, people just said, I don't know why I like it, it just feels right. Because the old system is comfortable, and that's something we always have to deal with when making a change. Just as you heard about in the case study about Microsoft and its major changes to the Office interface with the new toolbar. We also made some design shortcuts. We made an early commitment to modeling the interface on the more modern standard interfaces for similar systems. The idea that we needed visuals and we needed some sort of tiles was based on three things. It was the comments we'd gotten from users. It was our own experience seeing that learning time was a challenge and attrition was high because people really didn't want to interact primarily with text. And it was based on our recognition that there are now a lot of other sites out there that are using this similar interface, and that standardization is a good way of helping people transfer whatever they learned from one interaction to another. And then finally, our evaluation focused first on in-house walkthroughs, but then its greatest effort was on this public beta test, inviting people to try out the system and tell us what they think, watching what they actually used and what they didn't use, and incorporating that in as we iterated through our design. So that's our case example of designing to iterate or improve an existing system. I hope you've enjoyed this look at MovieLens. If you're interested in trying the system out for yourself, just search for MovieLens or go to movielens.org, and it's open, public, and free for anybody who might want to try it. Thank you. Welcome back. In this video, we're going to take you through the common elements in the user interface design processes that we'll be exploring in the rest of this topic. And specifically, we're going to talk about three common elements: user research, design and prototyping, and evaluation. Let's take these in order.
So let's start with user research. The goal here is really understanding in order to motivate the designs that you create. So you should know about the user's needs, their challenges, and their problems, as well as the kinds of activities they may try to do using your system. Users also have a set of experiences. They bring knowledge to the table. They may have specific skills, and you need to understand those in order to design for them. The technology that you build may be used in specific contexts, and that's very important to know if you're going to design for that specific context. Is this a situation where people are giving the system its full focus? Or is this a situation where they're distracted and using the system among many other tasks? That's just one example of context. You should also understand the current pain points. Why are users currently not satisfied with the approach? How can your system help? And in the end, all of this kind of works together to provide this potential for delight, to really help users use your system and really get used to it.
So if we think about different problems, there may be different kinds of information that would be useful as we explore our users. If we're designing a payroll system, we might want to know, is this somebody who enters payroll transactions one at a time as somebody makes a request? Or are they putting a batch in once a week or once a month and they're doing lots of payroll entry at a time? How does it fit into the work environment? Do some people do each of these and the payroll system has to handle, dive in, do one thing, get out, as well as people who might be immersed in it for half an hour or an hour? What does the person who enters payroll know about accounts? What does the person who enters payroll know about computing and the systems that we're using? All of this might be relevant in the payroll system. Or if payroll involves approvals, you may get into issues that come up when the person who does the approval doesn't really want to do that themselves. Do we need a way to delegate? Do they end up sharing passwords, which really makes the computer security people freak out? Do they need a way to do this when they're on vacation or they're mobile? All of this comes up with a computerized system. The MovieLens example of a movie recommending system or any of the movie watching systems, we would want to know where people use this. Are they sitting or lying on a couch? Are they watching on a mobile device or on a big screen? Are they with other people? It was the fact that we studied movie use and in an early version of MovieLens discovered that one of the things that turned people off was that they perceived MovieLens as selfish. It only looked at individual recommendations and couldn't accommodate a group. That led us to design a buddy system and group recommendations. So understanding your users and the users they may be co-using with becomes really important in a system that might be social. To use a third example, let's say you're trying to design a control system for smart home management. Any of you who've seen some of these systems know that all too often they're pretty hideously designed. There's large panels with lots and lots of different controls, and somehow they don't map to what people want to do. If you really want a smart home management system that's going to succeed, one of the challenges that you face is the question of who's going to configure it. Are you dealing with homeowners and residents who are going to sit down and actually program the button to say, this is how I say I'm going out, or this is how I say turn everything on, or we're going to watch a movie? Or is the configuring going to be done by a professional setup person, and the challenge becomes how do you communicate that configuration back to the user? That's obviously not the only question. There's a lot of questions you get about vision, about sizes and controls. I know when I looked at those systems, those buttons were so tiny it was hard to tell them apart in the dark. and yet they're the buttons you use to turn on the lights, which seemed a little funny. But all of these point to the fact that deeper understanding of who your users are and what they're trying to do will lead to better designs.
There are many ways to get user research. So for example, you can turn to generalizable knowledge. A lot of work has already been done in fields like human factors and psychology and social science. These can guide you in the things that users want and their limitations and the challenges that they may face with your system. You can look at research reports for specific user populations and domains of usage. For example, you can look up development stages for children to know what's appropriate for a 5-year-old versus an 11-year-old. You can look at usage logs if there's already an existing system that's providing you with data, though that can be very difficult because there's a lot of data to wade through and make meaning of. But in the end, I think the most important thing is the willingness and the time to actually have contact with real users, to actually see, observe them doing a particular task, interview them about their experiences, look at the tools that they currently use and how they currently use them, even maybe ask them to do some simulated tasks for you so that you can observe how they currently approach a specific task. There's, of course, tons of different ways of data collection, and we'll cover them more later on in the specialization. But just know that if you're willing to connect with users and to contact them, that's the best way to start doing user design.
But once you've done all this user research, you've only gotten halfway there in user research. The other half is delivering it to use in design. So part of the benefit is certainly just the learning that you do yourself. As somebody on a design team, the fact that you can come down and say, no, I actually know how these people work. I sat with them. I spent a week on a ship watching people use the navigation system. I know how they use it. Or I spent an hour with the inventory control person at the local supermarket understanding how they use the system. That's valuable. But the rest of your team also needs to know about these users. And that means the team needs documentation and artifacts that can help them understand the user and the user's needs. So collections of data can be useful, but actionable examples can be even more useful. What do I mean by actionable examples? Example activities. What are the things people do? As we were sitting here, a person was running a report to figure out what things do we not have a full week's worth of in stock. Oh, that's something that people do on a regular basis. And we learned by sitting with this person that he runs this report so that he can do an exceptional order for anything that's not coming in the next 3 to 4 days. Oh, that's how inventory control works. Or example user descriptions. What do we know about these people and the way that they use the systems that we're using? What do we know about their environment, about their context of use? We're thinking about putting together a movie recommender. Are people watching movies 2-3 times a week, 2-3 times a night, once a year? Do we have to handle all of those folks, or do the people who only watch movies a couple times a year not use systems like these? But also any notable highlights from your discovery process. They need to be written down in some form and communicated to the rest of your team so that you don't make mistakes that knowing this would have prevented.
So then you move on to design and prototyping. Design is the process of moving from that basic understanding that you might have gotten through user research through the exploration and ideation to really consider lots of different ways of solving the problems you uncover to concrete interface specifications. And so this is important. We don't mean kind of design, when we say interface specifications, we don't mean the kinds of software engineering requirements where it says there'll be a menu here and a button here, but more of the idea of what is this going to do and how is a user going to progress through the tasks to do it. There are many techniques for design. So a lot of these are grounded in design theory, and many of these kind of emerge through practice. And we're hoping to cover quite a few of these in the specialization.
And then prototyping is the practice of creating these interface implementations at varying levels of fidelity and varying levels of investment to promote the kind of exploration and evaluation that we want to conduct on our design alternatives. What we mean by different levels of fidelity are that you can have a prototype that's really not much more than a sketch on a napkin. With a sketch on a napkin, you can hand it around to members of your team and say, does this seem like what we were thinking about? You could even go to users and say, we're thinking about building one of these. Is this something that might be useful to you? Well, a sketch on a napkin probably isn't going to go very far, but it's low investment. And it might be just enough to figure out that that was a lousy idea. Now, if it's not a lousy idea, you may go the next step. You may develop a wireframe. You may develop more detailed sketches or storyboards. In some cases, you may get a running executable prototype, or you may even create a video mock-up of how the thing works. There's different ways that you can do this as you scale your investment and your commitment as you've gotten more and more confidence that this might be a way that you want to explore. But the whole idea of prototyping is that they're less expensive, less commitment than going out and building a full system before you've had a chance to figure out if it's the right system to build. And so we use prototyping to get that feedback, to do that evaluation before we make the huge commitment that it takes to build a system and make the mistake of building the wrong system really robustly.
Design and prototyping is always an exploratory process. So we don't talk about just one design, the one design and the one prototype you're pursuing, but rather about designs and prototypes in plural, because it's important to investigate alternatives in order to get to the right design. Professional designers actually invest substantial effort in learning design principles and patterns and cases that will help them develop those intuitions to get to the right first guess quicker. And we will be teaching some of these basic design principles to support your design. We will also depend on the encoding of these professional design practices that are already present in standard tools, templates, and guidelines that can help you get to the right design, to the design that looks really good right off the bat.
So our third element that's common in all of these processes is evaluation. When we talk about evaluation of an interface, we're talking about assessing the quality of a design, not in the abstract, but as it fits the users and their needs, with an eye towards identifying promising areas for improvement. So there's a lot of possibilities here. Structured techniques can allow a design team to evaluate a design even without users in front of them. They can walk through a design telling meaningful stories about how this fits or doesn't fit what we know about the users. They can use checklists to go find things that will or won't help as we go forward. An evaluation with users not only helps you find what are sometimes called usability difficulties, the idea that, hey, the person can't find the menu, they can't find the button, but as important can help identify mismatches or misunderstandings related to your user needs. So as you bring this sketch or prototype in front of people and say, well, let's see if this helps you with your payroll system. And they come back and say, I don't understand. It's asking me for who I'm supposed to be paying, but payroll isn't about users first. Payroll is about accounts first. You come back and say, uh-oh, we've got an issue here. Now, the issue may not be our system is broken. It may be you're trying to redefine it and you have a user who's locked in to an older model. It may even be an inferior model. But if nothing else, you have the issue of, well, how are we going to transition people into a new model so that they don't simply come in confused? That may be an issue of training. It may be an issue of interface, but it may also be that you just didn't understand the way that the accountants think about payroll. Finally, field evaluation and data collection, sometimes thought of as beta tests. Let's get this to a set of people and see what they do with it and then ask them how it works, can be an effective part of an overall strategy for evaluating products before a widespread launch. This is obviously a late evaluation. You have to have something that works. But as you're at that stage where you have something that works, getting it in the hands of a few trusted, known people who are going to give you constructive feedback can be extremely valuable.
So the key takeaways from this module and this lesson are the core components of UI design process. The three we covered are user research, design and prototyping, and evaluation. Now, of course, how these are balanced, arranged, or mixed, the order in which you do these may be different in different processes, but these key core concepts are present in all UI design.
Welcome back. In this video, I'm going to introduce usability engineering and task-centered approaches to user interface design, and it's a companion with the next video, which steps in more detail through some of the artifacts and descriptions that are created from this process. So let's start with the concept of usability engineering. It's a wonderful term, and it is the title of a book by Jakob Nielsen, one of the leaders in our field and a prominent consultant, who, among other things, is responsible for work on heuristic evaluation, a technique that we'll be mastering later in the specialization, but also in this whole concept of usability as something that's not simply an art, but that can be mastered as an engineering process. Borrowing from his book, the key elements of usability engineering boil down to know the user, designing and prototyping, evaluation and iterative redesign, and a pretty heavy embrace of standards, guidelines, and rules of thumb to make the design easier. If there were a simple insight, and this is an insight we've delivered before, it's that it's easier to improve an interface than to get it right the first time. And maybe if there were a second insight, it's that if there's something proven, use it. So the whole idea of usability engineering is, hey, if I follow this process, if I get my information, if I put together a design, I'll get something that is reasonable. And then if I follow guidelines and evaluate and work my way through, it will continue to get better. In fact, if you look at the work done by Nielsen and others, what it suggests is that at least for a while, you do get better. At some point, you might hit what's referred to as a local maximum, a point at which you can't get any better with the design that you have, and you might have to throw things entirely away and start over. But that's a major dislocation that often is not necessary, especially with the kinds of applications where somebody's trying to just get a piece of work done. The places where you just throw things away and start over are often in innovative consumer ideas where you'd say, I've made the record player as easy as I can possibly make it. Maybe the solution next is records aren't the answer. I need to move to tapes because I can do things with tape I can't do with records, or I could do things with MP3 files that I couldn't do with compact discs. Task-centered user interface design is a specific usability engineering style process based on the book by Clayton Lewis and John Riemann, which is a freely available book. You have a URL for it here. We encourage you to read it online and to refer to it as we go through the relevant parts of this specialization. Its particular focus is on capturing information about user tasks. Specifically, these are task descriptions, descriptions of things users seek to complete using the interface. So an example might be, I'm looking to put speaker notes into my slides. That might be a task, and we'll see that we get a lot more detail than that. And scenario descriptions, descriptions of the sequence of steps that a user would carry out to complete each of these tasks for a particular interface. And we'll come back to those in more detail. Now, I do want to avoid some confusion because task, scenario, and all of these terms are heavily used in the field of user interface design and human-computer interaction. Tasks are described and are slightly different in a bunch of different techniques. Task analysis is a user research technique that frequently refers to figuring out what people do and breaking it down into its smallest constituent components. When we talk about tasks, we're going to be talking about them in this larger set of what's a whole thing somebody wants to do. The task isn't to select a menu item. The task is to, archive a file, or the task is to update a calendar or some other reasonable higher level object. The term scenario is frequently used for a use case or a usage story. And because that one is commonly used even within this course, we're going to try to keep these terms clear by context, and we'll also use the term TCUID, or Task-Centered User Interface Design Scenario, when we're referring to the sequence of steps. So let's understand how this task-centered approach changes the process of user interface design. First and foremost, user research has a focus around gathering tasks. You spend a lot of time with users understanding what is it that they currently do, what is it that they can't do but they wish they could do, what is it that they have to do but might wish they didn't have to do, and understanding the TCUID scenarios, the action sequences for their current solutions to these tasks. How do they go about them today? And where does that identify possibilities for improving the interface? Now, that doesn't mean there's an existing system we're trying to update. They may go about things today in an entirely manual process, as we'll talk about in the example in the next video. Next, TCUID uses the tasks heavily in the design and evaluation process. Designs revolve around how are we going to make sure that these tasks are completable in an efficient way. Evaluation includes walking through the tasks, user tests on the tasks, and in fact, when we do comparative evaluation, we will often look at the scenarios, the action sequences, for two different interfaces with the same task. Now, this has benefits, it also has weaknesses. One of the key benefits of task-centered user interface design is that it's something that's highly usable without extensive design training. We've been teaching students, undergraduate and graduate students in computer science, in software engineering, and in other disciplines to get their designs working through a task-centered process for more than 20 years. And what we found is that virtually all of them can master this process in just a matter of weeks. That's important when you're getting going in user interface design. It also does a really nice job with what I'm going to refer to as work-like, or really task-oriented interfaces. Systems where people are trying to achieve a specific objective. These aren't just business systems. They might be an automated teller machine where my objective is to make a deposit or get money. They can be retail, where my objective is to make a purchase or find a product. Configurations, I want to get my home network working. But this also relates to the weakness, that when something is not task-oriented, this technique doesn't work very well. If your goal is awareness, I want to know what the important news stories are at all times, there's no task I'm achieving. I don't want to say, I want to find out what's in the news now. I want awareness, and that awareness might be a mix of a speaker sometimes telling me something important and a screensaver scrolling things by. Task-centered user interface design won't work very well there. Many games are largely not task-oriented. They may be immersive and experiences, but not a, here's something and I'm looking for the right way to do it. Some games are task-oriented, and many games have task-oriented parts. Other entertainment uses, social connections. Now, if you were to take a system like Facebook, are there things in it that are task-oriented? Absolutely. The idea of how do I friend somebody? How do I find out something about one of my friends? That's all very task-oriented. But the perhaps principal use of Facebook, the feed, where my goal is I want to be up to date on the lives of people I care about, that's not necessarily task-oriented. There's not a correct way to do that. And so other techniques turn out to be more useful when you're trying to evaluate interfaces like those. So that's your introduction to usability engineering and the task-centered user interface design approach. In our next video, I will be back taking you through some of the steps in more detail. Welcome back. This video talks about capturing information about users and their tasks through use cases, personas, tasks, and scenarios. It's the second part of our material on usability engineering and task-centered approaches. Specifically, we're going to step through these 4 ways of documenting information about the use of an interface and the users of an interface. I'm going to start with use cases. Use cases are stories that motivate and perhaps capture design. Sometimes they're called scenarios. We mostly won't use that term to avoid the confusion with the task-centered user interface scenarios, which are individual action sequences. For our purposes, you can think of a use case capturing the essence of use, or maybe the quintessential use that motivates why this is an exciting thing for us to build. It includes the application and something about its context, and they're usually just a couple of paragraphs long. So let me give you an example or two and we can talk through them. So Ben is an 11-year-old looking for a birthday present for his younger brother. He isn't going to buy it, just ask his parents to do so. He's already fairly experienced with online shopping on eBay and Amazon, but hasn't really done much shopping for gifts. He knows that he's trying to pick a Star Wars Lego set and that he needs to keep it under about $50. He goes to Amazon because he's pretty sure they have a large selection and low prices. Once he's there, Ben searches for Lego Star Wars, and as he's typing, the interface lets him select a category, toys or video games, for example, but he just searches overall. There are over 2,000 results, so he decides to narrow it down by searching for toys and games that are $25 to $50. The search criteria are easy to find on the left of the screen. There are still over 500 selections, but the first few look good, and he puts them on his wish list and closes the browser so his brother won't see them later. What do we get from a use case like that? Now, this is obviously a use case for a retail site like Amazon. We get a bunch of things. We get a sense of a type of user and what they would need for this site to work. We get some constraints that the person here knows what they're shopping for, knows the price range, doesn't really know how many things are out there, and that 2,000 results is too much to look at, but that if the first few all look good, the person doesn't feel the need to look at all of them. We get a lot of the sense as to why we might be really proud to have built the search facility for Amazon or the product recommender that put good things there in the first place. We would be proud of this example. Here's another example for something that doesn't exist yet, but maybe with enough of you taking this class, one day it will. So Joe is notoriously bad when it comes to arriving on time to meetings. He tends to schedule meetings back to back and never leaves time in between for running late, transit, etc. Smart Calendar is a new calendar system designed to help people like him. It integrates with Google Calendar, but adds 2 features. First, it automatically inserts travel time between meetings if they're not in the same place. And you may notice that the calendars already have a notion of place. Second, it offers a set of options for preserving transition time. Joe has selected Preserve 10 minutes after meetings, which automatically adds 10 minutes after meetings that are marked as busy to prevent being scheduled. Now that he's better about being on time, he's exploring the lunch scheduler feature to ensure that he has a 45-minute break for sometime between 11 and 2 each day. Now, I'd be seriously hiding something if I didn't say there was some relationship between this mythical Joe person and my challenge with calendars, which is that if you meet somebody from 9 to 9:30 and the next person from 9:30 to 10, and 10 to 10:30, and 10:30 to 12, and 12 to 2, you're late to every meeting and really hungry at the end. And yet, this might be exactly the sort of use case or story that gets a designer thinking about what it's going to take to make Smart Calendar really work. Okay, second, we're going to talk about personas. Personas are embodiments of user research into synthetic representative users. Let me take those pieces separately. They're research driven. You don't simply make up a persona from thin air. You get a persona by studying ideally large numbers of users, but at least several users in depth. Personas are narrative, and they describe model users that were derived by taking the set of types of users you have and breaking them down to find some relevant clusters. So we talked earlier about the idea of a payroll system. I might discover that I have clusters of relevant payroll clerks. There might be, Nick the novice who just started doing payroll last week and doesn't know a whole lot about the system, and all the terminology is still hard. There might be somebody else who's Emma the experienced who does all of this. We might have Billy the batch processor who's not willing to do things one at a time, but always collects a whole bunch of things and runs through them, not necessarily in order, as a way of trying to do them all together. These would emerge from the idea that I've actually clustered the users I have, I've identified clusters, and then I create an evocative or descriptive representative for each cluster. So an example persona, I actually have a couple examples here. If I'm thinking about the domain of a travel reservation system. Sarah, name in quotes, is a graduate student living in Minneapolis. She travels by plane about 3 times a year, about half of that for conference trips for her university research group. When she travels on her own dollar, she's very price conscious and wants to get the lowest price, even if that involves obscure routes or indirect trips. When she travels for the university, she's happy to let their staff make the arrangements. As a computer scientist, Sarah knows all about search engines and other computer systems. Sometimes this makes her skeptical that the system may be hiding the best fares, and I could keep going with information I've gleaned about tech-savvy, low-budget travelers to put together one persona. Or I might have another one for the same thing. Larry is a retired grandfather living in New York. He uses a computer mostly for email and occasional documents and shopping. He also has a smartphone that he uses mostly for calls and email. He travels frequently, maybe 6 to 8 round-trip flights per year, but almost never makes his own arrangements. When he travels, he's mostly concerned about schedules, particularly avoiding traffic to and from the airport, traveling on airlines where he has points, and then price. He likes to use points as soon as he can after earning them. He understands he should be more knowledgeable about making his own arrangements, but has always found online reservation systems too complicated to get started with. He doesn't understand all the fields and questions he's being asked. He isn't dumb. He even does his own taxes and those of his relatives, but he doesn't like the feeling of being asked for something he doesn't know or understand. Well, you can imagine that with these 2 example personas, we would have some very different criteria that we would use as we critique different interface possibilities as we go forward. And one person here is very price sensitive, the other one is convenience sensitive and focused on using points. These are going to be very different as we go, as are their technical abilities. So what's a task description? It's a description of a complete job that specific users want to accomplish without being tied to how they would do the job. It needs some typical details. It might need to cover transitions between subtasks. But what's really critically important, and what we will be evaluating you on and you will be evaluating each other on, is that it not dip into how, it focuses on what. And let's be honest, the difference between what and how is not always clear. We're going to use some examples to illustrate this. So Professor Konstan receives a call from a university in Austria asking him whether he could teach a class there next May during the 3rd week of the month. He should check his calendar, see whether he has any conflicting events, determine whether any of them will prevent him from committing to this trip. If he can go, he should enter the trip in his calendar with enough time to spend the entire week teaching and therefore arriving by Sunday and leaving no earlier than Saturday. Why is this a task description, and for that matter, a good task description? It says what to do. It doesn't say how. I could do this with a paper calendar. I could do this with Google Calendar. I could do this with a wall calendar if I have that. It has some interesting details that might turn out to be very relevant. The fact that I got a phone call means something. It means I'm on the phone. If I'm on my cell phone, and my cell phone is to my ear, and my calendar is on my cell phone, this may make it difficult to do this. The fact that it talks about the 3rd week of the month means I have to be able to look at a month view in order to understand what the 3rd week of the month is. It may be incomplete. Maybe it's not clear which month is the 3rd week of the month, and I might have to look at that. And it has multiple parts of this. Let's look at things. Let's enter this into my calendar. But the real test as to whether this would work as a task is, could I ask somebody to do this if I sat them in front of a calendar system? And this is something I could ask somebody to do, at least for themselves. Here's another example. Ellen has been using a fitness tracker for the past month and has been happy with how well it tracks her steps, but not so happy with the fact that she's mostly learning how few steps she's taking a day. She decides it's time to connect with other people. She knows her sister who gave her the tracker and her mother both use the same device, so she sets up the fitness tracker to share daily fitness goals and achievements with them. She already has their Facebook IDs and email addresses. Again, it doesn't say how. It might not even have every detail, because this may be a task where the details themselves are exploratory. Now, this isn't something you could do on paper. It doesn't make sense to define this task so that one of the valid solutions is, well, once a week, Ellen's going to put them in the mail, put a stamp on the letter, and it goes out there. That won't solve the purpose. But this will work whether you can do that sharing on the fitness device itself, on a cell phone app, on a computer. And that takes us to our last type of artifact, the TCUID scenario. It is a specific instance of system use for a specific task, a particular interface, and it says what the user would do in detail. So for instance, click on the calendar icon, hit Next Year button to get to May 2007. Why is that 2007 instead of 2017? That's a really delightful typo, but we're going to leave it in just for the fun. Click on and so forth. Or open the fitness software on the desktop computer. Select Share under the Options menu, and so forth. We're going to give you a specific example of a scenario in the assignment in this module of content. And so I'm not giving you very detailed scenarios here because, frankly, they're fairly boring. They're supposed to be boring. But we will give you examples, and you'll be going through a number of examples in the exercises in this module. The key to these scenarios being right is that they match the granularity of what a target user could do without understanding the task. So you might say, is it okay to say, save the file when, or do you have to say, click on the File menu and then select Save? Or do you have to say, move the mouse to the word in the top left of the screen that says File, press the button down, hold it, pull down until you get to Save, release it? And the answer is, it depends on what your target user could do if you gave those directions. If you've just invented the pull-down menu, you probably need to say go, press, click, pull. If you didn't invent that, but instead that was something that everybody knows, it's enough to say, go to File Save, or if Save is always under File and your users know that, to just say Save. That's going to become pretty clear as we go through lots of examples. Clicking on a calendar icon is something we'd expect somebody who uses an online calendar to do. We could even say open up the calendar, and they probably know how to do that. But if they've never used the calendar, we might have to give them more details. So again, the properties of scenarios is that they're interface dependent. They bring a level of detail that's appropriate to the user, task, and interface, and they help bring together some of these issues about what the tricky parts of the interface are, which design might be better for something. They can be extremely useful as we go forward. So how do these come together? Use cases most commonly are aspirational and inspirational. They're a way of taking the inventive vision behind what you're doing. How are we going to make life better, help people, and capture that in a way that you can communicate them not only to your design team and your marketers, but even to prospective customers and users. Personas are going to guide the design team. They typically need enough of them to represent diversity of users, but not so many that it becomes silly. Many teams may have 3 or 5 or 6 or 7 in a complicated situation. They're not going to have 45 personas and go through these arguments saying, well, I don't think Mike could do that. Wait, which Mike? Mike the one who did this or Mike the one who did that? That doesn't make sense. In fact, persona using teams tend to treat personas as if they were real people with names. I've even seen ones that have created fake faces or pinned them up on the wall. And they engage these in the discussion, not talking to the personas, but about them. Do you think Mike is capable of doing this? Would Larry be intimidated by the fact that we're using 3-letter airport codes? Would Sarah be upset by the fact that we want to show nonstop flights first because that's what most people use? Does she need a way to customize it to show cheapest first? Tasks outline system functionality. They're not requirements because they're not complete, but they're representative and important. They also serve as a basis for evaluation, particularly as we walk through the tasks and see how well the tasks can be achieved, and then ask people to try them in user testing. And a complex system may have tens of tasks. If you get to the point where you're documenting hundreds, you probably have moved away from representative and important, but it's quite reasonable to have a couple of dozen if the system has a lot of different things people use it for. Scenarios then document the different designs. They may document the current state of practice, what's the current system, and they document the different alternatives that have reached a stage of prototyping where you can create a scenario. And they can be used as part of your evaluation as well, in formal methods like action analysis and in walkthrough evaluations as a way of documenting the intended design solution as you go forward. So this completes our introduction to use cases, personas, tasks, and scenarios. As we move forward, we're going to look at some other techniques for user interface design.
Hello and welcome back. The goal of this video is to get you to become more familiar with an alternative approach to creating interfaces, which is the design-centered approach. I want to introduce you to some key concepts and methods in design-centered approach. The 6 ideas I really want you to know are intuition, dialogue, inspiration, disruption, process, and critique. I want you to know these so if a colleague uses these terms, you know what they mean in the context of design-centered approach. So let's get started. The first of these concepts is the idea of design intuition. This basically means the designer can make better initial guesses about the best approach by relying on years of experience. While other parts of this course assume nothing about you and your previous training, but simply give you a series of steps or guidelines to follow, the idea of design intuition makes a specific assumption about the person carrying out the design. The assumption is that the designer has had years of studio experience and apprenticeship in the UI design process that has allowed them to develop expertise to make good design judgments. Intuition assumes that the designer has both innate talent and significant training. The second concept I want you to remember is that of dialogue. While many user-centered approaches treat the user as a source of data, the design-based approach may focus on the user as a design partner. For example, in this photo of adolescents, they're contributing to the design. Or as in the case study of the International Children's Digital Library that I shared in an earlier video, children may be actually incorporated as partners in the design process. Now, there are two things that characterize this design process as dialogue. First is that users are not merely involved in a single stage of the process, but rather in every step of the way, including potentially the analysis and how the designers make sense of their contributions. The other is that, maybe a little bit unusual, is that the materials that are provided to the users may not be about getting their feedback on potential designs, but rather about provoking a response that may lead to that richer dialogue. So, for example, the designer may on purpose deliberately provide a set of terrible solutions in order to get the users to engage in the dialogue of why these solutions are bad. And this is not something you see typically people outside of the design-centered process doing. That brings me to the general role of data in the design process. Instead of using empirical data to directly drive design, designers may collect user data in more broad and inspirational ways. For example, on this slide, the users may be provided with coloring books, worksheets, and cameras for sharing their experience and responding to specific prompts. Now, it's not that these photos or drawings will lead directly to the system that will be built, but rather that this method can challenge the designer's assumptions, feed this dialogue that creates with the users, and provide inspirations that lead to the designs. The designer's intuition is key for transitioning from data to inspiration to designs, and the path is not necessarily obvious to an outside observer. Frequently, the role of the design-centered approach is really to challenge and disrupt the current approaches in the field. Designers may deploy systems that are purposefully disruptive to reveal critical seams or problems with current approaches. If there are assumptions that current systems make as a rule, design-centered approaches may focus on identifying and challenging these assumptions. In the end, design-centered approaches really value providing considerations for some of those crazy design ideas that may have otherwise been left off the table. The fifth concept that you may hear described if you work with designers is that of process. Documenting and justifying the design alternatives and decisions that are made along the way is a big part of being a designer. As I mentioned before, when a design is driven by intuition and inspiration, it may be hard from the outside to see how these decisions are made. So documenting the process is supposed to make these decisions transparent, to allow others to follow, and to allow others to build on your process. A clear explanation of the process is a big part of how rigor is achieved in design-centered approaches. And finally, I want to talk about the idea of critique. A critique is a specific type of evaluation done by a team of experts. These are typically very structured, with a designer presenting multiple ideas and saying what kind of feedback would be helpful to them at that stage of the process. There may be a moderator who guides the discussion. And there are domain and design experts that provide feedback that help guide the next iteration of the process. Now, this is different from a user or an expert evaluation that we cover later in this course because it involves a dialogue between the creator and the team, and it generally considers a variety of designs with a focus on a specific design challenge rather than walking in detail through a single system task. This process really does rely on the well-developed intuitions of the other team members, and it is another important part of how intellectual rigor is achieved in design-centered approaches. Now, all of that being said, this specialization is not really going to focus very much on the design-centered approach. There will be a bit more content giving a more in-depth view of the design-centered methods and when they are powerful, but generally it's very difficult to teach this kind of content in a MOOC class. So one issue is that developing design intuitions really only happens through substantial experience, through apprenticeship, and typically apprenticeship in studios, and that's very hard to achieve in a MOOC. It's also very hard to kind of get that interactive environment that's necessary to master elements like critique. However, you should know that a design-centered approach is a valid way of considering a user interface design problem. There are some tech companies where it's really the driving approach. I think Apple is probably the highest profile example. We'll also be borrowing methods and best practices from design-centered approaches whenever it's doable to actually incorporate them in this course. And from this video, I would just like you to really be familiar with the key terms and concepts of this approach. As I said, we went through 6 of them. We went through intuition, dialogue, inspiration, disruption, process, and critique. And just to wrap up, I'll be the first to admit that I'm not the world expert on design-centered methods. My training was primarily as a computer scientist, though I am very drawn to these approaches, and I ended up picking up quite a bit of significant studio time and a 6-month apprenticeship when I was in graduate school. But I really do encourage you to read about it from my design heroes. In particular, there's a book known as Ways of Knowing in HCI, and it contains 2 very interesting chapters on design, one from Bill Gaver and another from John Zimmerman and Jody Forlizzi. They're really the masters of design-centered HCI, and I hope you have the opportunity to learn from them as well. So thank you for joining, and I hope to see you again soon. Hello and welcome back. Today we're going to continue talking about design-centered methods. I want to talk a little bit about when they work best. So one thing I find is that task-centered methods are good for certain approaches, but there's also some things they really struggle with. I brainstormed to think what are the 6 things that really come to my mind when I think about the things that task-centered methods are not that good at. And I really think it comes down to issues like motivation and engagement, affect and how people feel about your system, connection, where things like how fast you accomplish a task may not be something that actually captures the system well. For example, if you design a video conferencing system, making a system that has parents and kids Skyping the fastest is probably not the best idea. You want them to connect and actually establish those connections, and a task-centered approach may not help you capture that. Identity is another one of these ideas. Let's say you build a ticket buying site where everything works well. Somebody can go through the task of buying a ticket very quickly, but just the way it's branded, it doesn't appeal to a particular type of user. Maybe it seems like pretty country, and so somebody who wants to buy death metal tickets wouldn't actually want to go to the site and use it. And then there's also this idea of values. Does the system really capture the things that are important to the user, the things they drive their everyday life? And I think this is where design-centered approaches can really help. So in one of the previous videos, I covered the 6 concepts of design-centered approaches. We talked about intuition, we talked about dialogue, inspiration, and disruption. I covered a little bit about the importance of documenting and presenting your process, and we also talked about critique as a way of evaluating a design. Now, I'm not actually going to talk about all of these today and how these relate to design methods. I'm actually going to focus on 3, on dialogue, inspiration, and disruption. In other courses in this specialization, we do talk a little bit about intuition as we teach you about psychology theories and help you develop good intuitions about what works and what doesn't. We will talk a little bit about process when we talk about the idea of writing a justification for the particular design decisions that you make. And as part of that process, we'll also discuss critique a little bit, though it's very hard in the context of a MOOC to be trying to do a critique. So today we'll just focus on methods which help lead to dialogue with users, which help inspire you as a designer, and help you disrupt your own thinking and question your own assumptions. We're going to cover 3 such methods. One is participatory design, the second is value-sensitive design, and the last one is cultural probes. And I don't anticipate that just by hearing me talk about these for a few minutes that you'll have enough to actually go out and use these methods. But it's good to be aware of them, and I'll also point you to resources which can help you learn more about how to use these methods, as well as how not to use them. So let's get started. The first inspiration method, I would say, is participatory design. I talked about this a little bit when I covered a case study about the International Children's Digital Library, which was actually built in a partnership with children around the world. So here are kind of the idea and steps behind participatory design. First, you really want to identify and work with project partners who know a lot about the domain context. Now, I know I always give children as an example, but that's not the only case where that could be done. For example, you could be working with workers at a Taco Bell, and you're designing a new point of sale system for them. Instead of just designing it on your own and then testing it with them, you can actually work with them to find out what are their struggles with their current system, how they would actually solve the problems that they're facing, and what would work best for them. Typically, the way participatory design works is that sessions are structured into teams, workshops, and activities. These teams can always be the same. So for example, 2 Taco Bell workers and 1 researcher working together, or they could be different, where for example, sometimes you would break up the workers into one group and the managers into another, and sometimes you would have them work together. Typically, you have specific workshops with specific goals, such as let's redesign the system to make it easier to give discounts to the customer, or around specific activities, like let us figure out something that could be different from the point of sale system that's at the front of the desk, maybe something like iPads at each table. You work together through multiple stages of the design process, and this is absolutely key. So it's not just at the stage where you're trying to figure out what is the problem with the current system, but also as you're coming up with design solutions and testing them and seeing how your ideas actually get interpreted by the people who work there, that you could build and actually design a system as partners with your project partners. And there's kind of several ways to go about it. You can enact very liberal interpretation of the design. So for example, you could actually have these workers at Taco Bell sketch out what they would want their point of sale system interface to look like, and then you go ahead and implement the system. Or you could also have kind of a more liberal interpretation. For example, when I worked with children in participatory design, we were designing the ultimate car trip system. And one of the things that several kids requested is things like a swimming pool in the car or a trampoline in the car. And of course now, I personally don't think that it's reasonable to go off and put a swimming pool or a trampoline in every family car, but I think their responses point to kind of an underlying issue, which is that it's hard to sit still for that long, and so it's nice for kids to have some sort of a physical activity to do in the car. So a liberal interpretation of that would be maybe something like Dance Dance Revolution in the car, where they could still be sitting, but maybe moving their feet or moving their hands while the car is driving. So as I mentioned, it's really important to involve the user at each step in the process. And these are just some ideas for how you'd be able to do that. There's, of course, many other ideas out there. So as you're trying to understand the problem, one of the things you can do is you can have your project partners keep diaries. You can observe them doing something, and you actually have them observe each other doing something and take notes on that. You could also do things like card sorts. So for example, if your point of sale system has multiple different features, you could have the workers sort these features into groups that make sense, rather than trying to guess at it yourself. You can involve your partners in the design stage, for example, having them build actual 3D prototypes. I think Legos are actually very useful for that. Or if you'd like to have some interactivity in these 3D prototypes, I found LittleBits are a great toolkit that doesn't involve a lot of programming knowledge. You can have them draw out paper prototypes. This doesn't require any programming, but can let them specify a lot of things about the interface that you're creating for them. And lastly, you can actually have them sketch out experiences. So the sketch that's on this slide is actually from a child to a prompt of how would you like to stay in touch with your best friend after they move away. And so this child drew a telepresence robot that can actually play soccer. And lastly, you also want to involve your project partners in the evaluation. So as you develop prototypes, you can actually have them try it along the way. And you can also have them share their opinions. Even young kids are capable of doing that if you give them a bunch of Post-it notes and ask them to write on each one something they liked about the system, something they didn't like, something that was easy, something that was hard. So it is possible to involve the user at every stage along the way. So let's talk about the second method, value-sensitive design. Now this is, I would say, maybe less of a method and more of a philosophy. The idea is that you want to consider and incorporate human values early in the design process. So for example, this drawing here from Tech Policy Lab shows people considering kind of the pros and cons of robots that fly in the sky. For example, the pro might be is you might get instant pizza delivery. That's great. Or that you may be able to use these drones for search and rescue. That's also great. But then these people were also able to come up with some things that are not as positive. For example, somebody using a drone to spy on their ex, or using the drone for surveillance to create a surveillance state. So these systems, the value-sensitive design approach, frequently looks at systems that are beyond the workplace. So things like home, public spaces. And the idea is that you could actually include a number of specific methods as long as those methods actually ask your users to reflect upon their values and consider how those values may be violated by potential systems. The other thing is that all work has some inherent values in it. Even if you're doing task-centered design, those values may include things like efficiency, getting the task done quickly, or cooperation, being able to do the task in such a way that other people can tell what you're doing and work with you easily on it. But value-sensitive design really aims to incorporate values outside of those two main ones. So perhaps kind of more esoteric values like liberty or equality or fairness. So there's a few steps that are part of this value-sensitive design process. The first step is really identifying both direct and indirect stakeholders. So for example, with this drone example, you wouldn't want to just ask people who own a pizza delivery business whether a drone is a great idea or not. You might also want to ask some other people who would be negatively affected on it. For example, somebody who is a survivor of domestic violence who might say, wow, I really not want a drone that my ex can fly around to find me. With each of these stakeholder groups, you want to ask them to identify the benefits and harms and map those directly to human values. It's really hard to ask people to talk about values generically because it's something that's kind of in the background of our lives. We don't think about it every day. But as you present them with scenarios or ask them to use specific technologies, people may be more able to reflect on values. As you identify the human values, you can investigate them conceptually. So for example, find related psychology literature that talks about the value of fairness and what that means and what people interpret as fair. And you can also identify potential conflicts because it's quite possible that one stakeholder would want one technology and another one would want a different one. And finally, you integrate those value considerations into your design process and into your evaluation. And in fact, the philosophy actually encourages you to integrate those value considerations into the whole organization of your company as you're building software or hardware for users. One tool that is provided for enacting value-sensitive design that you may be able to use in the workplace. I know otherwise it's a little bit kind of hand-wavy. It's how do you think about all these values. One tool is called the envisioning cards. These are available free online. And the idea is that each card kind of brings up a scenario and asks your users to respond to it. It can be a great way for you to actually solicit these values and the ideas that participants have around values. So let's briefly talk about the third method, which is cultural probes. So I've actually mentioned it briefly before, and I kind of gave this example of if you want to find out about what healthy meals mean to a participant, instead of just asking them, you might actually give them kind of a series of workbooks, something like a camera with which they take pictures of meals they consider healthy or unhealthy, a coloring book, or a place where they can respond to a worksheet, such as drawing a healthy meal. The typical process for a cultural probes investigation is that you meet with the participant and you provide them with an introduction about the purpose of your study and the materials that you're giving them. Next comes the collection period, which frequently lasts at least a few days, but often actually a few weeks. And during that period, you send periodic reminders to the participant to fill out prompts. You might actually send them specific questions that you want them to answer using the materials you gave them. And maybe even you're logging certain behavior of the participant. And lastly, when you're done, you kind of engage in this dialogue with the participant where you do interviews frequently contextualized by the probe content. So you might actually sit down with them, look at their drawing of their healthy meal and ask them, okay, why did you draw that? What does this represent? Why did you use the colors you used, for example? Another common probe that is particularly popular with computer scientists is known as the technology probe. So the idea here is instead of giving something like a camera or a notebook, you might actually deploy a technology specifically meant as a provocation. So not to evaluate that technology, but to provoke a response from the participants and to gather data from them. So typically this technology should be very flexible and the participants should be able to appropriate it in many different ways. So one example of a technology probe, and this is from the original technology probes paper, which I link on the slide, is the message probe. So they were interested in looking at how intergenerational families communicate. So for example, how grandchildren, parents, and then grandparents would all communicate together when they live apart. And they deployed something that was kind of like a digital post-it note system where they could leave notes and drawings for each other. And I know this doesn't seem revolutionary now, but at the time that this work was done, which I think was maybe in 2002, it was fairly old work, this was quite unusual. And they were able to glean a lot from the kinds of messages that participants shared. And the last point I want to make about cultural probes is this idea of probes versus prompts. So a probe is that entire kit that you give to your participants, and it might have lots of different things involved in that kit. So there may be a camera, there may be a technology probe as part of that kit, such as an app where they need to record something. You could give them postcards they're supposed to mail back to you. You can give them little packages that they're also supposed to drop in the mail after they're done. So all of that is part of a single probe. But as part of the probe, you might also want to ask specific prompts. So for example, let's say you give them a camera. Well, if you don't tell them what to actually take pictures of, that's not going to be a very useful technology probe. So you may do something like, send them a message in the morning, a text that says, take a photo of something that reminds you of grandma, for example, if you wanted to find more about intergenerational connection. Or maybe you have little bottles that you include as part of that probe that get mailed back to you. Maybe you ask them to put something in there that you want to share with your grandchild, and that gets mailed to you and lets you know a lot more about kind of that relationship between the grandparent and the grandchild. So again, just to review, the probes is that whole package that is being given, and the prompts are the specific questions and responses that you're trying to get from the participant. Now, all three of these methods share something in common. So the idea of these methods is not that they tell you what to build. In fact, you should never ask participants directly, like, what should I build for you? This is not a question participants can usually answer. But rather, they have these other goals. So one is to equalize the power between you and the user. So when you are coming in as a researcher, originally there's kind of this power differential. So they feel like, oh, well, you know how to build systems. I don't know how to build systems. So you tell me what you should build. But as you kind of ask them to do these playful activities, and you're willing to be a little bit silly with them in design workshops, or you're willing to ask them to reflect on these kind of complicated value scenarios, it really equalizes the power between you and the user. It really gets down to we're all people and we all have something to contribute to the design process. Also, these methods are really there to feed that rich dialogue between you and the users. It's not just the users providing data and you getting that data and doing something with it, but rather it's that conversation that evolves over time as you're both trying to figure out what is the right solution for the context. These methods are really meant to inspire you to go in a different direction. And that's why they're sometimes a little bit unconventional. I mean, you wouldn't really think about, giving a bottle to somebody and asking them to put something in there they want to share with their grandchild as a typical method. But maybe the things they put in there are actually really lead you to a new design direction, something entirely different that you hadn't thought of before. And lastly, they're really supposed to challenge your assumptions. Highlight your biases, especially in the case of value-sensitive design, where your values could actually be different from the values of your users. And they're really there to disrupt your thinking, to take kind of the orderly way that you think the project was going to go and turn it on its head and make you think in an entirely new direction. I think that really leads to some powerful designs and ones that aren't kind of immediately obvious and that everybody else around you is already trying to build out. So, as I promised, I didn't really give a ton of information about each of these methods just because we don't have time to cover all of them. But I'm going to give you links to papers that can explain these in more detail. So there's a book on participatory design, another fairly long paper or chapter, I think, in a book on value-sensitive design, which I think is very helpful to understanding it. And the probes paper is actually an interesting one. So it talks about how computer scientists interpret the probes and sometimes misinterpret them as an informational rather than an inspirational method. And so I think it's good reading if you're going to apply that method. Well, that's all I have for you today, and I hope to see you in the next video. Thank you. Hello and welcome back. Today we'll be focusing on pulling it all together, the entirety of the UI design process. We talked about many different processes, from usability engineering, such as task-centered UI design, to design-centered approaches that may feel a lot more subjective, like participatory design, value-sensitive design, and cultural probes. So here, the goal is to really find the right process for the right situation.
So, what does it mean to be the right situation? There are many properties design situations have that affect the process you might want to use. Are you designing something new? Is this a variant of something that exists? Are you iterating? What's the design situation? What's your user base? How broad is the user base? Are you designing for everyone or for a narrow group? How involved are they in the process? Is participatory design even an option? Or is there disengagement from them? How familiar are you already with your user base? And for that matter, how familiar are they with what you're doing? Are they constraints that you have from political or legal reasons? Participatory design is sometimes something that's been negotiated as a right of workers in designing their own work environments, where you don't have the option of saying, no, we'll just interview you and write up some cases and go away. But it's also a property of the system and the interface. How much of what you're trying to design is about engagement, motivation? How much is it a tasked interface versus not particularly tasked? Are you trying to create experiences like flow where people are immersed? Those will all lead to different conclusions about how much of this might be design-centered versus task-centered or other usability engineering approaches. And finally, and in our case, quite importantly, what are the skills of your design team? You know, if you have Apple's design team at your disposal, they can come in and say, well, gee, we've got a process that we think works for consumer products, and you probably have a good reason to trust them. If your design team is mostly a set of engineers and people who are building the product, or managers and marketers who might be selling the product, but without design experience, then many of those design techniques are just not likely to be successful. The folks involved don't have the training, and the engineering techniques are more likely to succeed. So, why task-centered user interface design for this course? The first reason is it's a good baseline method for novices, particularly for people with a business background, an engineering or technology background. We've had experience with nearly 2,000 people using this technique, and almost all of them find they can improve interfaces and design interfaces that are pretty reasonable by using that approach. But there's a second reason why. TCUID, by making these artifacts separate and explicit, the task descriptions, the scenario descriptions, but also, as we've added in, persona descriptions, by breaking apart those different parts of the design and user research process, it better supports learning how those pieces work. The more holistic design mechanisms really require that you already understand some of these pieces, and this is a good way to learn them in the first place. Now, to make this work, you will see that the examples we have you do as exercises and the capstone projects, if you complete the specialization, are limited to ones that are highly task-oriented. But as it turns out, task-oriented applications are probably the most common ones in the business world. Everybody has dozens of apps and desktop applications that involve filling out forms, entering data, requesting something, searching for something. And so these are probably the most useful cases that you're going to come up with as you start as a user interface designer. And as the course progresses, we will continue to discuss issues related to non-task oriented applications as they arise.
Now, of course, you may want to add other processes at some later point. There are, in fact, a lot of other processes, and there are many opportunities to learn them. So one is professional conferences and seminars. In the introduction to this course, we covered a few of those that are very common in our field. The others is books and articles. Sometimes at the end of a video, we point you to specific places you can go to learn more. Professional mentoring is a really good one. As I mentioned before, with design-centered approaches, an apprenticeship model is one that's still used to teach design intuitions. And of course, other online courses may also make you more familiar with some of these other methods. We really hope that you will continue learning and adding more methods to your UI design toolbox.
So as we close this topic, let's take a quick look forward. There is an assignment doing task and scenario examples and a quiz. The assignment involves peer review, and it is our intent that you learn not only by doing one example, but by thorough critique of the other examples that people do. Next, as we move into our next topic, we're going to look at psychology, human factors, and other sources for generalizable understanding of users, the kind of information that can jumpstart our user research before we get in contact with individual users and learn about their individual tasks and needs. Thank you. This video is an introduction to your assignment on drafting task and walkthrough scenario descriptions. This video gives you some background information and basic information about the assignment, but is not intended to replace a detailed reading of the assignment instructions where you'll get the specifics of exactly what you're supposed to be doing. So first and foremost, what are the goals of this assignment? We want you to demonstrate and cement your mastery of the key concepts of task-centered user interface design, and particularly the two key concepts of the task descriptions and the walkthrough scenario descriptions. This particular use of them is intentionally out of context. Obviously, task-centered user interface design would normally require that you go and do user research and build these as a result of your user research. You will do that if you go forward into course 2 on user research and design, where we'll have you go out and study users and go forward. But in order to do that effectively, we think it's valuable if you first understand what is it that you're trying to create taken out of context. The assignment is structured in 3 parts. First, there's a part that's structured as a quiz, where we will give you a set of examples of task descriptions and a set of scenario descriptions, a little bit of background in them, and we're going to ask you to evaluate them for strengths and weaknesses. We do this for 2 reasons. One, it's a way of making sure you understand the criteria for good task and scenario descriptions, but 2, it's also a way to make sure that you're up to speed before you not only do your own work, but submit peer evaluations of others. The second step has you draft just one of each of a task description and a walkthrough scenario tied to that same task. We're going to give you a specific example to work from. And the last part of this is peer evaluation, where you're going to go to 3 or more other learners' responses and do both a summative evaluation of, did they do this right? Were there specific issues that were done poorly? And some narrative evaluation of feedback. And that can be fairly brief, as you'll see when you look at the examples. So what makes a good task description? This is not new. This is what you learned about when we talked about tasks and scenarios. A good task description describes a complete representative task, and it includes the relevant context about usage and user. As you go through the quiz examples, you'll see, okay, here's one that it's just not something that would work. It doesn't include the details on the specific interface that solves the problem. So if I come back and say, well, my problem is I want to find a flight to San Francisco on particular dates, that could be a good task description with more detail. If I say I want to find a flight to San Francisco going into Expedia.com under the Flights Only tab, I've treaded out of the problem and moved into the solution, and we don't want any solution inside our task description. You'll see why again in a second. And the last piece is, you could give this task description to a sample user, a person who might really do this, and ask them to go do it in any of a number of different tools or interfaces, and they would understand what they were being asked to do. You'll see examples of these in the quiz as you go forward. What makes a good walkthrough scenario description? It's step-by-step instructions in user understandable steps at a chunking and a granularity that would make it possible to compare different solutions. The key here is to think about the level of detail that's useful. If we're using that same example of finding airfare, it may make a lot of sense to say, type in that you're going from MSP to SFO, if you know you are doing this in a case where that's what you should be typing. Whether or not the person knows that solution is a different issue. That will get back to your task description and whether they would know airport codes. What you wouldn't do is go very high level, where you couldn't carry out those steps, like say, enter all the information on the screen without saying what the information is. But you also don't want to go too low level that it's not really relevant for a user. You wouldn't say, put your finger on the trackpad, move left 7 centimeters and up 4.1 centimeters. Now move your finger 6 centimeters away from you and press down on the key that it sits on. That would be silly. That's not how a person would do it. It's not how we'd understand it. It wouldn't help us in comparing interfaces. So you will see a rubric as we go forward, and that rubric is going to tell you to go through and take you through things like, is this a task that is representative of what people will do, that's an important enough task that it makes sense? Is this a description that's understandable, and so forth? The rubric is not only intended to teach you how to evaluate, but how to write it. Once you understand how to evaluate it, you should be writing ones that you know when that rubric is used to evaluate them will come out as excellent examples. Next, why peer evaluation? This is a question we get asked a lot when putting together online courses. And I'll be honest, we get asked this question just as much when we teach in the classroom and we bring peer evaluation into the classroom. There's 3 reasons for peer evaluation, 2 of which we use when we're in the classroom, and a third one is specific to online courses. First and probably foremost, evaluation, whether you're evaluating peers or whether you're evaluating work that was given to you as model examples, supports a different and complementary mode of learning. There's a different style that you learn in when you're trying to evaluate whether something is good than when you're trying to do it yourself. And there's a huge benefit in evaluating work that includes examples that have flaws. When you're looking at your own work, even if you try to evaluate your own work, you run into problems that you like your work, you think your work is good, it's very hard to see the flaws. We'll see this again when we talk about evaluating user interface designs and how valuable it is to get somebody else to look at your design. This is part of how we learn, is by critiquing the work of others. If you were in school for architecture, a large chunk of your architectural training would be looking at other people's designs and giving them useful critiques. Second, peer evaluation in particular has been shown to support greater mastery. It's in that same spectrum of peer instruction, coaching, and tutoring. There's a lot of evidence starting from young children all the way up that if you want to really master something, you should learn it by watching, you should do it, but you should also teach it. And peer evaluation is a part of that teaching process, particularly when we include a summative component to it that says, tell these folks what they did well, what they did poorly. That helps you solidify your own understanding. The third issue is entirely practical. Without peer evaluation, courses at this scale simply wouldn't be feasible. I guess they'd be feasible if we wanted to charge thousands of dollars and hire people to evaluate things. But if we want to give you an educational opportunity that is free or inexpensive and give you the opportunity to get meaningful feedback, that feedback has to come as part of the process of getting that education. Okay, let's move on to it. You should expect completing the quiz to take you about 15 to 25 minutes. Set that time aside for when you want to do it. Doing your own task and scenario descriptions, it varies for different people, but we're expecting folks who are quick at this may complete it in 20 minutes. If it's taking you more than an hour, you probably should go back and get some more review to help yourself prepare for it. And then finally, evaluate at least 3 peer assignments. And that's, again, something that done well is probably going to be in the 15 minutes to 30, 35 minutes. It shouldn't take you an immense amount of time once you've reached the stage where you're ready to do those critiques. If you have questions as you come along, if they're about tasks and walkthrough scenarios, I'd suggest you take a look at the lecture video again, or really go to Lewis and Riemann's online book that's linked to there, Task-Centered User Interface Design. If you search for Lewis Riemann Task-Centered User Interface Design in Google, it will take you to an open and free copy of the book online. If you have questions that are about the assignment or about grading, you might want to start by looking at the discussion forum, either for people who've asked them already or to ask them both to peers and to your course staff who will be watching to see if there are any issues. Please make sure not to post specific solutions or specific grading challenges. Don't go to the forum and say, gee, this person did this, what should I grade it? But it would be a perfectly reasonable thing to go to the forum and say, gee, I have this issue that I'm trying to grade a particular task description, and the user wrote a task description that seems like it's a very narrow situation, but made a case that this narrow situation is important. Do people think that deserves full credit? That's a reasonable question to put out there, and you'll get opinions from lots of people, maybe even from us. Just to be clear, if you had asked that question and we'd responded, we'd probably say, yeah, if it's important, it belongs as a task description. And so absolutely, that deserves full credit.
Hey folks, welcome to the series of videos on psychology and human factors. The goal of this video in particular is to introduce you to the high-level ideas that we'll be talking about in this series of videos, and then in each video you'll be learning about one specific area of those ideas. Now in general, this series of videos is about understanding your users, but in particular it's about understanding users in general, general information about how people interact with technology. In this course, you'll be spending most of your time figuring out specific characteristics about your users, understanding their specific nature and how they will interact with a technology that you're building specifically for them. But it is also important to understand principles that are broadly true across all groups of users, right? So in this series of videos, you're going to be learning about the general stuff, and in the coming weeks, you'll be learning about how to figure out the specific stuff for your specific application. So a simpler way to think about this series of videos is that it's effectively helping you avoid reinventing the wheel, right? We'll be teaching you in this series of videos all sorts of things about how humans are and what that means in terms of how they interact with technology. And without knowledge about these general principles, you'll have to rediscover them, reinvent that wheel every single time you design a new application. So this stuff's pretty important. It gives you a foundation for doing the more specific stuff much more effectively. Okay, so the main learning objective for this series of videos is learning about how people interact with technology in general. But through this process, we're going to have three additional secondary learning objectives as well. One, you'll become familiar with key concepts, ideas, and theories that will come up again and again throughout this course and actually throughout the entire specialization as well. So for instance, you're going to be learning about theories about how people point at things, and with pointing being such a critical part of how we do almost everything in a user interface. For instance, to move a slide back and forth, right, I have to first point at the key, right? We need to know how people's desires to hit a target are manifest through their physical actions. You'll be learning about how humans make mistakes and the types of mistakes they make, obviously very generally important for all sorts of different technologies. You'll be learning about how humans need feedback from interfaces, again, very generally important. And you'll be learning about, for instance, cognitive theories of how people interact with the technologies around them. One of my favorites, Professor Yarosh, will be covering this, is the theory of actually distributed cognition, where we put some of our cognition into the tools that we use on a day-to-day basis. Okay, the second secondary learning objective for this series of videos is that we really want you to see in this series of videos how, while designing an interface can seem like a massively complex task, right? Oh my goodness, where do I get started? In this series of videos, you'll begin to see how pretty straightforward principles and ideas and theories can take you a large way towards your goal, right? So that this complex task can begin to break down into these more easily understandable ideas, theories, principles, and so on. And then lastly, in this series of videos, you will really, by the end of the series of videos, you will really buy into this idea that user interface design is an incredibly interdisciplinary field. You'll be learning about ideas and concepts and principles that come from psychology, that come from cognitive science, kinesiology, architecture, and even avionics. So this is actually one thing I really like about the user interface design field, that it's very interdisciplinary. This series of videos will really sell that point quite a bit. So I look forward to seeing you in this series of videos. Hey folks, welcome back. Today we're going to be doing our first exploration of the importance of human factors and psychology in user interface design. Specifically, we're going to be focusing on a case study on Fitts' Law, which really quite accurately describes how people move their hands and do other sorts of pointing. And we'll get into that here in a second. So what is Fitts' Law beyond a great first case study in the importance of human factors? Well, it's a simple mathematical model of human pointing performance. And more specifically, this model at a very high level looks like this. It says that the time to complete a pointing task is a function of the distance to the target from where you're starting your pointing operation, the size of the target that you're pointing at, and the pointing device that you're using. And we'll expand this a lot in just a few moments. But first, we have a few more high-level things to do. And first and foremost in those high-level things is to say this. Fitts' Law has been incredibly influential in both the research and practice of user interface design. One great sort of encapsulation of this is from a paper by three colleagues of ours at Google. And in this paper, these three colleagues wrote, Fitts' Law has served as one of the quantitative foundations for human-computer interaction research and design. And they go on to say that Fitts' Law has been used as a theoretical framework for computer input device evaluation. We'll be unpacking that a bit. It's been used as a tool for optimizing new interfaces. We'll be unpacking that one quite a lot. It's been used as a predictive element in complex gesture recognition algorithms. So it speaks not only to the past of user interface design, but the future as well. And it's been used as a logical basis for modeling more complex HCI tasks. Okay, why is Fitts' Law been so influential? Well, to put things very simply, when you're using a user interface, whether that interface is hardware or software, you are pointing a heck of a lot of the time. And Fitts' Law is a mathematical model for how well people perform pointing tasks. So these are just some examples of all the pointing we do when we use our computing devices. So you can point using a mouse, of course. I have my trackpad here, and I'm doing all sorts of pointing on my trackpad. And of course, you can also point with your finger on smartphones and tablet devices and these types of things, right? Pointing is central to so many interactions that we have in user interface, in our experience with user interfaces. And so it's very important for us to understand how humans point when we're designing these interfaces. Okay, so remember that we said that Fitts' Law specifies a relationship between the time to complete a pointing task and the distance to the target, the size of the target, and the pointing device that you're using. Now let's get a little more specific, look at an actual equation. And this is one of the simpler versions of Fitts' Law. There have been, Fitts' Law is quite old, as we'll talk about in a bit, and all sorts of researchers have come in and added little tweaks here and there. This is generally the basic form, very powerful still in practice, or it's been shown to be useful in predicting sort of new pointing tasks as well. So this is both a basic equation to understand Fitts' Law, as well as one that's still pretty darn useful. All right, let's unpack what all of these symbols mean. T, as you might guess, that's the time to complete the pointing task. W is the size of the target. And what do I mean by target when we're talking about user interface design? Well, all of these here are targets. So for instance, you can see that this button to create a new slide in PowerPoint, that's a target. It's a bigger target than, say, the bold over here, right? This icon here from my iPad, that is a target. You're pointing at it with your finger, but it's still a target for pointing. And then also, of course, all web links, they're also targets, right? They're differently shaped. These tend to be more square. This is more oblong, right? But they are still definitely pointing targets. Okay. A here is the distance to the target. So if I'm starting out over here and my target is the A, the distance is really high. That's a pretty simple notion. And then these are properties of the pointing device, and we'll unpack that in a second. One thing I like to do when I present equations in class is really talk about what happens when something goes up or something goes down. What's the overall effect, right? This, at least for me, gives me a sense of how all this works. It builds my mental model of the relationships described in the equation. And what we can see here is that since W is in the denominator here, right, as the target size goes up, the time is going to go down. This value here is going to go down. So as the targets get bigger, as those icons get bigger, the time to point at that icon is going to go down. The opposite is true with distance, right? So the further you are away from your target, say my target is the bottom left there, all the way down here, the longer it's going to take me. Okay, that stuff's pretty straightforward. This stuff gets pretty interesting and specifically speaks to the pointing device. We'll talk about that just in a second here. But obviously, A is some kind of intercept, right? And if this is high, that's bad news. That means there's a built-in cost to pointing at anything, regardless of how big the target is or how far away it is. And then B is the slope. So if this is high, that means that no matter what this value is it's going to be quite a bit higher because B is high. If it's low, that's going to dampen the effects of these variables, right? And it's a basic a slope operation. So let's talk about how all of these relationships, which are embedded into Fitts' law, explain key decisions in user interfaces that probably many of you are familiar with. So for instance, this here is a screen grab from Microsoft Word. It has the ribbon there, right? Everyone's kind of familiar with the ribbon. And you can see that it has made things that people probably do more often bigger, right? So I insert a picture a lot more than I insert a smart chart into my Word document. And that is manifest. That was a choice that Microsoft made, right? It's because this target size is larger, the picture icon is larger than the smart art icon, right? It makes sense. It's going to be easier to point at it. So if Microsoft's saying, okay, we only have limited space in our ribbon, how are we going to allocate this space? Well, we can do something to make people's pointing a lot easier by making the icons bigger for things that they click on more often. So Fitts' law, this is our first example of Fitts' law sort of manifesting in these maybe quiet, maybe understated ways in a user interface design, but ways that can have a pretty important impact on the overall user experience. For instance, if this icon were really small and we had to click on pictures over and over and over again, the time it would take to click on that tiny little icon, that would begin to frustrate any normal computer user. Okay, let's look at the same ribbon from Microsoft Word, but let's look at the bold, italics, and underline. Well, one hypothesis for why these are close together is that you often click on them together, right? So you're often bolding and underlining something next to each other. We'll talk about other reasons why these are together as well later in this particular course. But one reason is if Microsoft anticipates that you're going to be clicking on these together, it can make that pointing task faster by reducing the distance, right? This is all explained in Fitts' law. Okay, moving over to Mac OS now. This is one of my favorites. The Mac menu bar is at the top of the screen, right? And this can be understood, through the lens of Fitts' law, and I just love this. The reason it's at the top of the screen is if I go all the way to the top of my screen here, for instance, right, I can't go further. Effectively, what this does is it means that, for instance, the Finder here, if I go further past the Finder, I can't go further past the Finder. So effectively, the target of that Finder menu is all the way up to infinity, right? So I've made the target size effectively much, much, much larger than if I put this somewhere in the middle of the screen, right? So this is actually a very large target, even though it takes up relatively little screen space. I love this. It's a great design decision. Another Fitts' law-esque design decision you'll find in Mac OS X, or Mac OS now, is the dock magnification, right? So what this does is when I move my pointer down here in Mac OS, and dock magnification is on, I will see that each icon will grow when my mouse gets closer to it. And this is just a way of magnifying the target size, which will make pointing faster, right, as predicted by Fitts' law. Okay, moving back to Windows here, you can see the pointer, the mouse properties control panel and the pointer tab. This feature here is also explainable with Fitts Law. What this does is that this will snap my pointer to the default button, which in this case is OK. What I'm doing there is effectively reducing distance to more or less 0, right? Unless I want to hit cancel or apply. But even those are closer, right? So as soon as I open this and the pointer snaps here, I have made pointing a lot faster when I have this feature enabled. Now, perhaps more impactfully, Fitts Law is very famous for helping the folks at Xerox PARC back in the late 1970s justify the commercial introduction of the mouse. What they did was they found that the mouse had lower A and B values. Remember in Fitts Law, A and B are both the intercept and the slope. If those are lower, that is fantastic for every single pointing job, whether the target is large or small or the distance is large or small. And what they found was that the mouse did better than the joystick or just using your keys. I don't know if any of you are old enough to remember to do this. I'm sure some of you are like myself, where you're trying to point at something using the arrow keys. They found that the A and B values for the mouse were much lower than the joystick and the arrow keys, and they said, all right, I think we have an excellent pointing device here. Fitts Law says that it will make pointing a lot faster for everyone. Let's introduce this commercially. Steve Jobs saw the mouse, introduced it in Apple, and now we all use mice all the time. There's a great website that can kind of help us demonstrate what went on in 1978, as well as what goes on all the time now when people are designing new pointing devices. It's this website by Simon Wallner in Austria, and I'm just going to show you a quick demo here. Okay, so here we are at this wonderful website. And what this website does, it talks to you about Fitts Law. And it's a great additional reading resource, actually, if you're interested in this material. But this is the key part, right? It lets you click on things, and you can see how well Fitts Law models your performance, as well as one other very important thing, which we'll see in a bit. So let's just do a quick demo of how this works. Okay, click, click, click. I recommend you guys do this yourself. It can be kind of mindlessly fun, and you're doing it in the service of science. All right, so you'll see that the size has changed and the distance has changed, right? It's because if you look in the right there, I have randomize after round turned on. Okay, so you can see I'm having trouble clicking on the left-hand side of my trackpad here. But these are big targets, right? They're pretty far away, but they're big targets. Fitts Law suggests that I should be able to point on these more quickly, right? Okay, so this is the basic idea. Like a good cooking show or whatnot, I did this a bunch earlier before I started recording. So let's see what my results were, specifically in one area. All right, so what I did with that website was I did a whole bunch of rounds with my trackpad, and I did a whole bunch of rounds with my mouse. The blue here is my mouse. The orange here is my trackpad. Which pointing device is better? Okay, you just saw an in-video quiz. Hopefully you said the mouse is better. And the reason you thought the mouse was better, hopefully, is that the slope is lower. Now, both of these have roughly the same intercept. That's our lowercase a, right, in Fitts Law. But you can see that the slope is higher, right? What this means is that as the pointing task becomes more difficult, you can ignore ID here. This is basically a function of both A and W. As the pointing task becomes more difficult, time gets a lot longer with the trackpad, whereas the mouse time is much less contingent on the size and the distance to the pointer. There still is a good slope, but it's not enormous. Now, note that both of these have roughly the same intercept, or A, but it's the slope that's different. Now, I did this for my class on this subject last semester, and this was a separate run, and the same thing happened. And I also did it as an in-class activity, and everyone else saw the same thing. One thing I think this helps us explain, and I'm sure many of you have had this feeling, when you're doing a task that requires a lot of pointing, for instance, putting together PowerPoint slides, you're always pointing at particularly small targets, making them things bigger or smaller, right? Expanding the size of objects. You're dragging things around, you're clicking on things. It always feels a lot more frustrating for me to do that with a trackpad than it does with a mouse. And Fitts Law here can help us explain why, right? Everything actually just takes longer. All right, so before we finish up our discussion about Fitts' law, I want to cover a few more pretty interesting points about Fitts' law. The first is in relation to Fitts' law and accuracy. Now, when I taught this course last semester, I taught our local user interface design course last semester, and my students loved Fitts' law. It's this really nice structured explanation of something that I think we all have sort of struggled with and maybe implicitly wondered about over time. But everyone was very confused as to why it just spoke to speed rather than accuracy, right? Pointing speed is important. How fast can you click on things? But also important is how often will you not click on the correct button, right? I think we've all had that experience quite a bit. Now, Fitts' law does indeed only directly speak to time, but it does imply something of a speed-accuracy trade-off. And the way this works, right, is we have to think about size in a different way. Let's think about target size as a center point and a threshold, right? So what Fitts' law says is that if you increase your error threshold, if you increase your target size, your time will go down, right? W is in the denominator of the equation. But if you decrease your target size, you lower your threshold, if you lower your error threshold, right, decrease your target size, you're going to need more time. So there's a speed accuracy trade-off. Okay, so that's sort of at a high level how Fitts' law speaks to accuracy. I will say I did some additional research into this because students had so many questions. And it turns out that there was a paper published at ACM SIGCHI, which is the same publication venue as the Google paper was published that we talked about earlier. This is a paper by some of our colleagues at the University of Washington, Microsoft, and York University in Canada. And what they found was that, yes, Fitts' law actually can be manipulated to very specifically predict the accuracy of a pointing task. The prediction accuracy was actually somewhat astonishing. It was in the R squared, for those of you who understand what that means, was well above 0.9. And this is a nice little excerpt from their paper. What you see here on the x-axis is the percent of the movement time, or the time to complete a pointing task, that it took a participant to do it without any time pressure. Right, so here it's 30% or 40% of the no time pressure pointing task, and here it's 140%. And what this basically says here is if you rush people, you're going to get pretty low accuracy. So, for instance, if with very small targets, with 16 pixel targets, the accuracy, the error rate was 0.8, so 80%, and the accuracy was 20% if you really rush people, right? So Fitts' law, they did this through a manipulation of Fitts' law, and it turns out that Fitts' law actually can help us understand how many times you're going to misclick on something. Basically, if you make your target size pretty small and people are in a rush doing things quickly, you're going to have a lot of misclicks. Okay, the second thing I wanted to add about Fitts' law is that it not only applies to sort of older input devices and sort of things like mice and trackpads and so on and so forth, but it also is helping us do important research on new types of input devices and developing new user interfaces. We saw a bit of that here, right, with gesture recognition algorithms. But let's actually unpack this paper a bit more, this B et al. Paper from 3 folks at Google. They actually looked at how well Fitts' law applies to pointing using your finger on a touch input device, so for instance, a smartphone. And what they found was that Fitts' law does indeed help us predict movement time, time to complete a pointing task, with in this context, right, when you're using your smartphone. But it does require a slight modification, and that's why you see over here, it's not just Fitts' law, it's also F-Fitts' law. It's a slight modification. And this is kind of a fun modification. Basically, what F-Fitts' law says is when you're pointing on your smartphone, the movement time can be predicted by, both Fitts' law and what's known as, in scientific terms actually, the fat finger problem. And so the fat finger problem is even if you give someone an infinite amount of time to point at something accurately on their smartphone, oftentimes those targets are a lot smaller than your pointing device, which is your finger, right? And people will still miss it, right? They'll still miss it even if you give people infinite time. And what they found is that if you combine those two things, the fat finger problem or knowledge about the fat finger problem and modeling of the fat finger problem and Fitts' law, you can very accurately predict how fast people can point at things with their finger on a smartphone. The last thing I want to say about Fitts' law is that it demonstrates very clearly the importance of interdisciplinarity in user interface design. Fitts' law was not developed by a computer scientist. It was developed by a psychologist over 60 years ago. And despite this, it has become one of the most influential things at least over the long term, in user interface design. I think this is just a wonderful example of how important it is when we're doing design work, and quite frankly, when we're doing other work in computer science as well, that we look outside the walls of our discipline and reach out to other disciplines and say, hey, what do you know about this fundamental human process that I'm trying to make easier or that I'm trying to implement in my user interface design? And oftentimes those disciplines will have answers. Okay, a few closing thoughts. In this video, we saw that Fitts' law is a canonical example of how understanding humans can help in user interface design. And we also saw how Fitts' law and as we'll see later, other human factors can be key design shortcuts, We don't need to think about how big to make our icons to make pointing faster because we have Fitts' law, We don't need to use the more complex design processes that we'll learn in the rest of this specialization for that. We already know that, We don't need to ask questions about whether we need to put things closer together because how the impact of that will be on pointing, these types of things. We already know that from Fitts' law. There's no need to reinvent that particular wheel. And this saves us a lot of time because, as we'll see in this specialization, doing product-specific and domain-specific design really will take up all of your energy and will take up all of your will challenge all of your creative abilities, I should say. So with that, that's all we'll learn about Fitts' law, and I'll be seeing you soon.
Welcome back. In this video, I want to discuss human memory and attention. I will use the same structure in this video and the two following videos. I will first discuss the important human attributes and characteristics that have an influence on interface design, including memory and attention in this video, perception and human errors in the next two videos. Then, I will talk about how understanding these basic human characteristics can provide us concrete suggestions and implications for designing user interfaces. Memory is not the most stable human attribute. Many of us may have the experience of forgetting why we walked into a room or forgetting a very important birthday or appointment. According to cognitive psychology, there are two types of memory: short-term memory and long-term memory. Short-term memory is the capacity for holding a small amount of information in mind in an active, readily available state for a short period of time. The capacity of short-term memory is about only 3 to 4 items for most people. The duration of short-term memory is believed to be in the order of seconds. In contrast, long-term memory can hold an indefinite amount of information for a long time. However, it is complex and slow to transfer the information to long-term memory. Also, recalling long-term memory is slower and needs organization. So here are the implications we have based on what we know about human memory. When designing an interface, try to minimize the need for mighty memory, presenting information in an organized, structured, familiar, and meaningful way. Placing all required information for task performance in close physical proximity, giving the user control over the pace of information presentation. The second topic I'm going to talk about in this video is human attention. Attention is the concentration of the mind on a single object or thought. To understand human attention, you can watch this short video. From this video, we see that attention is really limited cognitive processing resource. When we are paying attention to counting the passes, we even ignore the gorilla. So the implications are as follows. Attention is precious and limited resources. Don't litter the side of your interface with distractible materials. Focus your users' attentions on only important elements. Thank you for watching this video. Hope to see you in the next one. Welcome back. In this video, I'm going to discuss human perception. Again, I will talk about what we know about human perception. Then I will talk about how understanding human perception can provide us suggestions and implications for designing user interfaces. Perception is our awareness and understanding of the elements and objects of our environment through the physical sensation of our various senses, including sight, sound, smell, and so forth. Perceptual characteristics include the following, and I will talk about these characteristics one by one. The first one is the proximity. Our eyes and mind see objects as belonging together if they are near each other in space. Similarity. Our eyes and mind see objects as belonging together if they share a common visual property, such as color, size, shape, brightness, or orientation. The third characteristic is matching patterns. We respond similarly to the same shape in different sizes. The letters of an alphabet, for example, possess the same meaning regardless of the physical size. Succinctness. We see an object as having some perfect or simple shape because perfection or simplicity is easier to remember. And related perceptual characteristics, closure. Our perception is synthetic. It establishes meaningful wholes. If something does not quite close itself, such as a circle, square, triangle, or word, we see it as closed anyway. Unity. Objects that form closed shapes are perceived as in a group. Continuity. Shortened lines may be automatically extended. Balance. We design stabilization or equilibrium in our viewing environment. Vertical, horizontal, and right angles are the most visually satisfying and easiest ways to look at. Perception is also influenced by expectancies. Sometimes we perceive not what is there, but what we expect to be there. For example, missing a spelling mistake in proofreading is an expectancy error. Context, environment, and surroundings also influence individual perceptions. The last but not least one, signals versus noise. Our sensing mechanisms are bombarded by many stimuli. Important stimuli are called signals. Not important or unwanted stimuli are called noise. Noise often interferes with the perception of signals to the extent that they are similar to one another. So here are the 11 perceptual characteristics. The implication is that designers should utilize our perceptual capabilities so an interface can be structured in the most meaningful and obvious way. Thank you for watching this video. Hope to see you in the next one. Welcome back. In this video, I'm going to discuss two types of human errors, slips and mistakes. Again, I will first talk about what we know about human slips and mistakes, and then I will talk about the implications for designing user interfaces. Humans are not perfect. People make errors, including unconscious slips and conscious mistakes. Slips occur when users intend to perform one action but end up doing another, often similar action. For example, accidentally putting liquid hand soap on one's toothbrush instead of toothpaste is a slip. Mistakes are made when users have goals that are inappropriate for the current problem or task. So mistakes are consciously made. Therefore, even if they take the right steps to complete the goals, the steps will result in an error. For example, if someone misunderstood the meaning of the oil pressure warning light in his car and thought it was a tire pressure monitor, no matter how carefully he added air to his tires, he would not fix this issue with his oil pressure. Here are some implications and general guidelines for preventing slips. Designers can include helpful constraints, offer suggestions, choose good defaults, and use forgiving formatting. To avoid human mistakes, designers can gather user data to understand users' mental models, follow design conventions, communicate affordances, and preview results. And thank you for watching this video. Hope to see you in the next one.
Welcome back. The topic for this video is conceptual models. This video draws on work first stated by Donald Norman in his book, The Design of Everyday Things. Now, the idea of conceptual models is that we as people are explanatory creatures. We come up with models. We have a drive to figure out how things work. We need to come up with these models because we also need to use things in new ways. And so rule one of interface design is you want to create an interface that behaves exactly as users think it will. Another way of putting this is your job is to make it easy for users of your system to create the right model of the system. Now let's look at this in a little bit more detail. When you are a designer and you create a system, you have a model of how the system works. Or put it another way, you know how the system works. You know the insides of the system because you built it. Now, hopefully that model is explicit. That's good design practice, good software engineering practice. And so you have your model of the system as a designer. But of course, the user has to figure out how it works. The user has to build a model, and that is called the user's model of the system. Now, we hope that the user's model will be identical to the designer's model of the system. That is, they will have an accurate understanding of how the system works. Well, how can the user actually create the model? They don't have access to your knowledge. They don't have access to the internal workings of this system. So the only way they can build a model of the system is through what's called the system image. All of the things about the system that are visible to the user, the controls, the displays, and so on. That is the system image. And so that is what the user uses to build a model. And as a designer, your job is to create a system image that makes it easy for the user to acquire a user model that is equivalent to the design model. So let's consider an example. And as often is the case, an example that shows when this is not done well illustrates the importance of this concept perhaps a little better than even a good example would. So I'm going to give you an example of how to control temperature in a refrigerator. And there's two things that you want to control about when it comes to the temperature of a refrigerator. The temperature of the fresh food compartment, where you might put milk and orange juice and things like that. And then the temperature of the freezer compartment, where you put frozen food. And this example is adapted from The Design of Everyday Things by Don Norman. So here are instructions for how to control the temperature of a refrigerator. And notice that there's fairly complicated instructions, which already is a bit worrying. Simple things should be simple to operate. But when I look at this, a few things come to my mind right away. I see, well, there's one display indicator for the freezer and one display indicator for the fresh food section. Let's see, letters for the freezer, numbers for the fresh food. So I figure if I change the letter, I must change the freezer temperature. And if I change the number, I should be changing the fresh food temperature. Well, that makes sense. And then I sort of look at the instructions and I think, well, normal setting C. If I want to make the fresh food colder, I move it up from 5 to 6 or 7. Okay. If I want to make the freezer colder, I move it from C to D. Yeah, okay, that's sort of making sense. Well, but if I go in a little more detail, I get a little more complicated, like, I sometimes have to change both controls in order to change the temperature in the fresh food. Well, okay, well, I'm not quite sure what that means. So given that my model of, the letters control the freezer, the numbers control the fresh food, I'm just going to stick with that as my working model. And what that might mean is that when I look at that, I have, my model could be that I have a freezer control that controls the freezer temperature, the fresh food controls the fresh food temperature. I probably have a cooling unit for both of them. I probably have a thermometer for both of them. And what happens is I'm controlling how hard the cold air unit works, either for the freezer or the cold air unit for the fresh food compartment works. Yeah, that's a pretty sensible model. Makes sense based on the controls that I could see. But suppose now I want to make the freezer warmer. Now, if I look at the instructions, there's no instructions that tell me how to make the freezer warmer. It tells me how to make the freezer colder. It tells me how to make the fresh food section warmer, colder. There's no explicit instructions for how to make the freezer warmer. So I have to rely on my model. And now I sort of think, well, I guess I'll move the freezer to B, because moving the freezer from C to D made it colder, but what do I do with the fresh food control? Should I leave it at 5 or move it lower? And my model of the system, my user model, really doesn't help. It really doesn't tell me. And furthermore, it turns out that the model I had of the system was wrong. The reality is the design model was completely different and actually kind of weird. It turns out there was one cooling unit in this refrigerator. There was a valve that controls the amount of cold air directed to the freezer and fresh food compartments. That is, you have a certain amount, a single amount of cold air being produced, and you can choose to route more or less of it to each of the two compartments. You can control how cold the cooling unit is, and then there's a thermostat somewhere. And the problem is it's really difficult or impossible to infer this model from the system image. So, not good design. It was not easy for me to come up with the proper model of the system from what I saw of the system image. Now there's a big problem too with feedback. Okay, so look at this instruction. It says, well, after you make your changes to the controls, allow 24 hours to stabilize. So whatever change I make, I have to wait 24 hours to see if it works. That's tough. That is not a design I like. Well, so we've seen some problems. So the question we have is, how does a designer help users acquire the right model of a system? And the answer is, use principles of good design. And we are going to go through these principles in another video coming up soon. So that's it for the topic of conceptual models, and that's all until next time. Welcome back. The topic for this lecture is the Gulf of Execution and the Gulf of Evaluation. This video draws on work first done by Donald Norman in his book, The Design of Everyday Things. Now, I want to start with just a simple example to illustrate sort of the foundation for this concept. So Don Norman talked about different stages of action. And he said, if you want to achieve a goal, you have to form an intention to take some action to achieve that goal. You have to figure out what actions you're going to take. You have to carry out the actions. And those actions always involve acting in the world, changing the world or the environment. And for our purposes, that environment typically is a computer system. Then you have to perceive and interpret what happened, what changed, if anything, in the environment. And then you have to evaluate progress towards the goal. Did I achieve the goal? Did I make progress toward the goal or not? So I'll just talk through a simple example of this. So suppose I want to clean up my desktop interface, and I've got a shortcut to Spotify on my Windows desktop. And I decide I want to remove it now, so that's forming an intention to act. I then have to figure out how to do it and actually carry out my intention, carry out my plan. And so I can figure out, or I already know, I can put this into the recycle bin by dragging and dropping it over to the recycle bin. And I can use the mouse to actually perform the drag and drop action. And then once I do that, I have to see what changed. And I might immediately notice that I don't see the shortcut on the desktop anymore. And then I can evaluate progress toward my goal. Well, in this case, it's very simple. If the shortcut isn't visible anymore on my desktop interface, I think I've achieved my goal. So just a really simple example that illustrates the idea of these stages of action. But as you might be thinking already, things can go wrong with this whole process, and they can go wrong at different stages. For example, I might not know about the recycle bin, or I might not see the recycle bin icon even if I do know about this concept. I might not know about drag and drop, or I might have a hard time executing the drag and drop action. Maybe my motor skills aren't good, maybe I can't see that well, maybe the mouse isn't working right, and I just have a hard time actually executing that action. So there's names to describe two particular types of failures that can occur through this process. One is the gulf of execution, and one is the gulf of evaluation. Now, the gulf of execution happens, as it sounds like, if you have trouble executing an intention. And this can occur. Well, think of these questions. Does the system provide actions that correspond to the user's intentions? That is there a way to do what you wanted? And can the user figure out that these are the right actions? Can you actually do these actions? And any difficulty, any problem in going from your intentions, from your plan, to available actions is called the gulf of execution. And the gulf of evaluation is the other side of things. You can ask yourself, does the system provide physical representations, that is, displays or outputs that can be easily perceived, easily noticed, and interpreted in terms of the user's goals and intentions? That is, can you tell, have you made progress toward achieving your goals? And the gulf of evaluation then represents the amount of effort or how difficult it is to interpret the physical state of this system, that is what you see in the system, and determine, have you made progress toward your goal? So let's take a couple examples, because what we'll see is that these two gulfs account for many Hall of Shame user interfaces, that is, bad user interfaces. So I'm going to take first an example of the gulf of execution. So what you can see on this slide is a picture of a conference room that I go into all the time. And if you'll notice, there's a screen at the front of the room. So often we want to project onto that screen. And when anybody does this, you want to dim the lights at the front of the room by the screen so that when you project information on the screen, it's more visible. Well, so I form an intention to dim the lights at the front of the room. Okay, well, I have to figure out where are the controls, and I have to figure out how to actually operate those controls to dim the light at the front of the room. So my goal is to dim the lights in front of the room, and I have to find out where are the controls. Now, perhaps not surprisingly, if I look at the back of the room, there's a nice light switch right by the door, and that's where the controls are, pretty much where you'd expect. Now, if you zoom in on those controls, though, you have this issue. Which of those two switches, there's one on the left, one on the right, is for the front lights, and which for the back? For me, at least, the answer is not obvious, and although I've probably done this dozens of times, I typically just do it by trial and error. So the problem of which switch should I press is a problem for me on an ongoing basis. And since the answer to this is not clear to me, there is a gulf of execution. Let's take another example, a gulf of evaluation example. So as I was preparing these slides, I downloaded some picture files onto my computer. And you can see them over there, and you see the names of those picture files. Well, which one of these is the close-up of the light switch that I used a couple slides back? Which one of those file names represents the light switch picture? And if it is not clear to me from this display, there is a gulf of evaluation. Now, you might be thinking that there are other representations in this in the Windows File Explorer that does let me get a preview of the actual pictures. That's true, but this is the default configuration that I use for various purposes. And in this display, it is not clear to me which of these pictures indicates the picture of the light switch, and therefore there is a gulf of evaluation. Also, for another couple of examples, remember that in another video, we gave the example of controlling the temperature of the fresh food and freezer compartments of a refrigerator. And in that example, we saw both a gulf of execution and a gulf of evaluation. So going back to the action model that we introduced earlier, it's useful to note that we can use this model as a guide for creating good designs. We can ask ourselves a series of questions. You can ask yourself things like, how easily can the user determine what the system is for, determine what can be done with it? How easy is it for the user to tell what actions are possible to be done with the system? How easy is it for the user to identify and carry out the appropriate actions? How easy is it for the user to perceive and interpret what happened? And how easy is it for the user to evaluate progress towards the goal? And as we shall see soon, there are useful design principles that help us answer these questions. A key set of these principles include visibility, feedback, mappings, and constraints. And these will be coming up soon. That's it for the gulf of execution and the gulf of evaluation, and that's all until next time. Welcome back. The topic for this video is an introduction to a set of powerful principles for analyzing designs and for creating good designs. And this lecture draws on Donald Norman's book, The Design of Everyday Things. And I'm going to introduce and give examples of 4 major design principles: visibility, feedback, mappings, and constraints. Now, the idea of visibility, it's pretty straightforward. Make the state and operations of a system visible and clear to users. Don't hide controls. So some of you might remember older systems like VCRs or telephones or even digital watches, where a lot of things that you have to do are hidden away and you can only get to them through odd actions like some combination of button presses or so on. And those systems tend to be hard to use. Instead, you want to make the status of a system visible by crafting well-designed displays. Progress bars are a good example, and even using other senses like sound output as necessary to give users a good indication of the state and operations of a system. So I'll start by giving an example of a really bad example of visibility. What you see here is a gas tank, a tank for pumping gas, and it's incredibly busy. And one thing you might wonder is, how do you actually turn the gas pump on to pump your gas? Well, there's a button somewhere, there's a display somewhere that says, here is where you push to start pumping gas. Well, where is it? Well, it's right there. There it is, so we can see it. But you can ask yourself, is that really visible? And in this case, the answer is pretty easy. No, it's not. It's hidden amongst a lot of other busy displays, so it's not visible. Let me give you a couple examples, though, of good design, of making the prominent features, the most important features of a design visible. So here's an example from Gmail. One of the most common things that you want to do when you're in a mail program is compose a new message, is start a new message. And Gmail has a very prominently placed, brightly colored, large button called Compose. It makes it easy for me to see this is how I start a new message. Now another example is something like a toolbar. And I'm showing the toolbar for Microsoft Office here. And there are many things that are visible to me. What this shows me is, what are the options? It shows me the most common options, and it even devotes more screen real estate to the ones that are perhaps most common. And as we discuss elsewhere, you can see over on the left side, there's a large icon for paste, which is one of the most common operations in Microsoft Office. So they have made the common actions visible here. Now the next concept we're going to discuss is mappings. Mappings are used to determine relationships, typically between something you want to control and the thing you use to control it, or between an action and the result of that action. These mappings take advantages of physical analogies or physical relationships and cultural standards. So again, I want to give you a few examples of this. Here's another real-world example, cup lids. So every once in a while I go into some place like a fast food place or even a gas station, and I want to get a soda. I want to get a drink. And after I get the drink, I have this problem of figuring out which of the various sizes of lids is the right one for my drink. And if I look at these, at this picture, what you can see is here are 3 different sizes of lids next to the drink dispenser where I've chosen cups. Okay, and I've got to figure out which is the right lid for the cup I chose. And it can be a little bit hard. Now I want to show you another one. Let's look at this. Here's another drink dispenser where, if you can see, there's 4 different sizes of cup ordered from top to bottom, from smallest to largest, and right next to them there are 4 sets of lids. And so I see a direct mapping, a direct correspondence between each size of cup and the appropriate size of lid. So good mappings, no problem in this case answering the question which lid is the right size for the cup that I selected. Here's another example where I'm controlling, it's an example of trying to control the burners on a stove. And so here's a stove. It has 4 burners. And if you look on top, there are 4 switches, 4 dials to try to control, to use to control the 4 burners. And the problem that I have is knowing how am I going to map the different burners to the different switches. Now, if I zoom in a little more detail to the switches, to the controls, you can see some interesting things. But you can see that they needed to give me further displays because without those displays, the mapping would not have been obvious. And so what you can see is it actually says So the display on the left, it says it's for the rear. The display on the right is for the front. And if you can also see, they have a little image that shows you graphically which of the burners it controls. That's a nice help, but the point is they needed that help because without that, they weren't confident that the mapping between the thing you were controlling and the controlling object was going to be clear. Now here's another stove, and in this case, the mapping is pretty clear. I think if you look at that, it's completely clear to you which switch you would use to control which burner. Now, for other reasons, you may not like having these switches right next to the burner on the surface of the stove, but at least the mapping is very clear. Let's take another example of mappings. Many people have ceiling fans in their bedrooms or whatever room in their house, and those ceiling fans also often have lights on them. And if I'm looking at this ceiling fan, I see two things hanging down, two strings hanging down. One is sort of this fuzzy yellow one, and one is just sort of a normal brown one with a little bobber at the end. And I look at that and I think, which string turns on the fan, which turns on the light? What is the mapping between those two controllers and the two things I can control, the light and the fan? And when I look at that, to me, the answer is not so clear. It's not a great example of mappings. So the next design principle I want to talk about is feedback. So feedback, this is an action that the system takes in response to a user action. And remember that people will build models, as we've seen in another video, and feedback leads to causal models. If Y happens after X, then X caused Y. So feedback is a prime mechanism for helping people understand how the system works and build an appropriate model of the system. So, and this actually is a good time to say, I find that with many of the examples that I use for computer interfaces, these concepts of feedback and mappings and visibility are so widely used that we tend almost not to notice them. And by calling your attention to them, I'm hoping you'll understand these concepts better and then realize their utility and make sure that you include those in the systems that you design. So this is simply, what I'm showing you here now is simply an example of a configuration screen on Dell.com. It shows the XPS 13 laptop. And near the bottom of the screen, there's a number of examples for ways that I might configure this system. And so if I choose one of those examples and I start to hover over one of the options, the system changes the display of that option to indicate that would be my current choice if I choose to make it. So it's responding immediately and giving me feedback, showing me the state and helping me understand how the system works. Here's another example on my phone. I had started to key in numbers, and toward the top it's actually showing me what is the number that matches, what is the actual phone number that matches the digits I've entered so far. So feedback that helps me understand how the system is interpreting what I'm doing, and furthermore, in this case, makes my task easier. Now, there's a few other screens I'm going to show you from Google Now. In Google Now, once I've tapped the microphone or I've said, OK, Google, it will actually give me visual feedback. You can see that red circle in the upper right with circles around it. This is showing me that Google is interpreting that it's listening to what I'm saying. And then as I continue to speak, Google will actually be starting to give me other visual feedback to let me know, yes, it's listening. And as I continue to go on, it will show me its interpretation of what I have said. So again, very useful feedback. The next concept I want to talk about is constraints. Constraints are design features that limit the range of possible actions a user can take. Now, constraints, it's a sort of a funny word because you might think of constraints as being bad, but constraints typically are good. They narrow down the set of options users have to consider, and they make their task easier. Now, there's a whole bunch of constraints. So you might think of physical constraints. For example, if you remember the old VCR tapes, you could only put a VCR tape in one way. USB cables or chargers that you use for your phone or things you use for your smartphone, some of those cables can only go in one way, so those are physical constraints. There's also logical constraints. There's also simple constraints on action you can design into a system. And I want to give you some examples of these because, again, there's lots of examples in the software we use, and it's nice to be able to sort of notice them and observe them and realize what's going on. So one common example is to gray out or deactivate unavailable menu items. So I've simply showed a menu here from Microsoft Office, and if you look at the top two options in the menu, cut and copy, are grayed out, meaning they're unavailable. Why are they grayed out? Why are they unavailable? Because I don't have any objects selected, so there's nothing to be cut or copied. Another common example is constraining user input. So I went to Amazon.com, and you might have noticed this when you choose to order something. One option is to specify how many you can order. And I don't get to just type in free text. Instead, I have to choose a number from a drop-down. And this is a way for the system to make sure that the input I provide is sensible input. Here's an example from the Duolingo system, the language learning software. I have it in the mode of I'm in English and I'm trying to learn Spanish. It's asking me to translate this sentence, and it is showing me a set of words at the bottom from which I should choose to come up with my translation. And so the point here is, for the language learner, at this point, they're not ready to simply type in free text. Instead, they're given a set of clues to help constrain their choice so that they probably have a good probability of learning or of giving the right response. And it's also nice, I wanted to show this second screen. After I've made a couple choices, you see these two grayed out squares down at the bottom between dinner and supper. And this is feedback that actually makes it clear I've supplied two choices already. So this also is another use of one of the design principles in this same interaction that makes it easy for me as the user to tell what's going on. So that was it for our introduction to a set of powerful design principles that we'll be using throughout this course: visibility, feedback, mappings, and constraints. And that's all until next time.
Welcome back. In this video, I want to discuss interacting beyond individuals, how to mine the social sciences to design socio-technical systems. A socio-technical system is a social system operating on a technical base. Examples of socio-technical systems include Wikipedia, eBay, Twitter, Facebook, and YouTube. Compared to designing traditional software or hardware product, designing the user experience in socio-technical system is quite challenging. Even if a designer wants a socio-technical system to be larger, or more active, or more friendly in tone, he or she may not be able to make that happen. The reason is that people are the key factor that influences users' experience in socio-technical systems. People are interacting with other people in these systems. Therefore, people's behaviors, reactions, or responses cannot be easily shaped or programmed the way physical materials or software can. Particularly in Kraut and Resnick's 2011 book, they proposed 5 critical challenges to design a successful socio-technical system. First, a successful socio-technical system relies on rich content to attract new users. For example, new members are attracted to YouTube because there are tons of interesting video clips other participants have posted. People use Facebook because their friends constantly post updates about their lives. However, when the designers try to create a new socio-technical system from scratch, they are faced with critical mass problem. That is, the site does not have enough content to start with. Second, for most socio-technical systems, a major challenge is to identify, attract, and socialize members who have the characteristics, skills, and motivation to contribute. Even established systems must attract a stream of new members to replace those who leave. Encouraging commitment is another challenge. Commitment represents people's feelings of attachment or connection to a group, organization, a community, or socio-technical system. Once the socio-technical system attracts new members, they want to keep the members around by increasing their commitment to the system. Next, to be successful, socio-technical systems not only want to keep their members around, but also want their members to contribute the content on which the group's existence is built. Finally, the people who participate in online groups often have different and sometimes competing interests. For example, people often post controversial, irrelevant, or off-topic messages to provoke other users into an emotional response. The challenge here is to regulate some people's inappropriate behaviors and limit the damage these behaviors might cause to the whole system. So in this video, I want to briefly talk about how social sciences can help to deal with these critical challenges. Economics and various branches of psychology, especially organizational behavior, social psychology, offer a series of individual motivation and human behavior in social settings. Properly interpreted, these theories can inform design choices about how to build a successful system. Let us take feedback as an example. Feedback can be in the form of messages, ratings, or simply a button to click to indicate liking or disliking of something. Basically, feedback tells people how others have reacted to people's participation. Social science theorists tell us that different types of feedback, like positive feedback, negative feedback, directive feedback, social feedback, can have very different effects on different people, like newcomers, old-timers, on different levels, like self-level, task levels. So here are two real feedback messages editors receive in Wikipedia. The first message is an example of positive feedback. This editor just sent a message to another, says that, "I'm so impressed, this is a very fine article." The second message is an example of a negative feedback. There is a concern that the rationale you have provided for using this image under fair use may be invalid. If it is determined that this image does not qualify under fair use, it will be deleted within a couple of days. According to social science theories, positive feedback signals that performance exceeds the standard. Therefore, when people receive positive feedback, although they are encouraged, but they typically maintain their efforts or even reduce efforts to the specific task. Negative feedback, although it might discourage people, also signals that their performance falls short of standards, leading people to increase efforts towards the specific tasks. When appropriately using both positive feedback and negative feedback, social technical systems like Wikipedia can motivate people's contributions, direct their contributions to the important tasks, and coordinate these contributions to maximize the benefits for the whole system. Here is the takeaway. Social sciences are very good tools to guide the design of socio-technical systems. If you are interested in knowing more about mining social science to design these successful systems, you can read the following book and the papers. Thank you for watching this video. I hope we can see you in the next one.
Hello and welcome back. Today we're going to talk about high-level models in human-computer interaction. And there's three theories that we're going to get to. We're going to talk a little bit about distributed cognition, activity theory, and situated action. And as before, I can really only give you a brief overview of these theories as they're actually quite complex. And so I want to start with something more general. So what does it mean for a theory to be valuable? At this point in the course, you've probably heard about some low-level theories like Fitts' law. And that theory really makes sense. It's about how fast somebody can click between 2 points. It's very measurable, it's very predictive, and a lot of people find it to be valuable. But I read a paper when I was first studying high-level models that talked about kind of what theories can contribute to a field that went beyond just this idea of being predictive. And so I include a citation to that paper here, and if you have access to the digital library, you can follow along. But I'll cover the main principles from it. So the main tenet of the paper was that the value of the theory is not whether it provides an objective representation of reality, but rather how well it can shape the object of study, highlighting relevant issues. So in complex high-level theories, the goal is not to be able to perfectly predict what's going to happen. Usually these theories address settings and contexts that are so complex that it's very unlikely that you're going to be able to predict things directly, but rather does it let you focus on issues that are most relevant. So in the paper, they discuss 4 powers of HCI theories, 4 things that make HCI theories good. And these are descriptive, rhetorical, inferential, and application powers. So let's go through each of these in more detail. Descriptive power is whether the theory provides you with a conceptual framework to make sense of the world. So does it take a really complex situation and make it make more sense without maybe oversimplifying things that are really important to understanding it? Rhetorical power is about the ability to describe the situation both to yourself and to others. So some of this is kind of the idea of language, like how do we term these complex interactions that are happening in social settings, for example. Inferential power is about the ability to make inferences or predictions about phenomena and interventions. This is kind of what I described with Fitts' law. It's very good at making inferences. If you tell me how big 2 targets are and how far apart they are, I will frequently be able to make a pretty good prediction about whether a person can click faster between setting A or faster between setting B. But that's not necessarily the case with high-level theories. And lastly, there's the application power. So can applying this theory inform and guide system design in some sort of a way? And so usually at this stage, I actually ask my students to reflect on whether Fitts' law measures up using these attributes. And I'm always kind of hesitant about Fitts' law because I think it's so low level that frequently it doesn't provide a whole lot of value for designing complex systems. And students, knowing that I'm very hesitant about Fitts' law, try to be very critical towards it as they evaluate it. But in fact, I surprise them by telling them it actually does pretty well on all of these criteria. It does provide a very good conceptual framework to make sense of a very specific interaction, which is how fast people click between 2 points. It does let us describe this to ourselves and to others. So for example, if we describe the size of a target and how far away it is from another target, we've actually described the entire situation. It lets us make inferences about how fast people are going to click, and it lets us apply this to inform design. So for example, putting menus at the top of the screen so that essentially it becomes an infinitely sized target. Other theories are not necessarily quite this straightforward. So the 3 high-level theories we'll talk about today are distributed cognition, activity theory, and situated action. So let's start with distributed cognition. And those in the know call it DCOG. So if you want to call it DCOG, you'll be one of the cool kids. So some key tenets of distributed cognition is that action is coordinated among embodied agents, where an agent could be a person, or an agent could actually be a device. So for example, if I am making a shopping list, I'm actually coordinating actions between 2 embodied agents. Myself, I'm the embodied agent who has some ideas of what to buy in the store, and my notepad, which is actually going to store those ideas for me to reference later. Both are actually embodied agents. So in essence, I'm kind of delegating the work of remembering to my notepad. Information itself can be embedded in an object or in an action. For example, in that notepad, I have embodied the information of the things I need to buy in the store. And all of this is part of a kind of a large cognitive ecosystem. So all these different agents who work with a shopping list, maybe I give the list to my husband to go buy things at the store. We've added another agent to the system. All the devices that are used along the way. So maybe he then decides to do some comparison shopping using his phone. So now the phone is also an embodied agent that's part of this ecosystem. all of this is part of a single system, and you have to understand how it all works together in order to understand the entire system. So this was a theory that was originally developed by Edwin Hutchins, and he actually originally developed it by looking at how pilot, co-pilot, and the devices in an airplane cockpit all work together. So he looked at this idea of speed bugs, which were little plastic bits that the pilot could place on the speed dial of their airplane, as you see in the photograph. And they all signified special things, such as, when the arrow is close to this speed bug, that means I need to decelerate or I need to open the flaps of the airplane. I personally don't know how to fly an airplane, so I'm probably saying completely ridiculous things about it. But it became kind of a visual indicator. So no longer did the pilot need to remember exactly, at 150 is when we need to decelerate, but rather they could just compare whether the arrow was close to the bug or not close to the bug yet. And so in some ways, that process of cognition, the process of remembering the correct speeds at which to do certain actions, was actually kind of embodied in the actual physical devices that were part of the cockpit. So when doing distributed cognition, I think the most important thing is actually to ask yourself, what is the unit of analysis in this cockpit, or in this context? So what Edwin Hutchins found is that in the context of an airplane cockpit that had a pilot and a co-pilot, the unit of analysis that was meaningful was actually the entire cockpit. So if you just observed the actions of the co-pilot or just observed the actions of the pilot and didn't have any context about the kinds of technologies they used, you would have had an incomplete picture of the kinds of actions that they took and the challenges that they faced in flying the airplane. Activity theory sort of extends this idea of what is a meaningful unit. And it actually posits that maybe the entire activity, so the process of acting upon an object to transform it into an outcome, maybe that can actually be the unit of analysis of a system. Activity theory, really, one of the key tenets is the continuous change and development of systems. Systems don't stay the same. And lastly, it's the fact that artifacts such as tools, rules, social structures around an activity all mediate how an activity is done and specifics of that activity. So activity theory is frequently represented as this kind of a triangle. So if you look on this triangle, you see the subject, that is the person doing an action. There's kind of a line, a light line connecting it to the object. You can think of the object as the objective or the thing that's being transformed into an outcome. So that's kind of the goal of the activity. And if you notice, there's kind of a light line or a dashed line between the subject and the object, because if there's a tool that's required in order to manipulate the object, then that tool mediates that interaction. But activity theory also recognizes that people very rarely act in isolation. People are frequently parts of communities, part of a social context. And so one of the things that you notice is that the community can also affect the object. The community typically affects the object through a process of division of labor. So every person who's kind of part of the community may have some responsibility for some part of the goal, some part of the object, and that mediates the interaction with it. And lastly, the subject, the person who's doing the action, is not just kind of part of the community outside of any sort of context, but rather their interaction within the community is mediated by the rules of that community. And so this kind of captures the main principle, though lots of people say that actually all aspects of this model are connected to all other aspects potentially. But typically this is the way you see it represented, as a triangle. So let me give you a concrete example from my work. So I was looking at how parents raise children in divorced families, and actually it made a lot of sense to talk about it in terms of activity theory. So if you think about the objective, the goal of the system as raising a child to become a successful adult, there could be a number of subjects. So the remote parent, the local parent, the child themselves, they all contribute to this objective. Now in the process, they're actually part of the community. So the child may have two different families that they're part of, their mom's family and their dad's family. They also are part of a larger community, for example, the school. They may have extended family that are also part of this community. And the way that the parents and the child interact with the community is through rules. So that may be specific household arrangements, custody arrangements, cultural conventions. All of these are part of it. Now, when you're apart from the child, frequently the way that a remote parent would interact with the child is very much mediated by tools. So things like the telephone or Skype or sending a letter. These are all examples of tools. And there's also this idea that if the whole community is responsible for raising the child in one way or another, there's some division of labor. What is the child responsible for in their own upbringing? What are the parents responsible for? What are the teachers responsible for? And so actually kind of classifying the problem in this way made me think about all the aspects of it, and perhaps aspects of it that I wouldn't have thought of. So, for example, maybe I wouldn't have originally included the consideration for the extended family or the consideration for the child's school as part of my analysis. But by classifying it as part of the community, I was forced to think about these issues. So a little bit of kind of review and also talking about the relative strengths of distributed cognitions and activity theory. So distributed cognition really has a very flexible unit of analysis. So for example, I'm in the studio right now, and I may decide that the unit of analysis here involves all of the technology in the studio, me and the cameraman. We're all part of a single unit of analysis. Or I may decide that maybe the unit of analysis is better set as the MOOC, and all of the different professors who are involved in it are part of the system. One interesting part of distributed cognition is that it really focuses on kind of exposing system working. So small things like how do we use the tools to achieve what we're trying to achieve, how it all contributes to the larger system, to the larger ecosystem. And many people find it to be more easily applicable to design because it's sort of, you can clearly see the role of specific technologies in the process. In contrast, many people find that activity theory constructs the names better, so it's easier to actually refer to different aspects of the system. So if you want to talk about the community, it's maybe more difficult to do that in the context of distributed cognition because you have to draw up new boundaries. The other thing is that activity theory really emphasizes individual agency. So while both in distributed cognition, both I and the notepad on which I write my shopping list are actually sort of equivalent, we're both agents in the system, activity theory doesn't think that way. The notepad becomes the tool, but I myself am the subject. I have agency, I have motivations, I have goals that I'm trying to accomplish, and the notepad does not. So it kind of separates this idea that people and technology are different. And the other thing is activity theory really thinks about this idea of process and really forces you to consider how that system is going to change over time. And distributed cognition is really more about capturing something at a particular snapshot, at a particular moment in time. But I also like to say that the two are actually quite similar, so that both can be applied in a wide variety of situations. They're both particularly relevant to social and collaborative computing, where you're not just dealing with a single subject, single person, single agent, but rather with a whole system where there may be multiple people interacting with something. They both try to incorporate this idea of social, cultural, and cognitive context. The idea that we're not just doing our action in a lab with nothing else around us and nothing else influencing us, but rather that we're all doing it as part of a larger system. And actually the methods used by both of these are actually fairly similar. Frequently it's ethnographic data collection, so really getting out in the field, observation, contextual inquiry, really asking people questions to figure out what they're doing, and observing them to see how they go about the steps of achieving their goals. And so now I want to talk just a tad about situated action. And this is really a theory that I feel like I can't quite cover in the time that I have. And so if this sounds interesting to you, if you have kind of questions based on what I say, I know I did have a lot of questions when I first read about situated action. I really encourage you to read Lucy Suchman's book, Plans and Situated Actions. And as you see, the subtitle of it is The Problem of Human-Machine Communication. So it is actually immediately applied to technology and how technology affects people. And the main tenet of situated action is the idea that human beings are master improvisers and explainers. So frequently we like to think of ourselves as having a plan and then doing our actions one after the other in order to achieve the plan. And this book uses ethnographic data to really challenge that assumption. It points to the fact that humans just do, and only when they're asked to explain what they're doing did they retroactively come up with a plan that would have accounted for their actions. So kind of a few basic tenets that go along with this. So plans are representations of situated actions. So actions are situated in the sense that you kind of are doing your best in any moment to do the next right thing. Whereas a plan is just something that may be used as a resource or used to represent whatever you did after the fact. In fact, these representations, like actual step-by-step plans, typically only are witnessed and occur when an activity becomes problematic. So for example, if you are riding a bike, you're not really planning on how to ride a bike. You're not planning to put your left foot on the pedal and push, put your right foot on the pedal and push. You're just doing it. But if I stop you and I ask you, hey, can you teach me how to ride a bike? Fun fact, I actually don't know how to ride a bike, so this would be a useful interaction. if I stop you and ask you, how do you ride the bike, then you're actually forced to consider and think about how you would plan on going about the process. Well, you need to gather some speed so that you don't actually fall over when you go on the bike. And here's how you turn. You have to kind of lean your body into it. But you only come up with that plan and that explanation of it when I make it problematic, when I ask you to account for it, when I ask you to explain what's going on. The idea of objectivity, so kind of the objective right way to ride a bike, or mutual intelligibility, which means how do you explain something in a way that both people can understand it, is not a given, but rather something that is achieved through hard work. We both have to work together pretty hard to make sure that your explanation of how to ride a bike is intelligible to me, and for you to understand that my understanding of it is actually what you meant to communicate. And language is seen as a central resource for achieving that objectivity, which is why it can be so important to observe two people who are interacting together around technology and observe the kind of things they say to each other through the process. So just kind of the quote that I really like about situated action is that a basic research goal for studies of situated action is to explicate the relationship between structures of action and the resources and constraints afforded by the physical and social circumstances. So this idea of how do you explain actions as they occur given the specific constraints around the social situation of the participant or the kinds of physical tools that they have around them in order to achieve the action. Now, this may sound just really hand-wavy. These are very high-level models, and I don't expect you to really know each model inside and out from a 10-minute lecture. What I would encourage you in doing is actually reading more about these models. I'll give you some resources at the end of these slides. But also knowing that there are a lot of these high-level models that work in certain contexts and are good at explaining certain parts of the problem, that have high rhetorical, high descriptive power, maybe high application power, but are not so much good at predicting what a person is going to do. And there are in fact also other theories that are quite relevant to HCI that may be relevant depending on the context you're working in. And these I'm not going to cover at all, but basically just to give you ideas of what some of them are called, names of terms. The actor network theory is a really popular one that treats sort of people and objects all as part of a single network. If you're doing anything that involves people to learn, it might be useful to you to look at a few learning science theories like constructionism and constructivism. If you are designing a system where people are exchanging social capital or goods, economic theories may be really useful to you. Of course, psychology theories are, I think, useful to every HCI and user interface designer, and we do cover quite a few of these in this course. But also, if you're working with a specific age, so whether it's children, elderly, adolescents, it's useful to also maybe take a look at some human development theories to know what is developmentally appropriate for a particular stage in life. So as I promised, here's a few citations for more information. So for situated action, I really point you to the book by Lucy Suchman. I think it is impossible to explain it well in 5 minutes, but hopefully you're at least familiar with the terms enough to know when they may be applicable and to know if you're confused. And the other paper is the paper that I started this lecture with, the paper that considers the different powers of theories, and in fact that actually talks about distributed cognition and activity theory in terms of these 4 principles. So this Role of Theory in Technology Design paper by Halverson I think is a really good read and a fairly straightforward read, so I really do recommend it. So thank you for joining today. I know this is quite a different set of theories than ones we've covered in this course before, but hopefully you learned something new, and I'll see you in the next video.
Well, welcome back, everybody. In this video, I'd like to give an overview of your interface critique assignment. Now, you remember the Hall of Fame, Hall of Shame assignment you did earlier in the course. In that assignment, you found a design and explained why you thought it was good or bad. But we're now at a point in the course where you've learned some design concepts and principles that will let you do a more systematic evaluation of an interface design. So what we're going to do in this assignment is actually give you a few examples and have you analyze them in terms of the concepts and principles that you've been learning in this course. So what are some of these concepts and principles? Well, here's a list of most of them. We've talked about conceptual models, the gulf of execution and the gulf of evaluation, visibility, feedback, mappings, constraints. and a number of interesting and relevant properties of human cognition, short-term and long-term memory, how people focus on information, attention, and kinds of mistakes people are prone to, errors and slips and so on. In earlier videos, we gave examples of these, and I'd encourage you, if you want, to go back and refresh your memory of these principles because you will be applying them in this assignment. So what's the structure of this assignment going to be? We're going to give you 3 example interfaces, which we'll present as screen captured videos or screen images, and you will have to develop a critique of each interface. Now, critique simply means a detailed analysis and assessment of both the good and bad aspects of the interface, if there are both good and bad. You must include at least 3 notable aspects of the design. They could be all good, all bad, or some of both. And you have to explain why these features, these aspects are good or bad, using concepts that you've learned in the course. Now, once you've done this yourself and posted your own critiques, you will do formal assessments. You'll do peer evaluations of 3 critiques from other students. And in the assignment, we're going to give you a formal rubric for how you will be evaluating the other students' critiques. Now, this is, we want to make sure that you can do a thorough critique of these interfaces and you sort of know what's expected. So we're going to do quite a bit in this assignment to prepare you for that. We're going to give you, as part of the assignment, several examples of interface designs, along with critiques for each one that we have written. And you know what? We're going to give you both good critiques that identify quite a few of the relevant aspects of the design, and that do a good job of using course concepts to explain why they're good or bad. We're also going to give you some examples of bad critiques, so you can start to get a feeling for what counts as a good analysis, what counts as a bad analysis. You'll then have the opportunity to do a critique of another interface design for practice, where we're not going to tell you in advance what we think are the noteworthy aspects and why they're good or bad. Instead, you'll do that, you'll come up with that, and then you'll be able to compare it to the critique that we came up with. Now, after you've completed this critique and you're satisfied with it, you'll get to look at our critique and compare it to ours and see where you agreed, where you might be different, and see if you feel like you've fallen short and how you might be able to do better. And finally, when you're done with this, you can go on to do your critiques of the 3 example interfaces that we're going to give you for this assignment. So let's take an example. Okay, this is the TripAdvisor.com website. TripAdvisor is a popular website and app, at least in the United States, for finding information related to traveling, to trips you might take. And let's look around at this site a bit. As I look around, I guess one of the first things I notice, it looks nice to me. Things seem like they're well laid out, so far so good. And I guess one of the concepts that comes to my mind that we've learned about in this course is visibility. The kinds of things that I can do in this site are clear. Okay, so what can I do? I see across the top a tab, hotels, flights, vacation rentals, restaurants, things to do, best of 2016. I see a text box, find, hotels, restaurants, things to do, near, enter a destination, and then I can search. Very clear what I can do, very visible. And down below, yet another way to do that. Hotels, flights, vacation rentals, near, city or hotel name, the dates that I need to specify. So it's making very visible to me the things that I can do. Slightly more subtle, but on the same point, I see, even though I can search for hotels, restaurants, and things to do and so on, down below the choice that's highlighted is finding hotels. And I think, well, probably that's the most common option people use when they use this site. And so it saved me a little work by making that be the selected option. one other thing I noticed that's interesting is I've used TripAdvisor before and actually have created an account. So I see, oh, look, it remembers me. It says, hi, Lauren, up here. And so that's interesting. It's made that visible to me that, yes, I've registered for the site and I'm logged in. So that's helpful to me. Okay, so what else do I notice? Well, I look around and I think, here I have to provide dates, and the way I do it is with a date picker. Okay, so that's good. So my input is being appropriately constrained. So good use of constraints. Here's another use of constraints, I guess. I'm not being forced to only enter hotels, restaurants, or things to do, or a city or a hotel name down here, but I'm getting hints. They tell me what kind of input is expected there. So again, it's a good constraint that's going to help me to provide appropriate input. So visibility and constraints are design concepts that are helping me understand noteworthy aspects of this design. Okay, well, let me do something simple. It's really hot here where I am in Minneapolis today, probably the hottest day of the year. So I want to search for a hotel in a cooler place. So Duluth, Minnesota, it's on Lake Superior. It's usually cooler, so I'm going to search for a hotel. Oh, look, I clicked on that, and immediately I get feedback, and I can see what my options are. So again, visibility, it is now visible to me what I can type in here, or what is good input, and the system gave me immediate feedback based on my response. So I'm going to say hotel, so that's great. And now the system, in response to that, moved the focus over to near. So very useful. I don't have to go click over there. I'm already over there. So good feedback. And I want to type Duluth, Minnesota. Oh, look. And of course, the system is responding to what I'm doing and giving me autocomplete suggestions, which is a useful kind of feedback. Now, it's nice that Duluth, Minnesota is right at the top. There's a city called Duluth in Georgia, and there's a city called Delulu in Queensland, Australia. I'm not sure if Duluth Minnesota's at the top because it's a bigger city than Duluth, Georgia, which is true, or because it's closer to me. But in either case, good feedback, very helpful. So I'm going to do that. And TripAdvisor goes on and does the search, so that's great. So what have we seen so far? Really good use of visibility, feedback, and constraints. So let me just take a quick look at the search results page. I'm not going to spend too much time here, but one thing I notice here is, oh look, here are all the hotels that sort of came back in Duluth, and pictures. And pictures are sort of obvious here, but again, they're helpful because they're making relevant information. In this case, something about the hotel, its location, or what rooms look like, it's making it visible. And so I find that helpful. What else can I see here? Lots of information. So here are 3 tags shown for each of the hotels. And if I look at those tags, what I know is if I click on them, it will further narrow my search. For example, if I click on Pets Allowed, I can immediately narrow my search to only hotels that in Duluth that take pets. So again, the system has made visible to me what I can do, and as I clicked on it, it gave me immediate feedback. It narrowed the set of search results. So again, really good. Let's see. So I think I've already given 4 design features using 3 concepts from the course: visibility, constraints, and feedback. So I could be done, and in fact I am about done, but I did want to mention one other thing. There's lots of things I could mention as well, but if I look down here, I'll scroll down a little bit further, excuse me. Yeah, I can see, let's just take Days Inn Duluth by Miller Hill Mall. I'd say this is a little bit of a stretch, but a pretty good mapping of actions to objects that I can take the action on. So if you notice, here's again Days Inn Duluth by Miller Hill Mall. What can I do with this? I can view a deal on Expedia, 128 dollars a night. Or I can go to TripAdvisor, Hotels.com, Hotwire, and I can view 7 deals if I want 7 deals in total. And so the point is, there's a good mapping between this object, this hotel, and the actions I can do on it, and even mappings between different booking sites, in this case Expedia, TripAdvisor, and so on, and the price that they will offer me. So good mappings as well. So that's an example with TripAdvisor of the kind of critique we would be looking for you to do on a site or on an app, the ones we're going to give you. Look at it, sort of reflect on what are the noteworthy features. I did 4 or 5 different features here, and all of them I could analyze in terms of concepts from the course. In this case, I used visibility, constraints, feedback, and mappings, and that's what we'll be looking for you to do in this assignment. Okay, well, just to say what I hope is obvious, that was a good critique. For the reasons that I said, I identified a lot of noteworthy features and I used the course concepts to explain why they were noteworthy. But I wanted to remind you that when we give you the written assignment, or when you see the written assignment, we are going to include some examples of bad critiques as well, so you'll know what to avoid. So that's it for the overview of the interface critique assignment. Here's another one we hope you'll have fun with. We hope it will give you good practice in applying these powerful design principles and concepts we've been teaching you, and we'll look forward to seeing you next time.
Welcome back. As we bring this first course towards a close, I have the distinct pleasure of bringing you an interview with Don Norman. As you may know, Don is a thought leader in the field of user interface design. He's the author of Design of Everyday Things and many other books, but Design of Everyday Things being the one that we've worked through many of the principles of the psychology of user interfaces from. He's also principal and co-founder at Nielsen Norman Group, and currently serving as well as director of the University of California, San Diego Design Lab. Welcome, Don.
Thank you.
So since we have a set of learners here who've been introduced to a lot of the basics of UI design without having stepped through all the details yet, I thought it might be useful to get your perspectives as somebody who has really helped launch this field and has guided it in both industry practice and in research, to tell us about where you see things having changed over time, the evolution of bringing in design practices on top of engineering practices in the field, and where you think we're going.
That's a big question. So, in the beginning, and this is true of the computers, but it's actually true of almost every single technology. In the beginning, the original technology developed by, well, hobbyists, tinkerers, engineers, technologists. And they're really very interested in what it can do. There's great potential. And they don't understand people. So that usually these first things are difficult to use, and which is okay, because it proves that the technology actually can be of value to people. The second phase comes when it becomes more popular and people have great difficulty with it. And they have difficulty using it, difficulty understanding it, and in some cases, this leads to serious incidents, serious accidents, and deaths even. So at some point, the profession wakes up and then tries to understand what they might do. At the last, roughly 100 years, a little bit less, there has been a profession, human factors, which has been very concerned about the way that people interact with technology. And that interest has now expanded into a number of other areas. For example, the field that we call human-computer interaction, which is probably the major basis for the course you're now taking. The real point here is that you have to understand people and the way that people do things. And you have to do this not by asking them, but by watching. by watching and see them, what they look at, what they struggle with, what they find easy, what they find hard, and accept what you see. A traditional problem that we have with engineers is that engineers think it's all very sensible and logical. And when somebody isn't doing things the right way, they say, why are they so stupid? And they really like to go over and say, look, just do this, can't you see? And I have to explain often to the engineers that the problem is you're being too logical. You have to take people the way they are, not the way you'd like them to be. And people are not logic. I mean, logic was invented. It's not a natural way of thinking. So people are emotional, and that's good, because emotions are where we have our values, where we decide what is good and bad, safe and dangerous. And people do use reasoning and logic, but they also use past practices, what they're used to. So the first step in any industry is understand the people and understand the task and design it for the task and the people as people are, not as you would wish them to be. And in the field of computer technology, I would say that's where we are, that almost every single company that develops products today has somebody from the field. They may call them human factors, they may call them user experience designers, they may call them human-computer interaction experts, but they usually have somebody or some small team. They often don't put the team, they put the team at the end saying, hey, we're all finished, now make it easy to use or understand or make it pretty, which is the wrong way to be used because, if we're really watching people, we can tell the company or yourself, here's a great new product we could develop that nobody ever thought of. We discovered this real need. And I think that's where we are moving. And so the future is that direction where we actually base products on what people really need as opposed to what a technology can do. But there'll always be a mix of the two. But that wasn't really the question. I think the real question was, the technologies we use are changing rapidly. There's a good example. Last night I had drinks with a friend who works for HP, the company that makes a new 3D printer. And we talked about the way that this new 3D printer is going to change manufacturing, and more importantly, the kind of design tools that we will be using for the 3D printer are completely different than anything you've ever seen. Today, when you design, and what you'll be taught in this class, is actually a pretty low-level design in the sense that you're going to be designing the controls, the menus, the structure, every little detail you'll be thinking about and trying to understand how that fits, how it provides the right function, and how it makes it easy for people to understand and use. But imagine a design process that's this. I have a smart design tool, and I tell it my goals. Maybe I'll tell it cost, maybe I'll tell it size, maybe I'll tell it weight, but also I'll tell it the functions that it has to produce and what the goals are. And then I'll sit back and let some kind of genetic engineering or genetic algorithms or neural networks or who knows what, machine learning, develop some possibilities. 5, 10, 1,000. And what I do as a designer is I look at them and I say, wow, I never thought of that, or that's horrible. And so what I'm doing is I'm training the system and I say, go in this direction, or no, don't do that. And I end up, me and the device, designing in this really wonderful collaborative way, ending up with something you've never seen before. Can you imagine what the role of the designer is like that? Are you ready to be that kind of a designer? It's really quite exciting, but it's a completely different way of thinking. And the reason this came out with 3D printing is because with 3D printing, you can produce devices that look completely different than anything we've ever done before. We can make things with different shapes that are hollow insides and therefore that are much lighter and stronger than anything we do conventionally. So that's the physical side. Now consider the, if you will, the usability side, the cognitive side. What's going to happen there? I think we'll see a similar revolution. So That's one direction we're going to move. But the other direction is, geesh, we're moving into virtual reality, augmented reality, new types of haptics, feeling, gestures, presence, sensors in everything, telecommunications. It's going to be an exciting new world, and you're going to play the major role because it's people like you who are just starting that's going to make the big difference. That's a good introduction. There's more that I can say, but I'll let you drive me to it.
Well, I think it's a fantastic vision. I'm going to ask you a couple of pointed stops along the way in that vision. I know when I joined this field, there was a dominant strategy, what was called typically usability engineering, that said, look, we're not smart enough, we don't know enough to get it right. Let's just build something and run it through some tests and make it better. And even back then, there were people who were pushing against that strategy. They were saying, wouldn't it be silly if the way you designed a house was to say, well, let's build it and see where it turns out that you walk into the wall, and then we'll tear it down and put doors there. But the concept of let's be iterative pretty strongly caught on. And then there was this wave, maybe led by folks in industry, places like Apple, that had designers in more leading roles that said, maybe this isn't about iterate and perfect, because iteration only gets you, to a local maximum. Maybe this is about how do we get somebody skilled enough that the thing they design already has built in all of this knowledge about how people do things and what they need and what they don't even know that they need. And we spent a lot of time envisioning how do you create that kind of a designer. And I'm hearing you talk about the idea that maybe we need to think about the tools for those designers that allow them to go beyond. But could you reflect for a minute about this tension or transition between the engineering-focused approach to usability and the design-focused approach?
In the end, I think that there isn't a tension, that we're going to need all of these different approaches. I'm actually a firm believer in when you're not quite sure what you want to do, is just do something. Build it. You have no idea what you want to do, build something. See what happens. See what people make of it. See what you make of it. And iterate your way through. Yes, say, oh, that doesn't work. Oh, gee, I never realized that people would think of doing this with what I just did. That gives me an insight for a whole new direction. And actually, I designed a house like that. Kind of. I mean, we bought a house here in Southern California with it was a one-story house, and we said, oh, it's kind of old. Why don't we remodel it? And so we brought in some architects, and the architects, they came to the house and they climbed up to the roof and they sat on the roof for 3 or 4 hours. And when they came down, they said, you're going to put a second story on this house, and we're going to put the living room and the dining room and the kitchen on the second floor, because on the second floor you can see the ocean, you can watch the surfers and the whales and the dolphins, and we never thought of that. So they started with that vision. But then we said, well, what's it going to feel like? How are you going to design the insides? And they gave us a rough plan, and we said, no, that doesn't fit. So what we did is we went to the apartment we were living in, my wife and I, and we took tape and we put it on the floor, and we took boxes. And so we taped out roughly the kind of area that we thought we would have in the new house. So we put boxes where we thought we might put the table here or the counter here or the sink here. And we made believe we were cooking for quite a while, and we kept moving things around. And we brought these ideas to the architects. And even while they were building the house, when it was just framed, we went upstairs into the second floor and we made believe we were cooking, and we said it isn't going to work. And we had them change it. And the result was spectacular. It was really wonderful because we tried it out. Now, you can't do that with big, expensive homes. You can't do that with big, tall buildings. But actually today with virtual reality, you can do that. You can actually build it and make believe you're walking through it, and it really feels real. And you can change things. And I've heard of architects who say they made major changes in major buildings because of this technology. So that's one step. Second, we have quite a bit of science that we can use. In the book, The Design of Everyday Things, there's quite a bit of that. And you'll probably learn others, because this book doesn't contain all that we know. But as a result of the fact that we know a lot, we don't just start from scratch. We start with knowing a lot about how people work, the kind of clues they need to make them understand what is happening. So we start with that. I also am a firm believer in watching people. I don't think we're ever going to have the knowledge about what people really need, because every time we build something, it changes what people need. It changes how people work and what they think is possible. So it's always looking to the future, and it's our job as designers to watch people and say, why are you always stretching like that? Or, well, gee, I see you taped these two things together. Why did you do that? Or why are you bending? Or why did you? That's interesting. We see you putting things on the stairs. Why do you put things on the stairs? Oh, they're reminders. Well, that's interesting. Why do you need reminders? So I think we're always going to need someone who has this brilliant new idea and says, let's try this. No one's ever thought of this. And someone who's just modifying what exists, making it better, maybe watching how people use what exists and suggesting changes. And in all cases, in the end, I believe that we have to do this prototype. We do something rough. We make it so that people can try it out. We watch what they're doing, and we realize that we have to change it. And yes, that gets us better and better. But as you said, it gets, if you think of, there are these hills all around us, and the higher up you go, the better it is. And so if you're on a hill, it's really good to get to the top. Now, that's what this iteration does. It gets you to the top of the hill. But it doesn't necessarily get you to the highest hill. In fact, you guaranteed you'll get to the top of this hill, and there's no way to get to the higher hill, because any direction I move makes it worse. Start going downhill again. So the only way to get to the higher hill is, well, actually there's several ways. One is, don't make one product, make 6 of them. And they're probably all going to be on slightly different hills, and you'll see which one seems better. Or second, that's where watching and being creative, and that's where the great creativity comes from. That's actually where inventors and tinkerers are so wonderful. They have some idea and they try it, and it's crazy and crappy and looks horrible, but it moves you in a whole new direction. And what you have to do is not look at it and say, ew, that doesn't work. You have to look at it and say, wow, that's a really interesting possibility. It's not very well done, but suppose we did it well. Maybe we'd be in a whole new space. This happened, by the way, with digital cameras. The first time people were starting to get rid of film. You know what film is? It was that piece of cellulose. It was chemicals, and you expose it to light, and then you had to keep it in the dark until you could put it through chemical baths, and it came out as a picture. No, you don't remember that? Well, that's how we used to do pictures. And when someone first said we could do it with a little digital camera, well, the pictures were pretty rapid, pretty crappy. And so they were rejected for a long time, even though that's all that we do today, essentially. So you have to be careful here that the first few products of a revolutionary new idea are often really bad. It's as if, yeah, this is a higher hill, but I'm starting off at the bottom, way down, the very, very bottom, where I'm so much lower than what we can do today. Why would anybody ever want to do that? So here's your challenge. Sometimes those other things are the correct way. And sometimes those other ways, like flying automobiles, are the wrong way. How do you know which is which? And the answer is, you don't.
Neat challenge and a neat example. I love the digital camera example, because not only were the original pictures not very good, but I think part of the challenge is the people using and building those cameras didn't know yet what they were going to be good for. And they couldn't have imagined that most pictures would never be printed and would be mailed around and posted in a form where not that good was good enough because they were going to be displayed on a watch or a cell phone. And obviously, because they persevered, we've gotten to a very different age of photography. But
That's right. But it's interesting because all sorts of experts like me said, yes, I can see why these pictures will be wonderful for social interactions because they're not really very good. But, who cares when I'm just trying to show my new child or my new friend or, where I was. But they just can't be any good, we said, because look how small the camera is. Look how small the lens is. Look how small the detector is. Physics tells us it just can never be very good. There's not enough light quanta hitting the detector. So see, you're always going to need a big, real camera to take really good pictures.
Well, we were wrong.
It's amazing how the technology has improved. So even the very tiny little camera in your cell phone takes pictures that are equivalent to what we used to get out of expensive cameras. Now, it is still true that if you want a really great professional level picture, we use a bigger camera, which has a bigger detector and a bigger lens. But it's been amazing. The more we knew about technology, the more wrong we were. It's a real difficulty if you think you know too much, because you know the limitations today. The people who didn't know about the limitations, and therefore, poof, they went past them.
Yeah, indeed. Well, let me ask you one last technology question as we close, which is a technology I know you've been following is what's going on with automobiles today, and automotive technology, including smart cars and self-driving cars and interfaces for systems in cars. Obviously, that could be a topic for a whole nother discussion, but is there something you've distilled from this that might be a lesson as we think about what we need to know about people and keep in mind as we think about designing the technology?
Yes. I think that automobile driving is actually not a good thing for people to do. Now, a lot of you listening to this will say, "What? I love to drive. What do you mean? I'm really good at it. It's really fun." It's not really fun. Look, for years, I owned a Porsche, and I really loved driving, and I took driving classes, and I took my Porsche out of the racetrack, empty racetrack, and did all sorts of wonderful things with it and with my sons. But that's wonderful. But, every day when you're on the highway and it's rush hour and you're just sitting there and hardly moving and it takes a half hour or an hour to get to where you're going, when it should really only take 10 minutes, that's not fun. But that's how driving is more and more. On top of that, in the United States, roughly 30 to 35,000 people die every year in automobile accidents, and about 1 million are injured. And in the world, about 1 million people die every year. That's not something that we should really allow to continue. And so fully automated driving has the potential to reduce those deaths dramatically. Well, we're making huge progress, much more rapidly than ever we thought. But the problem is the engineers think they've gotten even more progress, and the engineers have left out the human element. And sure, can we do highway driving automatically? Yes, that's the easiest part. Because in highway driving, the people are really pretty constrained, and you follow the car behind you. Sometimes you change lanes, but the lanes are often marked, and you can pass or not pass as long as you can look around you. And we believe that sometime in the year 2017 or 2018, almost every automobile manufacturer will have their luxury vehicles do completely automatic driving on the highway. What about the city streets? The city streets, no way. Because of the city streets, all sorts of unexpected things happen, and people do all sorts of bizarre things. And on top of that, people will see these automatic cars coming, and therefore they'll say, "Hey, I don't have to worry. I know it's programmed not to hit me, so I can just cross the street. I don't care what the traffic light says. Or I can just drive across because I know it's not going to hit me." And that's going to cause, calamity. Didn't say nothing of the fact that unexpected events are going to happen. And I like to tell people that we know two things about unexpected events. First is that they always happen. And second, when they do happen, they're unexpected. And when something goes wrong in an automobile, how much time do you have to respond? If you're flying an airplane and something goes wrong, this happens, by the way, it happens a reasonable number of times, so all these incidents are studied. The pilots, what's going on, they say. And they're very well trained, okay? Even so, it can take them several minutes to figure out what's going on and to save the airplane. Because when an airplane is flying high up in the sky, 30,000, 40,000 feet, 10,000 meters, there's a lot of time. It takes 5 or even more minutes before the airplane is going to be really in great danger. In the automobile, if you're traveling at 60 miles an hour or 100 kilometers an hour, in 1 second you've gone 90 feet or 30 meters. That's a big distance. You have to respond in less than a second. And if you haven't been paying attention, if the automation's been working quite well and taking care of everything for the last 20 minutes, you're not paying attention. You can't. And so there's where the danger is, great danger. And we've already seen a number of accidents that appear to be caused by just this. This is called vigilance. It's a field that's been studied in psychology for 50 years. We know a lot about it. And the automobile manufacturers don't seem to be aware of the fact that, hey, there are real problems here. So the hardest problem we're going to have in this kind of automation is getting the engineering crew to understand the complexity of human behavior. I mean, I've been studying what happens. We're working with several automobile companies, and we look at people standing in the sidewalk, and their back is to the street. And so if you're driving by, you assume that, well, they're not going to cross the street, I can keep going. And then suddenly, without any warning, they jump in the air, and they turn around, and they run across the street. If you can find them and ask them, they'll say, I just realized I was late for an appointment. I was talking to my friends, and oh my goodness, I'm late. So boom, off they go. What does the driver do? How does the driver account for that? How does the driver predict that this might happen? These are the difficult problems. The other problem is communication. You see a driverless car coming, can you wave it at horn? Go on, go on. Or can you indicate I want to cross? Or could it wave you on? And if it waved you on, how would you know it meant you and not the 3 people next to you and it didn't actually see you? Or how do you know what it's going to do? How does a driverless car tell you? What we do today is we look at eye gaze. We try to find the driver and see where the driver is looking. But there is no driver. There are all sorts of interesting new issues that are going to show up. There's a trend that I find dangerous, that as companies realize they need to bring more designers into the field, they often bring the wrong kind of designers. Design is a very complex topic, and the traditional designers, and by that I mean those who go to design school, they really are craftspeople. They don't usually understand science or technology. They're really great at making beautiful looking, attractive items. Now, if we ask them to do high technology items, they make them beautiful. But can we use them? So let me use as an example a company I like, I love. In fact, I'm standing in front of their products right now, Apple Computer. So Apple used to make products that anybody could pick up and use without ever reading the manual. It was always obvious what was going to happen because you could always see. It's a process I call discoverability. I could discover what alternatives I had at any time. And because of feedback, I could always see what had happened. And because there was a lovely command called undo, if it wasn't what I wanted, I could change it. And I soon learned to use undo on purpose. I would deliberately make a change to see if I liked it. And if I didn't like it, I knew I could always undo it. And I had a good conceptual model of what was happening. However, what happened at Apple was that the designers who were trained in traditional design schools, which is focused primarily on art and appearance, took over. And so when we did the iPhone and gesture phones in general, why, they were beautiful devices, they were nice to hold, they were good to feel, and the screens were very attractive. But there were no signifiers, no clues as to what operations you could do. It was not discoverable. Should I tap with one finger or two fingers or three fingers? Should I swipe left or right or up or down or with one finger, two fingers? One tap, double tap, long tap? How do you know? Most of the time, the obscure things you learn because someone told you and you said, oh, I didn't know that. Oh, that's nice. Can you remember it? Not necessarily. Apple with its mouse has this really nice thing on the control panel, a little illustrated example of what each of the different taps and things do, and it's a good way to learn. Except, how come I have to go back to that over and over and over again to remind myself what all those obscure gestures are? Because the gestures that I use on my iPad are not the same as I use on my smart mouse, which are not the same I would use on a trackpad. Same company. It's crazy. And so you have to be aware of the fact that when you talk about design, there are some designers who are so focused upon making it fun and beautiful that they completely ignore the fact that nobody understands it. Graphic designers who want to make sure that, oh, that ugly font, it gets in the way, so we're going to make it light gray on a dark gray background, and we're going to make it really small so it doesn't, destroy the visual appearance. Who could read it? It's crazy, and it's getting crazier, so beware of that. Your job is, yes, make it aesthetically delightful and pleasing and fun to use. Also make it understandable, make the actions discoverable, make what happened visible through feedback, and allow undo. Remember the times you say, oh, I have this great picture I want to show you, and so I swipe back and forth. Here it is, and I hand you the tablet, and the other person, you, touches the tablet with their hands accidentally, and so the picture disappears, and you can't get it back. You have to start all over again. That's crazy, just crazy. So don't be crazy, be wonderful.
Well, thank you, Don. This has been a wonderful way to bring a close to this first course on user interface design in our sequence. And I want to thank you for joining us and remind everyone this has been an interview with Don Norman on current thoughts and trends in user interface design. And we will see you as we go forward in the rest of these courses together.
Thank you. Have fun, folks.
Hello and welcome back. As we're starting the second course in the sequence, I'd like to provide a fictional didactic example of the design process from user research to specific ideas. Now, I'm going to go through this Russian fable, and if some of you grew up in Eastern Europe, this may sound familiar. Maybe your grandma told you this fable as you were growing up. For some of you, this will be new. So here we go. Once upon a time, there lived three brothers. Sergei was the oldest brother, and he was blessed with the best programming skills in the land. His code always compiled, and he never had any logical errors in his code. Vladimir was the middle brother, and he was blessed with a great work ethic. He always put in the time to test everything until everything worked well and all the usability bugs were fixed. And finally, Ivan, the youngest brother, well, nobody really thought he was blessed with much of anything, and most of the village called him Ivan the Fool. This is pretty typical of Russian folktales. So one morning, the three brothers were having brunch with the princess, and she mentioned that she was worried about her kids. So she wanted them to have some independence, but Russian fables are actually a pretty dangerous place to live. For example, witches are always trying to turn children into goats, or gaggles of geese are trying to carry them away to faraway lands. And she just wished that she could know where her kids were and that they were safe. So Sergei immediately thinks, what an opportunity! I'm going to build a tracking app that will show locations of family members. And I know just how I'm going to do it. And Vladimir thinks, what an opportunity! I'm going to build a tracking app. I'm not really sure about what it's going to look like yet, but I'll do some work and I'll figure out how to get the design right. And Ivan thinks, why are internet cats so funny? No, that's not what he thinks. He thinks there's maybe an opportunity here, but I don't know what the right design here would be. What is the problem that I'm trying to solve? what are the really important goals in supporting location sharing between parents and children? So he really is starting with, I don't know. So Sergey goes off and he sits in the coffee shop for 20 hours and he makes a location sharing app. He puts it on the Android marketplace and he waits for the downloads. But even though his app is technically perfect, there's no bugs in it. There's lots of other tracking apps out there. Not having any bugs in his app is not enough to make it succeed. In the meantime, Vladimir starts doing the hard work of figuring out what his tracking app for parents will be like. So he sends out a survey to a bunch of parents about potential features, and he finds out that they don't really want to stare at an app of their kids' locations all day. What they really want is an alarm that will go off if the kids are outside of their usual areas. So he makes a paper prototype of his app to make sure that all the features that are important are there and easy to find. He tests this and he iterates based on the parents' feedback, and then finally he implements it in code. He's not a perfect programmer, and there are some bugs and design bugs as well in his code, but he's able to catch those through user testing. He deploys his app in the marketplace, and he finds that he gets a lot of downloads because he did a good job targeting the app to the needs of parents. And by the way, this is the classic user design process. If you leave this course acting like Vladimir, you will be already ahead of the people who just know how to program well. So don't discount Vladimir. But let's see what Ivan did. So remember, he basically doesn't know what he wants to build. All he knows is that he wants to find out more about what motivates location sharing in families and see if there's any opportunities there. So he sets off on a long journey, traveling far and wide throughout the land. He talks to parents, he talks to children of different ages, he talks to teachers, all about location sharing. And he finds that there's actually 4 different types of motivation for location sharing. All of them are different, and all of them may require different solutions. First of all, the most similar to what the princess was talking about, many parents wanted to be able to give their young kids some independence, but still be able to set limits about where they can go and get alerts if something unusual is happening. But Ivan didn't just talk to the parents, he also talked to the kids and he observed them. And he found out that for kids younger than 10, they're really not that good at carrying a phone around. And so they're always forgetting it or losing it somewhere, and maybe a phone is not the right solution for tracking them. Second, Ivan also discovered that for some of the families, location sharing was really just about having a general sense of what everybody was up to, so that you can plan things like dinner time or a spontaneous outing to a movie. For these families, the solution needed to be glanceable, rather than something that would take multiple clicks to get to, or you have to whip out your phone, open an app, find some feature of the app, and multiple minutes to interpret. Third, some parents really did not want to be constantly checking their kids' location. In fact, they may have even thought that it was a violation of their children's privacy. Instead, what they really wanted was an emergency alarm for those really serious situations that would share the location of the child not just with the parent, but also with the police and other emergency services. And of course, the key is that this had to be really easy to trigger in an emergency, but also really hard to trigger by accident. Of course, you don't want to be calling the police or the ambulance every 5 minutes. And lastly, parents of teenagers wanted location tracking so that they can enforce the punishment of being grounded. But Ivan also talked to teenagers, and he found out that, well, A, they'd find a way to get around anything and cheat it if they really needed to. But B, they were really frustrated that it seemed like when you got in trouble, it seemed like you could only get in more trouble. There was no way to show that you were doing the right thing. How are teenagers supposed to develop responsibility and regain trust if they have no agency? That's what the teens he spoke to said. So Ivan went and spent a ton of time coming up with ideas for solutions. Many ideas were, in fact, pretty foolish, but some ended up sounding promising. He sketched and he made paper prototypes and low-fidelity prototypes and got more and more user feedback. This was his way of making sure that he got the right design, that he was solving the right problem for the needs that each family had. So finally, Ivan came up with ideas for each of the 4 motivations of family location sharing. First, to track young kids, he got away from the idea of having them carry their cell phone and instead switched to a bracelet. For families who wanted a glanceable sense of each other's whereabouts, he made a clock inspired by Harry Potter books that described each person's context. And actually, by the way, a side note, this is a real project. This was a project for Microsoft Research Cambridge. I'll link to it at the end of the slides. For the emergency alerts, he created special shoe inserts. If you click to hit your heels a certain way, easy to do on purpose but hard to do by accident, they transmit your location to emergency services. And finally, he made an app for families with teenagers. But instead of tracking the teen, the app asks the teen to voluntarily check in and share what they're doing. So it kind of flips the agency of the app, letting the teens feel like they had the power to rebuild that trust with their parent after getting in trouble, instead of feeling like they were being tracked and had no rights to privacy. And look, in real life, we all have constraints. Maybe you work for an app development company and you have to build an app. You can't go around building a shoe. But following this process may allow you to zig when other people are zagging. Ivan built an app too, but it was a very different app than one of his brothers built. So maybe you can't build a clock as part of your project, but what if the clock face was actually represented as an active lock screen for a phone? The key insight there is not that it has to be a clock, but that it's easily glanceable. It's something that you can look at and interpret in a few seconds. Maybe you can't build magical shoes, but what if you could detect when a phone is being thrown with a particular violence and call emergency services if that happens, because it might be indicative of a car accident or the kid being kidnapped? So this kind of thinking, where you look at lots of different solutions, lots of different ideas, this kind of thinking is never wasted time. So the good news is that Ivan was able to be really successful with all of his ideas. He sold some as a service, others as a license, some as an app, and he had a very successful Kickstarter for making his location-sharing family clock. With these successes, he was able to start and get funded a company that focuses on technology for families. Of course, Ivan is also a good guy, so he hired his two brothers to work for his company. Because, of course, who wouldn't want a perfect programmer and a really hardworking UX guy working for them? But now nobody called him Ivan the Fool anymore, and they all lived happily ever after. So, of course, this story has a moral, and the moral is that I don't know is actually a very good place to start in design. And the story was actually about kind of two types of thinking, convergent and divergent. Convergent thinking is about coming up to a solution to a well-defined problem and iterating on this solution to make it better. That's what Vladimir did in building his family tracking app, and it was pretty good. On the other hand, divergent thinking is about exploring the problem space and coming up with lots of diverse choices and solutions. That's what Ivan did, and he came up with many different good ideas. And at this point, I usually stop my class and I have my class discuss what they think is more important to innovation, convergent or divergent thinking. And I let them kind of talk about it for a while before I reveal that it's actually a trick question. I think that both of these are actually equally important to innovation. In fact, in course 1, Professor Constant and I introduced 3 different contexts for design, depending on whether you're trying to identify a good problem, iterate on a more specific solution, or improve on an existing solution. Each of these contexts depends on divergent and convergent thinking to different extents. But the reason why I'm talking about divergent thinking, and the reason I think it's important, is because it's not the type of thinking that computer scientists generally do. For many of my computer science students, my class is the first time they're exposed to practicing divergent thinking, and in general thinking more like Ivan did in this fable. So clearly the folktale is fictitious, but I do like telling it as part of the introduction to this course. Folktales can get away with being didactic in ways that lectures can't. And the main takeaway is that good interface design requires a lot more than just programming skills. Good designers like Ivan create these designs by conducting significant user research to understand the problem context. They use divergent thinking to come up with many diverse ideas and designs and explore the solution space. In this course, we'll teach you the specific techniques and methods that you may need to do this user research. We'll also share specific techniques for both divergent and convergent thinking if you're coming up with solutions for the problems that users face. So before I go, I just want to point you to a source of real Russian folktales instead of ones that I just made up. Also the whereabouts clock that I used as an example is in fact a real project, and if you have access to the ACM digital library, you can read the paper and read a little bit more about it. I think it's a really good example. So thank you for listening, and I hope to see you in the next video. Hello and welcome back. Today I'll be introducing you to Course 2. This course is really focused on how to do user research and then how to take that user research and turn it into design ideas. There's roughly 3 parts to this course. The first focuses on conducting formative research with users. The second focuses on analyzing and communicating the results of that formative research. And lastly, the third part is about generating and selecting ideas based on this formative research. So I'll just give a very brief overview of each of these parts. Research with users. So here is a much younger me doing some user research with kids, trying to understand how they can use toys for learning. And basically, research with users is going to focus on three different things. Asking people questions, whether that's as part of an interview, a contextual inquiry, or something like a questionnaire. Observing people's behaviors. And again, this could be an unstructured observation in the wild, it could be a more structured observation in the lab, or something like contextual inquiry, where you both observe and ask questions. And we're also going to talk a little bit about analyzing traces of people's behavior when you don't have direct access to their behaviors. Some examples may be something like logs of their activity on a website. As part of this part of the course, we'll also have an assignment where we'll have you conduct observations and we'll provide you with some feedback on how you did. The second part of the course focuses on analyzing and communicating your results. So this is actually an image from a real study. So this is the analysis of quotes from interviews where we cluster them into categories in order to understand what the meaning of those interviews was. In fact, we'll focus on three parts. Qualitative analysis, similar to what I showed in the last slide. Quantitative analysis, when you have enough information that you can do things like descriptive statistics and hypothesis testing. And communication tools. How do you actually explain your findings to others, especially when working with teams where some people may not have been part of that direct formative research work. Some of the communication tools we'll cover would be personas, use cases, tasks, scenarios, and implications for design. And the last part of this course will focus on generating and selecting ideas. Again, this is a photo from a real study where we were looking at different ways of designing interesting communication systems for families. And so we had lots of different ideas sketched out to consider. So some of the things that will be involved in that part of the course are getting to a quantity of ideas, because that's how you get a good idea, is you get a lot of ideas. Selecting the best quality ideas from those and communicating those ideas to stakeholders. And again, as part of this course, we'll have an assignment for you. We'll ask you to go from some user research that we provide you to some design ideas and provide you with feedback on your process. So by the end of this course, you should be able to conduct a study to understand the technology opportunities in a particular context. You should be able to communicate your findings, the results of this study, to others in a meaningful and clear way. And lastly, you should be able to identify specific design directions that actually capitalize on these technology opportunities that you find through your formative work. I look forward to seeing you in this course.
Hey folks, welcome to this first series of videos in this second course in the specialization. This series of videos is all about methods for doing user research. So in other words, this series of videos is going to cover different ways of knowing about the most important people for your user interface project. Of course, this most important set of people is your users. So looking ahead here, each video is going to cover a different set of methods for understanding your user base. You're going to get a lot of disciplinary diversity. So we're going to be doing very qualitative stuff like interviews, and we're going to be, at a high level at least, covering very quantitative things like log analysis. If you're a technical person, expect to gain a lot of respect for qualitative methods like focus groups and interviews. You'll be getting a series of videos that should demonstrate to you pretty clearly how valuable that squishy type of information can be for establishing a good and successful user interface. And conversely, if you're a people person, if you really like getting that qualitative or squishy data, expect to gain a decent amount of respect for technical methods like log analysis and what they can tell you about how to design your interface most effectively. So this is an interdisciplinary set of videos, and it's one that really celebrates its interdisciplinarity. So before we get going on each of these methods-focused videos, I wanted to cover a couple of high-level principles, two in particular. The first is this one, and this is one to keep in your head as you're going through each of these methods, and that is that you are not the user. The reason you do user research in the first place is that you have to take a step back and, with a great deal of modesty, understand that your instincts and your experience, generally speaking, are not representative of your user base. You're probably someone who knows your way around a computer, knows your way around technology. You might know how to program. You are an insider. The vast majority of people using your product are most likely outsiders. So you really have to take a step back, recognize that your own knowledge, your own experience has to be subordinate to that of the users as you learn about them through the methods that you're going to be covering in these videos. So this principle is so important that Jakob Nielsen, one of the founders of the modern of user interface design as we know it today, Jakob Nielsen writes that one of usability's most hard-earned lessons is that you are not the user. I would say that he would also say that it's one of usability's most valuable lessons as well. So a second guiding principle that's kind of a corollary to the first one is that you really need to keep an open mind here, right? So you might have some preconceptions about how your users behave or how your users want things. You have to take a step back and really listen to what your users say or listen to what the data tells you about your users. All right, with that, I think you're going to enjoy this next set of videos taught by some experts in the corresponding methodologies, Professor Yarosh and Professor Zhu. And with that, I will see you soon.
Hello and welcome back. Today we'll be talking about one of my favorite methods, interviews. And we'll cover a little bit about both doing interviews with an individual and doing interviews with a group of people, which is also known as focus groups. So why should you try to interview users? It turns out there are many aspects of a person's experience that are difficult to infer directly from their actions. Just observing somebody doing something, sometimes you can kind of tell if they're liking it, what their motivations are, but most of the time you cannot. It also allows you to answer the why questions. Why did the user do something in a particular way? And it allows for reflections on rare activities and events. So for example, I'm not in a house fire every day, but perhaps I was in one at some point. You can interview me about that event and you don't have to follow me around my entire life just in the hope that at some point I'll be in a house fire and you'll be able to observe my activities and use of technology in that context. So let's go through a quick example of an interview study. I conducted interviews with families where parents and children live apart. And there were actually two types of families that I was interested in. I was interested in divorced families where one parent typically lives in a different household from the children. I interviewed families with a variety of custody arrangements in those families. And I was also interested in work-separated families. So these are families where there may be a traveling parent. And there's lots of different reasons a parent may travel. It could be deployment, so military deployment is a common one in the United States. It could be something like immigration. So one parent may come to a country that they're planning to immigrate to and then bring their family over later. In fact, that was the case with my family. My dad came to America and then a year later was able to bring my mom and me over. And I also interviewed the children from both of these families, focused mostly on the ages between 7 and 13. I didn't only ask interview questions. I also provided a few kind of structured questions, we call those questionnaires, and some drawing exercises for the kids because it's sometimes difficult for children to articulate kind of abstract concepts, and so asking them to draw can be really powerful. So the two drawings here actually in response of if you could have any magical thing to help you stay connected to your parent, what would you have? And the drawing on top is a robot that carries secret messages, and the drawing on the bottom is a magic door that lets dad in at bedtime to read a story. And this doesn't mean that I'm going to, as a designer or as a computer scientist, go off and build secret message-carrying robots or magic doors to let dad in, but it does actually point to these common issues that children have when they're separated from their parents. So the top one, the secret message robot, is actually from a divorced family, and one of the things that it underlines is that kids are kind of very aware of the tension between their parents over their time and affection, and frequently try to keep contact with one parent as private from the other parent as possible. And that's why this kid wanted the robot to carry secret messages. And the one on the bottom actually highlights the importance of routine. So there's certain activities that the children are used to doing with a particular parent, and when that routine is disrupted, it can be really problematic for the child. So just to give a quick overview of what we found in the study, so one of the things we were really focused on were the goals that each of the parties brought to the picture. And so the ones that are in light gray were actually common for work-separated and divorced families, and the one in kind of a darker or blue we only saw in divorced families. So for kids, their main goals are to have fun, no surprises there. They also want attention and support when they want it, so they're very in-the-moment creatures. If they have to wait until Sunday at 7 p.m. Skype to tell their mom about their skin need, that's not going to work. They're going to forget about it by then. And the other thing that we saw in divorced families, but not in military or other work-separated families, was that kids are really sensitive to this tension over between their parents, and particularly the competition over time and affection, and really tried to minimize those tensions. There were also some common goals that kids and parents had. So for example, collaborating on daily activities. So both mentioned that that's when they have the good conversations, when they're playing outside or playing a board game, or when they're doing daily routines like bedtime or getting ready for bed or breakfast. Homework help was a big time that parents actually felt that they were very instrumental in the child's life and found kind of a lot of things to talk about how school went, whereas just asking about how was school generally generated a very bland answer, just like good. And also creative pursuits, so whether that was drawing together or building something out of Legos, those kinds of things. Now in terms of the parents' goals, all the parents we spoke to really kind of wanted to have the information and the power to act in the child's best interest. They wanted to maintain a strong emotional connection with the child, but that could actually be very difficult when you don't live or you spend a lot of time away from the child. Phone and video chat were not quite there yet, so they were not really engaging as ways of interacting with the child over distance. And lastly, the parents frequently wanted to minimize tension with the other parent in the family. And this was actually something we found not only in divorced families, where it kind of makes sense, but also in work-separated families. Frequently, the parent that's at home kind of has to take a greater share of childcare responsibilities. They're the ones kind of making sure the routine still happens for the child. And the parent that's abroad may want to be really careful about how they disrupt those routines or how much extra obligation they're introducing for the parent who's still at home. So we actually saw this theme across family types. So this is just an example of an interview study and the results from it. So now let's actually go into how to interview participants. There's generally about 4 steps to it. So you want to prepare your questions, you want to schedule and arrange a meeting, conduct the interview, and then analyze. So in terms of preparing your questions, it's very important to actually plan ahead rather than to think, okay, well, on the spot, I'll figure out what I wanted to ask them, and it'll just be kind of like a conversation. So typically, I put together something that I call a protocol, a list of questions that I want to ask and follow-up questions. We'll talk a little bit more about preparing a protocol in a later video. But I just want to make sure that you understand a few things about this, 4 things. So one is you really want to have open-ended wording on interview questions. The main strengths of interview questions is they let the person tell their story. And so you don't want to ask interview questions that can be answered with a single word that ask the participant to select from a list of choices or that are yes or no questions. And this is actually the most common mistake that I see for people who are first developing their set of interview questions. So as you read through it, if there's any question that starts with something like, do you, or in any other way can be answered with a yes or no, you want to make sure to rewrite this. So for example, instead of asking, do you connect with your child over the phone, ask, how do you connect with your child? Or tell me a story about the last time you connected with your child while you were apart. You also want to make sure to plan the time. So it can be very easy to miscalculate how much time a particular section is going to take, or in both directions, actually. Sometimes I think a certain set of questions is going to take a very long time. It doesn't actually end up getting that much response from the participants and end up ending short. I also note follow-up questions for myself. So generally, the interview is kind of like a conversation. It is led by the participant, but sometimes I do want to get at specific pieces of information, and I may note those for myself in order to get back to them. And the last thing, and the reason I make it big is because I think this is really important, is that anytime you do an interview study, you want to pilot first. You want to actually sit down with somebody who is either somebody in the family, somebody you know, somebody in your lab, somebody in your work group, and go through that interview with them, asking them to pretend like they're the participant. It's really powerful. It helps you understand which of your questions are confusing. It helps you get a better metric for how much time each section takes and whether you're going to be done in the time that you promised the participant. It's a really valuable experience. And I would also say that if possible, if the people you're interviewing are not let's say not in your age range or have some special characteristics, if possible, see if you can find somebody from the appropriate demographic to do the piloting with. So in my case, if I wanted to pilot with children, I usually recruited my little brother, who was at the time much younger than me, so I could sit him down and have him pretend to be every kid and actually go through the questions with him. But hopefully you can also find kind of friendly participants who can stand in for the user as you pilot. Now, the second step is scheduling and arranging. And I actually find that in most interview studies, unless you have somebody to help out with this stage, the scheduling and the arranging and recruiting take about a fourth of the time in the whole study. So it's a fairly significant undertaking. So just make sure that you plan for that in your schedule. You should definitely follow up to confirm the interviews. It takes a lot of time to recruit people, it takes a lot of time to set up, and you don't want that to be lost just because somebody forgot the day or because you had written down the wrong location or something along those lines. I also think it's very important to consider the setting and how you present yourself to the user. And we'll talk a little bit about that on the next slide as well. But the main point that I'm highlighting here is that you should also make sure to be safe, especially if you're going and you're doing these interviews alone and you're going to meet the participants somewhere. See if you can instead meet them at a public location like a coffee shop. That's a very reasonable place to do interviews, or a public library, rather than, let's say, at the participant's home. Or if you are meeting them at a participant's home, perhaps having another person come with you, or letting people know where you are and then planning to check in with them as soon as you leave the interview. Just make sure to be safe, because it can be a dangerous place out there. So let's talk a little bit more about this idea of setting and presentation. You have to really think about how to present yourself and where to do the interviews in such a way that will make your interviewee most comfortable and most likely to give you honest answers. So just to give you an example with children, if you sit kids down in a room that's gray and has gray chairs and looks like it's meant for adults, and if you wear a lab coat while asking them questions, you're going to get a lot of demand characteristics. So that means the kid is really going to be thinking about, wow, this person has a lot of power over me. What do they want to hear from me? Let me make sure that I tell them what they want to hear from me. And that's not the kinds of answers that you want. So for example, when I interview kids, I try to find a kid-friendly place. So something that has a lot of color, that has kid-sized chairs, for example. And I try to dress very casual, so I might wear my University of Minnesota t-shirt, for example. Now, on the other hand, if I was, let's say, interviewing high-powered CEOs about how they use technology to manage their day, I may want to wear something different. I may want to wear, a fancy pantsuit, or at least my awesome blazer while I meet them. So it's something to think about ahead of time, to think about how is the participant going to perceive you. Are they going to be comfortable giving you honest answers? Are you going to be taken seriously, and all that kind of stuff. So the third step is actually conducting the interviews. So I usually prefer to audio record the interview, which frees me up to be thinking about follow-up questions, be really listening to what the participant's saying instead of madly writing. Of course, this is only with participant permission, and most people I find are okay with you audio recording if you say that, this is just going to be used to generate transcriptions. It's not going to end up on NPR or YouTube later. I do still take some loose notes, but I really mostly focus on listening and thinking about what I'm going to ask as a follow-up when the participant is talking. One thing that you kind of learn as you do a few of these is to really follow up on hunches or unusual responses. So sometimes the participant will, answer a question, but you kind of sense sarcasm in what they said. So follow up on that. So, you said you really enjoy the tools that you have currently available for communicating with your child, but I also sense some sarcasm in that. Can you tell me more? So that can be a really good way of actually kind of getting to some underlying issues. Sometimes laughter is an unusual response. So you'll ask a question and the participant will laugh first and then answer it. And that could be something to follow up on as well. So I noticed you laughed here. Tell me a little bit more about that. Why did you do that? The main lesson to learn in doing interviews, and this is something that I myself struggle with, and definitely when I listen to myself after the interview, I still find moments where I'm like, oh, I just interrupted the participant while they were saying something interesting. But the main lesson is actually being comfortable with silence. So even 3 seconds of silence in an interview can feel like an interminable length of time. So for example, here's 3 seconds of silence. That was really uncomfortable. Like I was ready to jump in with talking again. Now, in an interview, when a participant has finished answering a question, or when you think they may have finished answering a question, or when you've stated a question but they haven't started talking, it may be really tempting to jump in with a clarification of the question, or with the next question, or some other follow-up. But you really need to give that silence time, because the participant is actually thinking, and to them that silence may not be as interminable. And maybe they're thinking, oh, there's one thing I could say, but I'm not going to say it because it doesn't seem that interesting. That silence may actually kind of get them to say whatever's on their mind. So I would say count to 10. It's very uncomfortable, but it does actually lead to better interviews. And overall, this is kind of a more a learned skill or a craft or an art than it is a science. Learning how to interview well is really about practicing doing it. So one of the things that I like to do, and this is again also very uncomfortable, is to take that audio recording afterwards, and either as I'm transcribing it or sort of if somebody else is transcribing, just listening to it on myself on the train, just listening through the whole interview recording and kind of critiquing myself and my skills as an interviewer. Did I jump in somewhere and interrupt the participant? That's something I frequently do. Did I give enough time? Did I seize an opportunity for a follow-up based on something the participant said that might not have been obvious? I take those notes and I hope to learn from them and improve as I do the next interview studies. So analysis is the last step, and it's complicated. We'll actually cover it in its own lecture. We have an entire lecture on qualitative analysis. And so for now, I'll just let you know that after you've done the interviews, you need to analyze them. So the other thing I wanted to cover a little bit was this idea of digital tools for interviews. So I really do believe that interviews are best done in person. So if you're sitting across a table from somebody, you can read their body responses. You can kind of see where they're looking. You can see if they're distracted or with you. You can see if there's anything else going on in their context that might be changing how they're responding. But it's not always possible. Sometimes the participants you want are scattered throughout the country or the world, and those interviews need to be done some other way. So I have in the past done interviews by phone or video chat, and then audio recorded them and kind of followed the same process as I generally would. I do prefer video chat to the telephone because it does give me at least a little bit of a window into the context of the participant and at least a little bit of insight into their expressions and kind of where their attention is. But I find that the richest interviews I really do get in person, even though it does have that inconvenience of having to travel to the participant or having them travel to the lab. So the one thing I would say is that don't interview over email or chat or some other text-based medium. Or if you do, maybe don't call it an interview, call it a questionnaire or a survey. Basically, anytime the person has to type, you're going to get severely abbreviated responses, and you're going to get responses that are kind of edited by the participant because when we speak freely. When we write, we imagine that being seen by others outside of the intended audience. So in general, I would definitely avoid that. And I think for me, if somebody says they interviewed over email, that definitely raises a red flag in terms of how that might have biased their data and biased the participant responses. So I promised that we'd also talk about group interviews, which are also known as focus groups. So let's cover that a little bit as well. So sometimes there may be an advantage to interviewing not just one person at a time, but a whole group of people. So typically it would be something like 3 to 10 people, depending on the context. And you kind of pose a question to the whole group and have them answer it at the same time or have them discuss it. Typically, these groups are very carefully selected based on the role and demographic of the participants, depending on what your research questions are. And the one thing I'd like you to take away about this kind of group selection is thinking about whether for your questions, for your context, it is more appropriate to have a heterogeneous group or a homogeneous group. And what I mean by that is, do you want to have a group where everybody has the same role? So for example, let's say that if I was doing my study with kids and parents as a group interview, I didn't do that, but if I did, I may think about inviting a group of 5 dads to talk, and maybe a group of 5 moms to talk, and maybe a group of 5 kids to talk. And so those are groups that are homogeneous. Everybody there has the same role. Now, on the other hand, I may take a different approach. I may have a heterogeneous group where I have the same family where everybody has multiple roles all be in the same group interview. So a single family with, let's say, mom, dad, and the kids being in the same room as I'm interviewing them and kind of providing me feedback on what's going on. So there are advantages of each. I think in general it's just important to think kind of what questions are you asking? If you're asking a lot of questions that are really directed at the dads, but you have a heterogeneous group, then half of that group or more than half of that group is not going to be able to contribute to that question or to that answer. And so that may not be what you're going for. So how do you decide whether to interview people as individuals or to interview them in a group? So I've kind of made a little bit of a comparison between the two. So definitely it's more time and effort that's spent with each participant when you're interviewing individuals. And that's both a pro and a con. So if you don't have a lot of time, you are spending that hour and a half, or maybe even 2 hours if you count kind of getting there and getting back. with each participant. But that also means that you're getting kind of richer responses because you do have that time to have that silence after responses or to really give the participant time to think before they jump in with their answer. With individuals, it is easier to coordinate the logistics because typically, it's just planning to have two people meet up, the interviewer and the interviewee. And, it's finding a place that works for both of you, finding a time that works for both of you. It's not that hard. And I think it's also a lot more privacy for the participants. So the responses they're giving are not being heard by everybody else in the room, for example. So they might be more honest. On the other hand, in groups, it is frequently easier to solicit more feedback. Because if you ask a question and maybe in the group of 5, one participant doesn't actually have an answer to the question, the other 4 will jump in and start talking, and perhaps through that discussion, that 5th participant will figure out something interesting to say about this point as well. I really find that these discussions between the participants that occur when they're answering questions can really highlight things like their assumptions or what's really going on or kind of underlying issues. And these group discussions can really be fascinating sources of data. Now, one negative, however, is that you may need to deal with confounding personalities. So sometimes you may have somebody who's really quiet in the group or somebody who's incredibly outgoing, has a lot of opinions, and that might be a problem because the quiet person might not feel like they can offer any of their opinions, whereas your whole interview is kind of dominated by one dominant personality. And lastly, there's this issue of kind of what we call presentation of self. So for example, if you're interviewing parents about parenting, parents frequently feel judged for how they parent. So they may want to present themselves in the best light to the other parents in the group interview. So they may not give you entirely honest answers or may kind of really try to kind of gloss over their actual parenting practices and present it in a particular light. And typically when you're interviewing, that's not what you're going for. You really want honest responses for participants. So we're wrapping up on this video. I know this is a long one, so bear with me while we just finished talking about the strengths and weaknesses of the interview method. So the strength of it is that it can work with no knowledge or hypothesis before starting. This is not a hypothesis-driven method. This is not a method where you kind of know what's going to happen before you conduct the interview, but rather one where you're really trying to gather more information from the participants. It does provide you with that rich and nuanced data about participants' lives. You're really getting them to tell their stories for you, and that can be a really powerful experience. And because you're really getting them to articulate their experience, it reveals all those internal invisible aspects of their experience. So whether it's motivation, why did they do something? Affect, how did that really feel? Identity, like is this who you are? How does this match with who you are? Their priorities, their preferences, their mental models. And it also allows them to reflect on rare past experiences rather than something that happens to them every day that you can just observe. Now, of course, there are also weaknesses to this method. One big weakness is that recall may be biased. So you're asking participants to think about something that's happened in the past or to reflect on something that's happened in the past. They may not be remembering it accurately or correctly. Their reflection and reporting may also be biased. So whether that's about presenting themselves in the best light to you or really kind of considering how, if, let's say, their boss saw the answers they give to the interview, how that would reflect on them. And it's not really what they actually do, it's kind of how they reflect on that. So one example of this is, if you ask me, what does a professor do during the day? What do you do during your day? In an interview, I might give a set of answers, and I'm trying to be honest, but I'll say, I spend, 20% of my time doing teaching, I spend this amount of time doing research, I spend some time on service. Whereas in reality, if you actually followed me throughout my day, you would see that the one pervasive activity that I spend the most time on is actually email, which is not one of the things that I listed because maybe I didn't think about it at all. So sometimes when you're asking people to reflect or report, they will give you a different answer from what actually happened in real life. And lastly, interviews are a qualitative method. In order to get that nuanced data, that rich data, you really do have to spend a lot of time and effort with each user. So you can usually get to only a few small numbers of users. You're really not looking for a representative sample here. You're really not trying to say something that's quantitatively significant about the entire population. You're really just trying to get the stories that your participants can provide you about their daily, everyday experience. So if you'd like more information, this is my favorite book about being an interviewer. Interviewing is Qualitative Research. I think it's really good and it's really simply written. So if you do end up using this method, I definitely recommend you take a look at this book. It's quite good. Well, thank you for bearing with me for this long video, and I'll see you next time. Hello and welcome back. Today we'll be talking about observations, the art and science of observing your users. Why would you want to observe your users? There's really three reasons, probably more, but the three major ones are that some actions are really difficult to articulate. So let's say that I ask you, how do you ride a bike? You just get on and ride, right? And so it's only through observing you that I can actually tell kind of the minor ways that you balance or the minor ways that you kind of actually approach the activity. Or if I ask you, how do you answer your email? You may have kind of somewhat of an answer. Maybe you say like, well, I look at it once a day and I answer it all in one single pile. But by observing you, I may actually find that you do it somewhat differently, that you actually return to it throughout the day, or that certain emails when they come in, if they ping your phone, are more problematic than others. So sometimes these descriptions of behavior that we give, so we may say, I check my email once a day, actually conflict with the behavior that we take when we go through our daily lives. And this is not because the participant is lying necessarily, but just because we structure things in our head, the way we plan our day is so different from the way it might actually go. The other thing is that participants may not know which details of their activities are actually most relevant to you. So maybe the reason why I didn't say that I actually check my email throughout the day is because I wasn't sure if that particular aspect of my interaction was actually something you were asking for, actually was relevant to you. Maybe I didn't think that checking my email on my phone, for example, counted as checking my email. Or maybe I didn't think that if somebody approaches me in the hallway and says, oh, by the way, I emailed you that thing, do you mind taking a look at it? And I look at it, that still counts as checking email outside of my 1 hour of checking email per day. So, in fact, by observing somebody as they go about their day or as they go about a particular activity can yield insight that's different from just asking them about that activity. So let's talk about a quick example of a participant observation study. So as I've talked about in previous videos, I'm really interested in understanding the potential role of technology in helping people recover from addiction and alcoholism. And so as part of that process, I really wanted to understand how technology was currently used and also how people use social support in their recovery. So part of that process was attending 6 months of participatory observation. I went to 132 open meetings, 12-step meetings. And open meetings are actually open to anybody, not just people who are currently in recovery. And so I was able to come in and kind of observe and make friends with people and ask them questions about how they currently practice their recovery, but also really just kind of sit in the room and see what happens. I also attended 18 organizational service meetings. So all these meetings that happen every day, all around the world, they need to be organized somehow. So frequently it's kind of this volunteer system, grassroots system of service level meetings where common issues are considered for a particular area, region, or state, and decisions are made. I also documented artifacts and current technologies used. So when I say documented artifacts, I mean doing things like taking photographs of particular technology that may be used by participants, whether that's an app or something even like a whiteboard that you see on the photograph, on the heavily anonymized photograph on the bottom. So through that process, there are a few things I learned. So I learned how meetings and event logistics are organized at the group, area, and regional levels. And by actually watching how the sausage is made, so to speak, not just asking people, well, how is a new event organized, where I might get kind of a sanitized or whitewashed way of describing it. I looked at how disruptions and norm violations are handled at the group level. That was quite fascinating. So sometimes you might have somebody come in who's early in recovery, or perhaps in fact still high or still drunk. They will be speaking at a meeting and really being disruptive rather than actually contributing to the discussion. And what I saw was kind of the old-timers of the meeting, people who come regularly and have a lot of time clean, will exchange looks. One of them will nod. They'll take that person out of the room so they're not disrupting that meeting, but they'll talk to them for as long as they want to talk. And that was really powerful to see kind of that way of approaching norms and violations, which wasn't punitive, but rather tried to be constructive for all the people involved. And lastly, I got to observe how the organization as a whole creates and improves content. At the time that I was doing this observation, the Narcotics Anonymous program, the NA program, was in the process of approving a new book. And this was actually kind of approved and written at the grassroots level, so drafts were passed down from the world level to regions, areas, and even groups. People would read, would comment, and pass those comments back up to the world level. And so it was really powerful kind of to see that process as it was happening, rather than to just ask about that process in retrospect. So let's talk about how to observe participants. So 4 steps here, and there's a few of these videos have a very similar structure, so some of this may sound familiar. So step 1 is to prepare your note structure. Step 2 is to schedule and arrange access. Step 3 is actually conducting the observation, and then 4 is analysis. So the key to preparing your note structure is understanding what it is that you hope to capture in your notes. Are there any other types of evidence that you want to capture? So maybe you want to take a video of something. That would clearly be inappropriate at an NA meeting or an AA meeting, but photographing something like a whiteboard or other artifacts or getting screen caps of people's apps that they use for recovery was reasonable other forms of evidence that I could gather. What granularity is actually relevant to you? Do you want to note each time somebody speaks up at a meeting so that you know how many people actually participate? Or do you just want to sit back and look at larger themes that happen, so kind of have a more structured way of taking notes? And lastly, will you actually try to quantify these notes in any way? So for example, if I did note every time somebody at a meeting spoke, I could actually have an idea of how many people on average speak at a meeting from 132 meetings I attended. So these images actually show kind of the 3 extremes, or maybe not 3 extremes, but a spectrum of taking notes. So the first might just be a notebook and a pen, so completely unstructured. You're coming in, you don't know what you're going to find yet, but you're looking for kind of any interesting insight that might come from that process. And that's really how I did the AA and NA observations. I really just had a notebook that I was taking notes in after the meeting as field notes, because I didn't quite feel that it was appropriate for me to put the whole meeting under a microscope and to count how many times different people spoke. The one in the middle shows kind of a medium structure, so perhaps it might be something that's more digital, and you might be actually recording specific timestamps when something is happening, and then noting things like maybe particular trouble that a participant had with the system, or what they did at a particular moment in time. So it's kind of a lot more structured because you get timestamps, and you're doing it in the process, in the moment as you're observing. And then the last one here is also from a study that I ran observing how kids used a particular technology. And one of the things we were interested in that study is how often do the kids look up at the screen that's providing them content versus play with the physical toys that were kind of the things that activated the content on the screen. And the argument we were making is if they don't attend to the content, then they can't possibly learn. So if they're looking away or they're looking down, they're not actually attending to the content we're trying to teach them. And so what we had is a very structured sheet where for every 30-second segment, we kind of specified what was happening mostly in that segment. So we used a downwards arrow to say that the kid was looking down, an upwards arrow to say the kid was looking at a screen, and an O to say that the kid's attention was entirely somewhere else, so not even on our system at all. And so later on, we could actually quantify that. We could, for each participant, say, okay, how many downwards arrows did they have? How many upwards arrows did they have? That would actually allow us to, for example, compare systems. So the spectrum goes from very little structure for how you take notes to quite a lot of structure where every 30-second segment of your time is structured. And all of these are valid. It's just a matter of what is valuable to you in the study and what do you kind of anticipate seeing from the observation process. The second step is scheduling and arranging access. So we've talked about this before, and all the same issues as interviews apply. Consider the setting, consider the presentation, how you present yourself, consider how you'll be viewed and whether your presence will bias the participants' responses or how they act. Follow up to confirm and schedule, and of course be safe. So do the observation somewhere, either with somebody else or somewhere where you're in a public setting and you can be safe. The third step is actually conducting the observation. So I find that it's really important to provide clear instructions for the participant. If necessary, there are cases where you may be observing people in a public setting where they don't actually know they're being observed. So maybe if you're doing something like counting how people walk in and out of a supermarket, you're not going to ask consent from every person who's walking in and out, but maybe you're just doing some basic counts. But most of the time when you're observing participants, they know about it. They give you their permission to observe them. And sometimes you even provide them with specific tasks. Like you may ask, okay, I just want to see how you would debug a particular piece of code. Can I sit back and watch you while you do this? And they'll go ahead and do it for you. But I think those instructions are very important. Particularly also tell the participant if you want them to act as if you're not there, or if you want them to kind of be commenting on the activity as they're doing it. You're going to get very different results depending on the two. You want to go ahead and set up any necessary equipment. So perhaps your audio or video recording the session. If you have notes, you want to have all your note sheets printed so that you can take notes either in a structured way or in a digital way. Then as the study progresses, you take notes using your pre-prepared structure or lack of pre-prepared structure if you're just taking general notes. After the observation, this is really important, review your notes immediately afterwards. So I like to schedule at least half an hour in my schedule immediately after user observations, just to sit down, write field notes, so describe what happened, anything that may have popped up that I didn't anticipate or that I didn't note in my other notes, I would write down there, because all this stuff is like very easily forgotten. If you wait until you do kind of 3 observations in a row, you're not going to remember what happened in that second observation or some piece of insight that you might have had as you were observing. So that process of field noting is very important. Now, analysis is covered in a later lecture, and because here we did talk about observations that could be very kind of unstructured and qualitative, and observations that could be quantified that are kind of very specific. Both the 2 types of analysis will be covered in the qualitative analysis and the quantitative analysis lecture. And just to give you an example, so on the one on the left is analysis of kind of a more open interview type study where you're just observing and you're noting general things that might be of interest. And the one on the right is a very structured analysis where we actually looked at how specific children played and whether they were social with each other using one of our 4 prototypes that we developed. And so this actually generated very specific numbers, level of social play, that we were then able to compare across children and across conditions. So lots of different ways of analyzing observations. Now, the other thing I want to talk about is this idea of digital observations. So it used to be that you had to be in a particular place in order to observe people. But now there's lots of activity that happens online, and you can actually conduct an observation study remotely from participants. So the image here shows AA or NA, I'm not sure exactly, video meeting that is actually happening on an online web page. So this is, of course, very heavily anonymized here as we're showing you this image. But we were able to attend those and observe those, and we didn't actually have to leave our office in order to do that. So we could follow the same process of taking notes and seeing what's happening, but it was something that was actually happening in a digital environment. So you can also do something similar by having the participant screen share. So maybe you do want to observe how somebody goes about their day at work, but you can't be there to shadow them. If a lot of their work is digital and they agree, maybe they can just share their screen throughout their day. The other kind of context where I think this is really powerful is actually multiplayer video games. So going to something like World of Warcraft and observing how people behave can be as interesting and as powerful as going to a playground and observing how people behave there. So what are the strengths of the observation method? One of the strengths is that as interviews, it can work with no knowledge or prior hypotheses before starting, especially if you're taking kind of unstructured notes. Again, it also provides you this rich, nuanced data about the participants' actual process, not just what they say it is. It reveals the specific, concrete, and unedited actions. The participant doesn't really have time or the opportunity to necessarily kind of abstract or represent or focus about how they're being viewed or whitewash their activity. They just do it and you observe it. And so in a lot of ways, it can be kind of provide you a more honest perspective on the actual steps taken in the workplace or at a particular leisure activity. Now, of course, it has weaknesses as well. So usually you do need access to and the cooperation of the participants in a specific context. And that may be more difficult to get. I think sometimes people are more comfortable with being interviewed because they do have that ability to kind of edit a little bit what they're saying or how they're presenting themselves. It's a pretty vulnerable experience to let somebody just come in and observe you. It does also rely on the situation of interest being frequent enough to observe. So, for example, I was interested in the AA and NA meetings, how particular moments of disruption were handled. But in those 132 meetings, those moments of disruption probably only happened about 10 or maybe 12 times out of those entire set of meetings. So if I had just gone to 1 or 2 meetings, I would not actually have been able to observe that interaction. So it has to be frequent enough to observe given the number of observations you're taking. And lastly, just by looking at what somebody's doing, it may be really hard to understand not only what they're doing, what exactly is the purpose of their activity, but also why it is happening. And so this is kind of where interviews may be able to step in and help out. But if you're just looking at what the person is doing, it may be really difficult to understand why. So if you're interested in getting more information about observation, one of my favorite books, and it doesn't just talk about observation, it talks about kind of analyzing social settings in general, but it has some very solid chapters on observation. My favorite book is this book by Laughlin and others on analyzing social settings. So take a look at it if you get a chance. That's it, and I hope to see you next time. Hello and welcome back. Today we'll be talking about the contextual inquiry method of doing formative work with your users. So if you've seen the other two videos that I've done on kind of formative methods with users, observations and interviews, those are words that you may have heard in other contexts as well. But contextual inquiry kind of sounds like a fancy phrase. It's not one you may hear that often. So let's define it first. Contextual inquiry combines some aspects of interviews and observations. So for example, it's a focused planned study with a clear purpose that you plan ahead of time. It does use data-driven observations and interviews. And it provides documentation with notes, transcripts, and other supporting data. But what's different about contextual inquiry is that it also emphasizes the natural context. So this is not typically something that's done by inviting a user to a lab out of their natural context. This is something that's typically done where they would actually perform the activity. It also emphasizes the partnerships with participants in collecting and interpreting the data. So it's not just you as a scientist coming in to analyze people under your magnifying glass, but it is in fact this kind of partnership process where you're trying to understand something and you're soliciting the help of your participants in order to understand it. So why would you want to use contextual inquiry? One of the reasons is that it actually addresses the different shortcomings that interviews and observations have. You get to observe the action as it happens. You're able to ask questions in the moment, so you can actually avoid some of that recall and reporting bias that participants might have. And it allows you to have those follow-up questions to get to the nuances of what and why in understanding an action, which is something that purely observational methods may actually struggle with. So let's give a quick example of a contextual inquiry approach. So let's say that you want to understand how electronic health records, or EHRs, are used by actual medical professionals. So what you might want to do then is actually solicit a medical professional, follow them in their clinic with their permission, observe and take notes while they complete their tasks using the EHR, and ask interview questions about what you observed. Now, some of these interview questions may come afterwards at the end of the day. Maybe you have a set of questions that you want to get through. But some of those questions may actually be interjected as you get an opportunity. So maybe they, as they're entering something into the system, they exclaim and they're frustrated about something. And you may ask, wait, what happened? Why did you, go back a few screens? And they're like, oh, I forgot to enter the dosage for this medicine and the rest of the system won't let me proceed. I have to undo all these steps in order to continue. So they kind of provide you with insight right there and then that may be invisible, but may really provide some context for what's going on. So how do you do contextual inquiry? 5 steps here, roughly a similar structure to doing observations and interviews. So the first step is arranging access and structuring that partnership. Because again, it's not about just the observer and the observed, but rather about this idea that you are coming together to understand the activity of interest. You want to prepare your notes structure. You want to then conduct the observations and interviews that are sort of part of contextual inquiry. You interpret the findings with the help of the participants. And lastly, you analyze. So to arrange the access and to structure the partnerships, you need to first figure out who you're going to be observing. For example, in the EHR example, you may be observing a doctor, you may be observing nurses, you may be observing sort of medical clerks who are actually entering the data. Those are all opportunities. And you need to decide who is and who isn't relevant to you. When and where will you observe? So if you're going to a particular hospital, how many visits will you make? Typically, contextual inquiry is done over multiple sessions because that lets you see a lot more kind of detail about what's going on. And it also kind of prevents people from saving kind of the least controversial tasks to show you on the data that you're observing. If you're coming from multiple sessions, you're probably getting the most honest view. How will you document the process and what kind of data can you collect? So your participants may actually have some opinions about this. Maybe they don't want you to take photographs. In fact, that might be quite common in a hospital where patient privacy is really important, so they might not want you to be standing so close behind them that you can see the screen and read people's names, for example. You may also ask, when is a good time to actually be jumping in with interview questions? So if you're observing a medical professional, doctor entering EHR data, that may be whenever they may be able to take a moment to answer the question. But let's say you're observing a surgeon doing a complicated surgery procedure, maybe they would rather you not jump in with your questions right in the middle of the surgery, but instead note them and wait until after that activity. So these are all important to get with your participants. These are not just decisions you're making, these are the decisions you're making together as a partnership. The next step is preparing your notes structure. So again, this is probably very similar to something you saw in earlier videos on observations. You want to figure out what you hope to capture in your notes, what kind of other evidence you want, what granularity is relevant to you. But then in addition to all of that, you also want to figure out when are you going to jump in with questions and what kinds of questions will you ask. So this is kind of a combination of having an observation and an interview protocol. Once you're actually conducting the observations and interviews, agree on clear instructions for both you and the participant. When are you allowed to intervene? When are you allowed to speak up? Where do they want you to be in particular places, especially if it's kind of a high-stakes setting like a hospital? And also, what do you want the participant to do? Do you want them to show you something special, or do you want them to just go about their day as is? Do you want them to verbalize about the activity that they're doing? Like, do you want them to describe what they're entering into the EHR system? Set up any necessary equipment you may need for your study. Again, that's usually some sort of recording, some sort of notes. And then as you're doing it, just take notes on your pre-prepared structure. Jump in with interview questions when appropriate, or note those interview questions to ask later. It also might be that even though you originally agreed with the participant that you could jump in to ask questions, they may in the moment say, wait, not right now, maybe a little bit later. So you may have to kind of adjust on the fly. Afterwards, after the session, actually debrief with your participants. Show them what your notes are. Again, they're a partner in understanding what's actually happening, and you do want them to have that power to say, ooh, you noted this, I think you misinterpreted what happened here. Or maybe something even like, you noted this, but maybe we can keep this off record because this is a little bit embarrassing. And in these cases, you do have to respect the rights of the participant. I also like reviewing the notes and transcripts after the observation and writing those field notes about the experience. Again, because it can be very easy to forget some piece of insight that you had while you were observing, unless you actually kind of reflect it right away after the study. So again, after each observation study, make sure to schedule some time where you just start sitting down and reflecting and writing your field notes. The fourth step is interpreting with participants, and it's kind of unique to this contextual inquiry approach. You want to both debrief after each session and also at the conclusion of the study. And the goal here is to retell the story of your inquiry from your perspective. It's typically chronological. So you just say, I came into the hospital and I saw that you were visiting with patient X. Afterwards, you took the paper chart and you entered some information from their paper chart into the computer that's located in the hall, et cetera, et cetera, et cetera. Be sensitive to the fact that your participants may actually be impacted by the stories that you tell. And be flexible in your reporting. So as I mentioned, sometimes participants may actually ask you to take out some piece of information. I don't think you should ever lie in the way you report your data, but sometimes some omissions can really help protect the participants, and you need to be respectful of that. They're putting themselves in a vulnerable situation. They don't need to volunteer for your study, and so they're kind of doing you a favor, so you may as well respect their rights. The last step is analyzing, and so as I mentioned before, we have a whole entire lecture on qualitative analysis and quantitative analysis, so I'll kind of leave that for the later videos. So what are the strengths of contextual inquiry? One strength is that you can, again, start work with no knowledge or hypotheses before starting. It's, again, a data-driven method, so you don't need to know a lot about the context before coming in and observing. It does also provide you that rich, nuanced data, and it does also focus on the actual process rather than the processes reported through recall. It does reveal those specific, concrete, unedited actions taken by the participants in a given context, but it also reveals the internal and invisible aspects of the participant's experience, like motivation, affect, identity, priorities, preferences, mental models, and all that, because you're also able to ask about the experience, whether in the moment or because you've noted a question to ask later. Now, of course, no method is perfect, so even contextual inquiry has some weaknesses. The one is that it requires a lot of time and effort. So generally, it's a very small number of users, even smaller than interviews could be, because you may be spending days following particular users in order to get to observe an activity of interest. It does require that access to and cooperation of participants in a specific context. And it's particularly critical in this method because, as I said, you are really soliciting the participants as partners in gathering, interpreting, and understanding their data. And of course, just as in other observation studies, it does rely on the task of interest being frequent enough to observe. So if you were focused on a very specific EHR entry task, like maybe an EHR entry task that has to do with a particular rare disease, you may not actually be able to observe that in the moment, because if it's something that only happens once a year and you're there only observing it for 3 days, that might not happen during that day. So if you'd like more information about contextual inquiry, there's an excellent book about this, or I guess chapter about this in the participatory design book, and from the inventors of this method, really. And if you want kind of a shorter reading, if you don't feel like you can read an entire chapter, there's a really excellent article called Apprenticing with the Customer that, again, I link here if you have access to the ACM Digital Library. I hope you check it out, and I hope to see you in the later videos. Thank you.
Good to see you. We've been talking a bunch about user research, and I want to bring up a really important topic, and that is the topic of ethics and consent in user research. Ethics and consent? You might wonder what this has to do with designing interfaces, but ethics are critically important whenever you're involving people in what you do, whether you think of it as research or work. And ethical obligations are often also legal obligations, that you not harm people, that you don't embarrass or shame them, that you don't put their jobs in jeopardy, that you don't cause them financial or emotional harm, that you respect their right to choose whether to participate and whether and when to stop participating, and that when you collect data on them, they understand what you're collecting and why, how it's going to be used, and how you're going to manage things like recordings. Just to give one simple example, if we're in an environment where we're trying to show and understand where people have trouble with their existing solution to a problem. So let's say we have a financial system and people are having trouble entering payroll. Right, and we say, would you mind if we record your use of the payroll system? Somebody might say, why? Oh, well, we want to try to figure out what's hard about it so that we can make it better. And they say, yeah, that sounds good. What we forgot to tell them was, oh, and we're going to post videos of people having trouble with using the payroll system on a public site to try to help convince everyone we need a new payroll system. And won't it be great when people see and recognize you and that you're making mistakes on the payroll? Well, no, that's not great. That's something that can get somebody fired, get somebody shamed. Now, I know you would never do this. I would never do this. I'd love to say no one would ever do this, but unfortunately people have done this. And that's why we're going to spend a couple of minutes on some principles and some practical issues in ethics and consent. So in the United States, we tend to anchor most of our discussions of ethics with human subjects to a report known as the Belmont Report, which grew out of a national commission that was charged in the wake of some highly publicized unethical research. Most famously, the Tuskegee syphilis study, where researchers chose to study syphilis and its progression in a set of African American men rather than treat it and cure them, because they were interested in understanding what the disease did. And this created an uproar because here you have people who are, medical professionals who are denying people treatment and letting a disease progress in ways that may cause them, unknowable harm. And out of that Belmont report and the national and in fact global consensus that you can't just take advantage of people came three key principles. And these principles still underlie in different versions the ethics of human subjects work. The first was respect for persons. This is really about autonomy and consent. People are not there as an instrument for you to get done what you're trying to do. They are autonomous, they're deserving of courtesy and respect, and they have the right to choose in an informed way whether or not to be part of whatever it is that you're doing. We'll come back to the idea of informed consent in more detail. The second principle is one of beneficence. Minimize harm, maximize benefit. This is especially relevant in biomedical studies where we're talking about, if we're testing a drug, how do we make sure that it's being tested at a low enough dose that if it's harmful, you don't cause serious harm. But minimizing harm turns out to be a big deal in every kind of interaction where you're using people to study something or study people. And the final one is the principle of justice or fairness to all. This comes up in certain kinds of studies in making sure that you don't only study one population if the thing that you're going to later create from it goes out to many populations. This is a principle that's been used to, for instance, prevent people from doing medical studies only on healthy young men, resulting in the fact that we don't know how the drug might perform on women or the elderly when they might need that drug. You could make the same argument that if you're designing a user interface system for people who are using public transit, make sure that you're studying the behaviors and the capabilities and the usage of people who use public transit. Don't go off and say it's more convenient to study other people and design a system not designed for the people you're trying to actually serve. So with those three principles, the US created a regulatory framework. But even though the Belmont Report was focused on US biomedical research, the same principles are found all over the world. Canada's Tri-Council policy statement addresses in different language and slightly different issues, and certain things they raise to greater prominence about, for instance, how they deal with First Nations peoples and the integrity of tribes. But they're basically the same core ideas. India has a set of guidelines on institutional ethics committees for human research that look a lot like the same ideas you would find elsewhere in other parts of the world. There are guidelines in China, there are guidelines in Finland. Pretty much anywhere you go, you'll find that there are some guidelines. In some cases, these are only medical. In other cases, they've been extended to non-medical research, perhaps in part due to examples of harm in non-medical studies, like the famous Stanford prison experiments, where people had volunteered not really knowing what they were getting into and were assigned roles of either prisoner or guard and locked up or locking others up, and led to some pretty harmful outcomes. There were also some significant concerns raised about some of the compliance experiments where people suffered psychological harm from believing that they were administering shocks to others who turned out to be actors who were pretending to be shocked. Lots of examples that are not specifically medical. Some of this, you may say, feels very far away from studying users in their context, but the principles work out very much the same. So I want to take us through just three key concepts and a couple of points as to how you might put them into practice. The first is simply do no harm. Minimize risk. Think about and either eliminate or reduce and disclose possible sources of harm. How might a recording be misused or reused? I think about some of the early cases where people were studying telephone interfaces. And I've seen recordings where you'd have people struggling mightily to do something like transfer a call. Now, those were remarkably compelling for making the case that the interface had to change, but they could also be terribly embarrassing if they went out and they were, pitched in a different way as, look how dumb this person is who can't transfer a call. So what can you do about that? Can we avoid recording people's faces? Can we make them, fuzzed out and unidentifiable? Can we delete the recordings when we're done? What are we going to do with work logs? What are the risks of employer retribution if we're studying somebody's work and they become less productive or they tell us things their employer doesn't want us to know? What are the risks of embarrassment or violations of privacy or confidentiality? And consider also the context beyond the individual. Could we be harming an organization or a community? A number of people I know have tried to study how do we do building systems to support recovery groups, substance abuse groups, cancer survivors. How do we make sure that we're not hurting the group while we're figuring out how we can help them? That comes into issues of cultural and societal expectations, norms, and working with people who really understand the group and can help you understand what's appropriate and what isn't when you're dealing with them. Point number 2 is informed consent. Give the people you're studying the information and time needed to decide whether to participate. No pressure. Consider whether they can really volunteer to participate. Are they minors who need parental consent? Do they have reduced capacity? Is there coercion there? It's not okay to say, oh, your boss said I could study you, without also coming back and saying, wait a minute, how do I make sure that this person really does want to be studied and I'm not violating them ethically? How do we make sure that the right information is disclosed? Doesn't mean you have to say everything. You don't have to say, gee, I'm trying to figure out how often you use the mouse, because that might lead somebody to change their behavior. But it's reasonable to say, I'd like to understand how you use your computer to get your work done, and I'm going to be watching how you do that and recording what you do to better understand if we could design the system to be more efficient. How do we make sure that their questions are answered? And most important, perhaps, how do we honor the fact that consent is not irrevocable? That as you start the process, they may say, you know what, I'm uncomfortable with this. And we have to avoid possibly coercive measures that would stop them. You don't say, oh, gee, I put all this effort into starting to study you. You can't quit now. You can't say, well, gee, if you kept going, I would be giving you this huge, compensation payment, but you get nothing because you quit just before the end. You've got to make sure that people are not coerced, that they really want to do it. The third is the notion of ethical review. In many cases, that depends on company, that depends on country, you may have to have your work, your plans for user research, reviewed by others before you can start. In some countries, there are entities that have human subjects review boards. In the US, you'll sometimes hear of these as IRBs, or institutional review boards. Some countries, this is only for medical work. Some countries, it's only for research that's funded by a government. In some places, it's all work of a certain type. But many larger companies also have internal review processes before they'll allow companies to contact customers or study them, or even study their own employees. You need to understand the context in which you're working. And even when there's no formal review, you may benefit by having somebody knowledgeable about the types of things you're doing review your plans ahead of time to make sure that they're ethically comfortable, that you're not causing harm, that you're not doing something that you really shouldn't be doing. More broadly, recognize ethics are not just about meeting regulations. They're about the spirit of doing the right thing. So if you notice that somebody's becoming increasingly uncomfortable or agitated, don't wait for them to withdraw consent. Address this issue proactively. It's appropriate to say to somebody, hey, you're looking like you're not comfortable with me here. Would you rather I stopped? Get help recognizing potential harms in advance. Frequently, if you're not an expert in the work environment, you need somebody who is. And be careful about setting expectations. Something that's been arising more commonly recently is the idea that somebody who participates in any way along the process of something being designed might be entitled to a share of whatever comes out. This has happened in cases where people's DNA are used to come up with new drugs. But you could imagine this coming up when you're developing a new app, that somebody's there and you say, hey, can I talk to you and talk with you about your use and watch you for a while to help design this new app? And suddenly you come up with a new app and they say, hey, I helped design it. Where's my cut? Make sure you're clear up front. If you want to be generous and say, well, by the way, if we succeed, I'm going to acknowledge you, or if we succeed, I'm going to give you a free copy, that's great. If you want to make them a partner, that's great. I don't think you'll often do that. But if your plan is to say, look, I just want to make it clear you're doing this as volunteer work, or you're doing this and I'm taking care of getting you lunch, but you don't have anything else, make that clear up front so that you don't have problems later. So in this lecture, we've talked about ethics and consent in user research. We will come back to this topic of ethics and consent when we talk about usability testing and user studies in the evaluation course. But we wanted to deal with ethics right up front because you're going to be going out and learning about people, and we want you to do that in the most ethical and harm-free way possible.
Hello and welcome back. Today we'll be talking about designing a user research protocol, which is really a little bit about putting it all together. And I've referred to a lot of processes that are kind of inherent to designing a user research protocol while I've talked about interviews, while I've talked about observations and contextual inquiry and all that stuff. All those methods had a section that said something along the lines of plan your study. And that's what developing a user research protocol is all about. So why would you develop one? Why take the time to actually write down in a lot of detail what you're going to do? So one reason is you get a lot more consistency between sessions. So if you have all your questions in roughly the same order, if you know when you're going to deploy some sort of a questionnaire, if you know what kinds of things you're going to be noting in the observation, then you're going to get more of the same results from all the participants, rather than some participants you ask a certain question to, others you don't, and then you can't kind of say this person said this and the other person said that. You can only kind of follow up and try to determine what they said from the rest of their interview. You also want to manage your time to get to everything. Generally, in recruiting participants, you have to let them know how long the study will take. So whether it's an hour-long interview or an hour-and-a-half-long observation, whatever it is, you want to manage your time to get to everything. So if you have your protocol divided into sections and you know each part is supposed to take you approximately 20 minutes, you can kind of hurry it up if the participant is taking longer with particular questions, even potentially change gears if they really get stuck on a particular topic. Or you can realize that you actually have a lot of time left. You can ask more follow-up questions, more why questions of the participant to really get more depth on particular answers. So this planning, I think, is really helpful to figuring out how you're going to spend your time with the participant. It lets you anticipate and prepare for problems. So the main thing that the protocol lets you do is pilot. And when you pilot, you frequently find out that things take shorter than you thought, or longer than you thought, or a question that you thought was very clear was actually very confusing. And then you can go ahead and actually refine based on this process. So overall, developing a protocol is a really valuable part of conducting formative research. So the general structure that I like, and this is not everybody does this the same way, but just to kind of give you an idea. is I like preparing one paper packet per session. So if I'm interviewing a person, that's a session. Or if I'm doing multiple interviews, so let's say one a week for the next 4 weeks, each one of those counts as a session. The idea is that every time I meet with a participant, I have everything I need on hand and nothing extra. So what I recommend is actually combining everything you need into a single combined, easy-to-print PDF. It makes it much faster because somehow I find whenever I'm on my way to meet a participant, I'm always running late, so I don't have time to go through my machine and print 7 documents. This way I can just print a packet, grab it from the printer, and go. So a few things that I like including in this, mostly describing what I will do and when. If I have interview components to it, just having specific questions or prompts that I'm going to ask the participant, and any other study materials that you need. Joe in a previous lecture has talked about ethics of doing research studies. So one of the things you might have in this is something like consent forms. In a previous video, Hai talked about questionnaires and surveys, and so that's another thing you might have in there, some sort of a questionnaire that you would like your participants to respond to. And even if your study is mostly an interview study, you might still have something like a short questionnaire that just collects the demographics of the participants, so you don't have to ask them that. Consent form, as I mentioned, there's more on that in Joe's video on the ethics of research. Generally, you can get a sample one from your organization, whether that's a university or a company. So typically at a company, these come from company lawyers, and you may also have to get the participants to sign some sort of an NDA if you're testing a particular technology. But the key thing to remember is that frequently as the researcher, you're really also kind of the advocate for your participants. You have to kind of put yourself in those shoes of understanding that no study is risk-free. Participants are there and they're offering their time. They're being vulnerable with you by sharing, either allowing you to observe what they're doing or sharing very specific information about how they're living their lives. And you need to make sure that they can understand their rights. That they know that, for example, they can stop at any time. They can leave the study at any time. If they don't want to answer any question, they don't have to answer it. And this is actually particularly salient with kids because they're so used to being in a school setting where if a teacher asks them a question, they have to answer it. And they might not understand that actually this is not the same thing. There's no right or wrong answers here. This is just about finding out more about them. So managing that power differential is really important. Additionally, the consent form should have your contact information in a format that the participant can take with them. So what I frequently do is I'll have like either 2 copies of the consent or a part of the consent that they sign, and the other part I will unstaple and give to them to take with them home. Because sometimes what happens is that in the study, the participant is like, I don't really have any questions, but then later on they may have a specific question about how their data is being used, how it's being analyzed, or maybe even want to ask you not to use a specific piece of data that they generated. So overall, very important to make sure to protect the rights of your participants, and that consent form is an important thing to add to your packet. Now, other than this kind of introductory content like the consent form, I really like using the block metaphor to describe how a protocol may be constructed. So if you've ever played with toys like Legos or Duplos, the idea is that any block can be connected to any other block, and altogether they form a structure. So typically, my protocol is kind of bookended, I guess, by 2 things that I always have, which is the reminders for myself before and after the study and the debriefing block. And inside there's all these content session blocks that could mean questionnaires, it could mean interviews, it could mean observations, or any other number of things. Now, one of the things that I typically add in the reminders for self portion of the study is things like remembering to bring my audio recorder, remembering to check the batteries in my audio recorder, remembering to bring notes, remembering to confirm. And some things that I include in the after study session are things like getting the audio off my recorder so that I don't run out of memory for next time, or taking my field notes so that I don't forget something that I saw in the observation but didn't have time to note during the session with the participant. Also, as I mentioned, you'll have some sort of an introduction and consent block. If you're not the only person conducting the study, if there's multiple people conducting it, I like to use a consistent introduction block because frequently how you frame the study changes the kind of data you get. So Frequently, this is just a block of text that each person reads, and it says something along the lines of, "Hi, my name is Lana Yarosh. I'm a researcher at University of Minnesota, and I would like you to try out a new system that we're building and give us some opinions on this. We are not testing you, we are testing the system." So that's an example of something that might go in the introduction block. So now let's get to the content session blocks. So let me give you some examples of what these might look like. So if you have questions that are not open-ended, so those would not be appropriate for an interview, questions like, what is your age? What is your gender? How many kids do you have? Questions that basically have a single word answer or a very short answer. I prefer adding those to a questionnaire rather than asking them as an interview set of questions. So frequently, this takes forms of something like a demographic questionnaire. Additionally, there may be other kind of validated questionnaires that you may use as part of your process. So there's a few we talk about in this course later on in the evaluation, but some examples are the NASA TLX, which is a questionnaire that measures effort during a particular activity, or the SUS, which is a usability questionnaire. But the point is that you want those already printed, you want those ready to give to the participants. Frequently, I like to bring an extra copy in case they want an extra copy if they mess up writing and they want to rewrite it somewhere. That allows me to have all the materials on hand, and then I'm also prepared for any questions the participant may ask about those questionnaires. Let's give another example of a content session block, an interview topic. So perhaps, and I'm going to use the example of the work I do with understanding the role of technology in recovery from substance use disorders. Maybe I have a content block where I'd like to know more about the kinds of apps they use on their phone to help with their recovery. All the questions that are relevant to that, I will put on there. All the follow-ups that I may note, that I may keep in mind as the person is answering my interview questions, I will put in that block. I will estimate how long it should take to cover all the material in that block. And if it looks like the participant is not quite, is taking too long with the questions, I may skip a few questions or hurry it up or actually move on to the next block just to make sure to get all the information that I need. So there's more on this in the interview video. And I always add the reminder, remember, these are supposed to be open-ended questions. So if any questions in your interview block end with, or can be answered with yes or no, then you're probably better off either rewording those questions or combining all those questions and putting them kind of in a more questionnaire style format. It will take less time to do it that way. Let's do another example of a content session block. You might have an observation session that's kind of integrated into your protocol. So as an example, with the study with technology for recovery from addiction, I may want to observe how somebody would actually go about finding a specific meeting, AA or an NA meeting that they want to go to. So I may note on my protocol a prompt that I would use, something like, how about find a meeting in St. Paul on Thursday morning? And I may give specific directions to the participant, whether it's like, pretend I'm not here and do it as you would if I wasn't in the room, or as you do it, think aloud for me and describe what you're doing. And usually for myself in the protocol, I will note exactly what sort of things I'm interested in noting as I'm observing the participant. Again, we talked about this a little bit more in the observations videos. These notes could be very unstructured, like a blank sheet of paper, or they could be very structured, where you're expected every 30 seconds to record something about what the participant is doing. And both are okay. It's about what's appropriate for your study. And so basically the idea is you combine all these content blocks in order to make your protocol. And the one thing I want to make clear is, of course, these examples are not exhaustive. We've talked about a few methods in this course. There are lots of methods out there. You might have contextual inquiry blocks. It's just an example of how you take all these methods and combine them into a single study. The key is, I think, is know what you hope to get out of each block. Don't just add a questionnaire because you can, or a bunch of interview questions because you think you should have some interview questions in your protocol. Think about what's appropriate for the study. Think about what you hope to get from the participants as they go through this process. I think that'll really help you get the most out of your time and the most out of the participants' time as well. And I hope I also kind of made this clear as I went, but multiple blocks of the same type is totally fine. So I've definitely had protocols before where the study was just an interview study, where I would have 3 content blocks that were all just sets of questions on different themes. So it was just a study that contained the bookends and then the 3 content blocks that were all interviews. But you can also, of course, mix and match. So you could have observations and interviews and contextual inquiry and all these other things that are kind of mixed together and are part of the same study. The key is think about it ahead of time. Write down what you're going to do so you can be consistent across sessions, so you have a chance to pilot, so you have a chance to actually try it out with somebody and iterate and refine it. And that's all I have to say about designing protocols. Thank you for joining me for this video, and I'll see you next time.
Welcome back. In this video, I'm going to discuss log analysis. What is log analysis? Logs are the traces of human behavior seen through the lenses of whatever sensors we have. For example, web applications often keep records of visitors' information on the server end. These web log data often include information about which users visited the website at what time, using which browsers, etc. Log analysis is the activity seeking to make sense out of the log data. Why log analysis? In previous videos, we have talked about many user research methods: interviews, focus group, observations, contextual inquiries. However, user data collected using these methods are often small in quantity. Now, through web-based applications, we can collect lots of data very quickly and very easily. Analyzing large amounts of log data allows us to see phenomena that were previously unobservable. There are many types of information that could potentially be logged. One type of information is the user interaction information, including queries, clicks, URL visits, system interactions. In addition to the user interaction information, one can also collect context log information, including web pages shown, ads, etc. There are some commercial log data visualization and analytical tools available in the market. Here is a screenshot of a data visualization provided by Google Analytics. One common practice to perform log analysis is to partition data to view interesting slices. For example, we can log for changes in behavior over different times, different user types, different locations, different languages, different entry points, devices, and different systems. Here is one example illustrating how to partition log data to view interesting slices. This figure shows the bounce rate on the GroupLens Lab front page in 2 different months, April and August. This figure tells us that the bounce rate is much higher in April compared to August. Here, the bounce rate represents the percentage of visitors who enter the site and immediately bounce, that is, to leave the site rather than continue viewing other pages within the same site. So this figure tells us that the bounce rate is higher in April compared to August, which means that visitors in April are much more likely to leave the site, while the visitors in August are much more likely to stay in the site. One possible reason is that many visitors in August are current and incoming students of the GroupLens Lab. They often stay in the site to look for information to prepare for the new semester. However, many April visitors might be random visitors, so they tend to leave the site very quickly. The strength of the log analysis is that it can provide a complete and accurate picture of real user behaviors, including the ones people don't want to talk about. Second, log analysis allows for statistical analysis on large size of data. Regarding how to perform statistical analysis, please refer to the video on quantitative analysis in Module 3. Although the log data analysis is often very powerful, we need to keep in mind the weakness of log analysis. What logs cannot tell you is people's intent, people's experience, people's attention, people's beliefs on what's happening, and log analysis also limited to existing interactions. And also, log analysis cannot draw causal relationships. Takeaways. Log analysis gives a rich picture of real-world behaviors. There are many types of log data, and we can partition the data to view interesting slices. Finally, we need to recognize what the data can and cannot tell us. Thank you for watching this video. Hope to see you in the next one. Welcome back. Today I want to discuss surveys and questionnaires. What is survey or questionnaires? Note here we use the term of survey and questionnaires interchangeably. Survey or questionnaire is a list of questions aimed at extracting specific data from a particular group of people. Survey can be powerful user research tools if they are designed appropriately. How to design a survey? First, you need to decide the topic of the survey. Then, define the population and sample for your survey. Third, create survey questions. We can evaluate and modify survey questions based on 5 principles. Fourth, send out survey requests. Finally, analyze survey responses. Deciding the topic of the survey is important because how well you define your main goal of the survey will determine the population, sample, the question asked, and shape the quality and the usefulness of the responses. Usually, at the very beginning of the survey, we will provide a concise description of the survey goal to your responders. The second step is to define the population and sample. Based on the topic of your survey, define the requirement of your population. For example, is your target population children, smartphone users, heavy users of social media sites? Because it is not always feasible to survey the entire population, you often need to take a representative random sample. One scientific way to determine the sample size is to perform the power analysis. Due to the time constraint, I'm not going to talk about details of power analysis here. If you are interested, you can Google power analysis. There are some tools available on the market to make it easier to design online surveys. I used the SurveyMonkey and SurveyGizmo. Both of them worked fine for me. There are 5 principles of designing online surveys. First, the survey should clearly instruct respondents about how to proceed. Second, make your first item in your survey interesting, easily answered, and fully visible. Third, restrain the use of colors so that consistency and readability are maintained. Fourth, present each question in a format similar to the format normally used on paper. Finally, avoid differences in the appearance of questions that will differ across platforms. So often, before send out your survey request, you should test your survey in different browsers, in web or in mobile, and in different operating systems. The next step is to send out survey requests. There are multiple ways you can share your surveys. You can email your survey links to people. You can embed the survey in web pages. You can share survey invitations on social media sites, etc. Finally, analyze survey responses. By analyzing the responses, you can test your hypothesis, approve your hypothesis, or disapprove your hypothesis. You can answer your questions, uncover trends in the data, and provide guidance to your design. You can watch the quantitative analysis in Module 3 for more details about how to analyze survey responses. Takeaways. Survey can be a powerful user research tool to extract data from a specific group of users. 5 steps to design a survey. First, decide the topic of the survey. Second, define the population and sample for your survey. Third, create survey questions. Fourth, send out survey requests. And finally, analyze survey responses. Thank you for watching this video. Hope to see you in the next one.
Hello and welcome back. We've been talking a lot about formative user research, and now it's your turn to try it out. Today I'll be talking to you about your assignment to observe 2 users. So here are the basic assignment components. You'll be asked to observe 2 participants in a specific context, and we'll talk more about these contexts later. You will write a 2 to 3 page description of your user observations, including the following. So it should have some sort of an introduction, introducing your context. It should describe the participants, the setting, and the recruitment strategy that you used to find these participants. It should describe your methods, how you decided to take notes, and any of your interactions with the users, things like asking them follow-up questions or debriefing with them. You should also provide a detailed description of data from each of your 2 users. What did you see? What did they do? And finally, a brief analysis of what you saw working well, what was problematic in terms of what your users did, and possible opportunities for design in that particular context. So I know that this is somewhat abstract, and it always helps to see an actual example. So I find it's always helpful to actually see an example of how this would work. So what you'll find in Coursera is one example of an assignment for a context of trying to take out cash from an ATM machine. So the assignment is a 2-page write-up of 1 user observation, and it also has the rubric that is going to be used to grade you as well. So take a look at the assignment, think about how you would grade it using the rubric, and then take a look at the grades that we gave it, as well as the comments on why we gave a particular grade. This should give you a lot more understanding both about how to go about doing your assignment and about how to grade your peers when you get to that part of your work. So there's 4 contexts that you can choose from, and make sure to just choose one context and to observe 2 users in that context. Don't pick 2 contexts and observe 1 user from each. So the 4 contexts you can choose from are getting a train or a public transportation ticket from an automated display or kiosk, observing a driver as they drive a car, observing somebody try to find a hypothetical mobile phone plan for a visitor, and observing somebody use a point-of-sale checkout system. So a little bit more detail about each one. And one of the reasons we actually give you so many contexts is because some of these may be easier for you to access than others depending on where you live. And so do pick one that is actually reasonable for you and that you can get access to. But if you live in a big city, especially kind of in Western countries, so US or Europe, you may have an opportunity to watch somebody purchase a ticket for something like the subway, the metro, a train, or a bus, using an automated machine similar to the one in this photo. So we want you to actually get the user's permission to observe them or ask a friend to actually use the device while you observe them and observe their interactions with it as they purchase a ticket. The second possible context is observing a driver in a car. So again, we want you to get the person's permission. We don't want you to be observing yourself while you're driving because that's not safe. You can't take notes while you're driving the car. But as the person is driving, kind of note how they respond to distractions, what kind of technology they use, as any, and how they find their way upon a particular trip. Now, of course, this could be somebody you know. So for example, you can ask your sibling to drive the car while you observe them. Or this could be somebody that you kind of recruit on the spot. So maybe if you're already taking a cab ride, ask your cab driver if they're okay with you recording them. Well, taking notes about them, not actually video recording them. The third context is sort of a hypothetical situation. So see if you can recruit a friend or a family member and ask them to use whatever tools they would use if they had kind of this hypothetical situation of a friend is visiting them, they'd like to find a mobile plan for the next month while they stay in your country, and how would you actually find and recommend a plan and compare maybe multiple plans to suggest to them. So lots of people would probably in that process go to their browser, mobile web browser, and try to find the answer to this question. Other people may try to do that on their phone. Other people may choose to ask somebody. But the point is just observe them working their way through this hypothetical problem. And the last context you can choose is a point-of-sale checkout system. So many fast food restaurants use a computer to check people out. Many stores, retail stores, use some sort of a device to help purchase an item and then check a person out. And again, here you would want to ask the permission of the person you're observing to perhaps look over their shoulder while they're checking you out or checking somebody else out. But hopefully you'll have access to somebody in your life that can help you, can have you observe them as they're using this point of sale system. So those are the 4 contexts, and as I said, we'd like you to pick one and observe 2 different users, 2 different participants in that context. Now, as you're carrying out your assignment, so you can review some of the videos that are relevant, but you should remember that you should prepare your notes structure, so decide what kinds of things you're going to observe. So for example, your notes for how somebody buys a ticket may be very different from your notes on how somebody is using technology or managing their distractions while they're driving in a car. You should schedule and arrange access if you need to, so do ask the participants' permission to actually be observed. You should observe your 2 participants in the context while you're taking notes. Now, you don't have to only get all your data from looking at them. You can also ask follow-up questions or perhaps debrief them after the observation. That is up to you, so some interview components may be included in your protocol as well. And lastly, write up your observations. Now, a few relevant lectures for you to review as you go through this process. I think the most relevant will be the observations video. So take a look at that if you don't quite remember how to conduct an observation study. If you are going to include some interview components in your study, take a look at the interviews and focus groups video. And the designing a user research protocol may be helpful to kind of remember how to put it all together, how to get started with a participant, how to debrief them, all those parts of it. So hopefully this is enough to get you started on the assignment. There'll also be a write-up on Coursera that you can read through. And if you're not sure where to start, I would really just suggest looking through the example and reading through the example we provide as a good place to get started. Thank you, and I hope you enjoy this assignment.
Welcome back, everybody. The topic for this video is translating user research to support design. Now, in the last few lessons, we've been concentrating on gathering data from users and doing user research. So you wind up with data. Well, now what? In the next series of lectures, what we're going to be doing is giving you some techniques for analyzing that data, for making sense of it, and then for capturing the results in representations that can be used to guide design. So let's talk a little bit about the data analytic methods you'll be learning. Roughly, you'll be learning 2 general classes of methods. We'll call them qualitative and quantitative. Qualitative methods are tailored to work on data that's expressed as text. Now, this typically means the kinds of responses you get from interviews where people fill out forms or you take notes on their responses, notes that you've taken from observing people as they work or as they do their activities, online information, let's say information from documents that are produced online. So qualitative methods are structured ways that you as a person, as an analyst, can go through this textual data and discover patterns or themes, concepts that emerge, things like user needs and requirements. So qualitative methods let you do that sort of thing. Quantitative methods, on the other hand, are applied to structured or numeric data, things like logs of user activity or large-scale responses to surveys, things like that. And the way you analyze those, you end up with things like statistics, graphs, charts, overview aggregate numbers that give you a picture of what is in the data. Now, once you've analyzed this data, or once you've analyzed your data, you need to come up with representations of this data that can be used to guide your design decisions. And over the next few lectures, we're going to be talking through a number of such representations. So personas, and we've touched on most of these earlier in an earlier course as well. So personas are model users. Based on user research, you notice patterns, you cluster users together who share common reactions or common goals, attitudes, responses, and so on. And then you come up with a fictional user who represents this aggregate of user attributes. And this is useful in focusing design and making sure that your design can support this class of users. Usage stories are rich descriptions of system usage, and in some cases this system may not exist, or if it exists, it may not do the things that you talk about in this narrative, in this user story. And the point of a usage story is to serve as a vision for what could be, for what might be, and gather interest and assess whether this is a vision that people think is actually worth implementing. A task is a more focused description of what a particular user or user group is trying to accomplish. And once you have gone to the trouble of defining tasks, then these can be used to guide design. Namely, you want to make sure that your system can actually allow users to accomplish this task. And a scenario or walkthrough scenario is a way, a specific way that a task can be accomplished in a specific interface. So once you have a task, once you have an interface, this is a step-by-step sequence of actions for accomplishing that task in that interface. So that's a quick overview of what you'll be learning in the next few lectures, and we will be going into detail on all of those things. We'll look forward to seeing you next time.
Hello and welcome back. Today we'll be talking about qualitative analysis. I know I've been referring to it for quite a few videos as I discuss things like interviews and observations and contextual inquiry, and today we'll actually talk about how to do it. The method I'm going to be discussing here is inspired by something called grounded theory method. Now, we won't go into too many details about grounded theory. It could take years to learn, and I'll refer you to a book at the end. But I'll just try to be very pragmatic and describe the method step by step. So what you need to know about this is that this is an inductive, data-driven approach. What this means is that you don't start with a hypothesis and you don't start with the things you think you're going to find, but rather you sift through the data to see what insight is available in the data itself. This process also relies on something called constant comparison of open codes. The idea that you identify units of meaning within your data and then you compare them to each other to identify meaningful clusters and patterns. Now, both of these, the idea of a method being inductive and data-driven and the idea of constant comparison, are key to this grounded theory method. And so if you do end up reading the grounded theory book or finding out more about it, you will hear words like data-driven and constant comparison used there as well. So this kind of serves as a foundation to learning more about similar methods in the future. So here's an overview of a qualitative analysis process. You're going to prepare the data, do an open or initial set of coding on it, do some thematic clustering, final coding, and finally writing. And writing is part of the qualitative analysis process. This method is really powerful because it can actually be applied to any type of data that could be made textual. So obviously, if you have interviews that you've recorded and then transcribed, that transcript is textual data. But perhaps less obviously, the field notes that you make in observation or after contextual inquiry are also potentially part of a data set. You can even add word descriptions, so text descriptions, to something like video, audio, images. Like, for example, children's drawings on particular topics can become sources of analysis by converting them to text. So as long as you can take some piece of data and make it into a paragraph, you can then do qualitative analysis on it. So the first step is, in fact, this preparation process. Can you take the data that you currently have available and transform it to text? If it's an interview, this just means transcribing. If it's other types of evidence, it may mean creating a text description of it. Now, if you're doing this project in the real world or if you're doing it for research, chances are you want to keep your participants anonymous. You don't want their names appearing in your findings. And so I find that this is a very good stage to actually go through that anonymization process. Typically, I just remove all names and label each participant with a number, participant 1, participant 2, etc. And this is the good stage where you want to also link any associated data for specific participants using that number. So let's say if you had conducted an interview and then some observations, and then also given a questionnaire to the participant, you want to make sure that all of those are linked to the same participant number. And this is great to actually do explicitly, because I have had a study where we kind of haphazardly ended up assigning numbers and accidentally assigned the same participant number to two different participants, and then ended up spending roughly a week trying to disentangle the data and figuring out, okay, well, we have this quote from this participant. Is this indeed from participant 2, or is this the other participant that we labeled participant 2? So if you're explicit about this and careful about this early in the process, you can avoid going through the same panicked week of a lot of work just to make everything make sense again. The second part is called open coding, and the goal of this stage is really to immerse yourself in your qualitative data, to really understand what meaning is there. The general process is pretty straightforward. You take your textual data, you read through it, you highlight anything that may be significant, and you write a short phrase for this highlight to express the meaning that's in this highlight. This short phrase is in fact your open code or your initial code. Now, generally, you try to write a short phrase to capture each unit of meaning. So it could be that the participant has actually spent a minute communicating with you, and there's really only one unit of meaning there. As people, we frequently add a lot of kind of cushion words around what we say, so the participant may have repeated your question and then said, let me think about it, and then said, I think the answer is, and then only that last part where they actually tell you the answer to the question is the unit of meaning that you have to label. Conversely, sometimes a single sentence can hold a lot of meaning. So maybe they say one thing, but it actually applies to multiple different points. So maybe I ask them, how do you currently stay in touch with your child? And they say something like, well, I really rely on the residential parent to help me stay connected. We also use phone and video chat whenever possible, except that the kid sometimes thinks it's boring. So there's actually 3, maybe 4 units of meaning within that one sentence that participant could have said. The first unit is they rely on the residential parent to help. The second one is they use video chat. The third one is they use phone. And the last one is that this is not engaging to the child. So I could potentially have 4 different open codes just for that single sentence. And they're all kind of units of meaning. So as an example, I recently did a set of interviews with families, cross-cultural families. So these are families where one parent is from a different culture than the other parent, to kind of identify opportunities for technology in that space. And from the 20 interviews that we conducted, we had more than 750 open codes. And that's pretty typical. You usually get hundreds of codes just from a few interviews. So the next part is actually making meaning of all these codes that you have. So this is the clustering process. What you really want to do is arrive at thematic clusters, kind of larger units of meaning that take all these open codes and combine them in ways that let you see patterns. So this is definitely kind of there's an art to this process. It can also be guided by theory. So if there's specific things that you already know you might be interested in, you might kind of look for that in the clusters. But most of the time, it's fairly data-driven. So you start out not knowing what kind of meaning you have in the data. Now, there's tools that aim to help you with qualitative analysis. Here we'll actually just be mostly focusing on paper as a tool, because that's the tool most readily available. And honestly, that's the way I still do qualitative analysis. I think it's really effective. I think it's a great way of collaborating. But there are other tools out there, and just so you're aware, there's a free tool called WEFT-QDA, which helps you assign codes and then cluster them. Recent tool somebody told me about called NVivo is also all about that kind of qualitative clustering. And then Atlas TI, I think, is a fairly comprehensive, fairly expensive tool that also specializes in kind of doing video labeling as part of that data set analysis. But let's talk about paper, because as I said, this is the tool that's actually available to most people. So here's how you would do thematic clustering using paper. So have one open code written on a note, so maybe a sticky note, a Post-it note, whatever you have available. And also jot down the participant ID on that note. So something like, from my previous example, child not engaged with video chat or phone was a unit of meaning from the sentence the parent said. So I would jot down that would be on a note as an open code, and I would say something like participant 3 is the one that said it on the bottom. I may take that note and another note that I have currently in my large open code pile and compare the two. Maybe I have another note that says something like, my kid is bored unless we play video games. Maybe that's a quote that some other participant had. Well, I can compare the two and think, do they actually communicate a similar sense of meaning? So maybe these two are actually pretty similar because they're both about the child not being engaged. But they're not exactly the same. So one is just talking about the fact that phone or video chat is not engaging. And the other one is really focusing on the fact that video games are. So I would put them somewhat in a similar location on, say, a wall or a tabletop, but maybe not in the exact same space, so they wouldn't be overlapping. Now, if I then pick up another note, and maybe it says something about video games, but nothing about engagement, so something like, my kid and I like to play World of Warcraft together, that might go closer to the note about video games, further away from the note about engaging over phone or video chat, and so on and so forth. Each note I pick up, I compare to all the notes that are already on the board and place in relationship to them, in terms of the geography of the board. Now, as you keep going through this process, as I said, it's quite typical to have something like 750 open codes from a set of interviews. You may find that you need to keep adjusting your categories. So, for example, let's say that halfway through this process, I find that there was a lot of nuanced answers that people gave about video games, and that I can't just keep it all as a single category, that maybe lots of people talked about World of Warcraft, lots of people talk about Minecraft, lots of people talked about casual games, a few people talked about games you play about also video chatting, kind of like you can play checkers over the network. So all of those games are actually a little bit different. So I'm actually going to my category that had all the games listed there, that it was just about video games, and actually do a little bit more of kind of separating things and moving things apart. I may also find that, kind of started with something being central, and the entirety of the bodies of notes kind of moves towards a certain direction, and I may need to kind of reposition it in order to continue being able to add notes to it. So this is quite common. So adjusting, adding new clusters, moving entire clusters is all part of this process. And when you finally run out of notes, the next step is just to name the clusters as you see them. So perhaps I would still have a cluster that's focused on playing video games with children over distance. Maybe I'd have a cluster that's focused in the effectiveness of video chat and phone, and those might be separate clusters. Now, the next step, once you kind of have gone through this process, is to actually kind of develop your coding schema. So these clusters that you have named now serve as the coding schema for you to analyze the rest of your interviews. The idea is that now you can do a pass through the data, so reading again through all your textual data, coding units, whether it's a note on your, like a line on your field notes, or whether it's an entire participant saying they fit into this category or not, or whether it's a specific comment or a specific answer. So coding these units into the identified clusters. Now, optionally, and a few people like to do this, but it's kind of a controversial thing in the field still, optionally you can do iterator reliability on a subset of these codes. So if you want additional confidence to know that a particular statement, you've actually assigned it to the correct category, or in fact, or I would say assigned it to a reasonable category that other people would also assign it to, you can ask somebody to help you calculate an iterator reliability analysis. The way you do this is you provide them with a code book that you use to assign your codes, and you provide them with some randomly selected subsets of your unit of analysis. So it might be some set of statements that participants made, or some set of interviews. You ask them to go through it and assign codes, and then you calculate Cohen's kappa on that analysis to make sure it's satisfactory. So you might think, okay, well, why wouldn't everybody do this? It seems like it would just only improve work. It's not that controversial. And the reason that not everybody does it is, in fact, it could be a little bit misleading. It's adding quantified information to a place where that's not really what this is all about. So qualitative analysis is kind of about making meaning, and that meaning is being made from fairly small number of participants, so interviews typically less than 20, contextual inquiry maybe even smaller than that, and assigning things like iterator reliability or numbers or saying how many participants did what can actually be interpreted in a misleading way. People start thinking that your data is representative, and I've had this happen to me. One of my papers said something along the lines of 3 of our participants said that they used video chat, and later I found this paper cited elsewhere as something along the lines of like it gave a percentage. It said something like 3 out of 18 participants, and therefore this percentage would actually use video chat. It kind of suggested that we had a representative sample, and whether that was not the case. So lots of people who actually report qualitative data choose to focus on themes because those are harder to kind of try to think that this applies to everybody. It's more focused on this idea of telling the participant's story, and so it's kind of more true to the method's nature. But in the end, especially with kind of less, with textual data that may be more controversial or perhaps is harder to put into categories. I think iterator reliability analysis could add something to that process. And now we get to the final step, which is writing. So this is part of the qualitative research process because you're really putting together all these very nuanced stories, all these very nuanced ways of looking at it. Writing really helps you get the concrete statement of what are we getting out of this? What is actually the takeaway from all these interviews or all these observations or all these contextual inquiries that we've done? And there's kind of a few guidelines I have to being a good writer of formative work. So the main one is that you want to tell the story. So your data is going to have a story, and that doesn't just mean listing all the themes or listing all the clusters that you came up with, but rather kind of the larger takeaway. You want the story to always stay true to the data. Of course, you don't want to lie. You want to support every claim with quotes that participants have made, and you want to account for exceptions. So if 9 of your participants said one thing, but then there were 2 that were kind of vehemently opposed that are very different from that, you want to actually talk about those exceptions and do communicate the experience of these other users as well. I actually really like being specific by giving numbers of participants. Again, this could be controversial because then it could be miscited as saying that a certain percentage of your participants did something. But to me, it's kind of more exact than saying some or many or almost none or whatever kind of hand-wavy words you can use. And the key is that you also want to give next steps and implications for design. And I say implications for design here, this could actually be, either specific design ideas, or it could be something like personas, or it could be design requirements. Whatever it is that you think should be done with the data that you found through a formative process, I think it's important to articulate it, because at this point of the process, you'll have more insight into the data than perhaps anybody else in the world. You've probably spent hours reading through the interviews. You've spent hours making open codes and clustering them into categories, and then actually coding all the interviews again with your final categories. That deserves some recognition. I think your recommendations will be taken seriously, so you do want to make sure to actually give them in the write-up of your formative process. So I've mentioned these books before, but all of these include chapters on qualitative analysis. I think the one book I hadn't mentioned before is this Basics of Qualitative Research by Strauss and Corbin. So this is, if you want to learn more about grounded theory method and kind of really not the abbreviated version, but the real process, I think this is the book to read, the one in the middle there. But the 2 other books to the side, Interviews and Analyzing Social Settings, are excellent books that provide very kind of practical descriptions of the analysis process, and so I also recommend looking at those. To summarize, qualitative coding is complicated, but in the end it's just a process that you can follow. So I hope that this gives you more insight into how you can make meaning out of your qualitative data, and good luck with your analysis. I'll see you in the next video.
Welcome back. This video is about quantitative analysis. Quantitative methods emphasize statistical analysis of user data collected through surveys, through questionnaires, or computer-generated records, that is, logs. There are 2 ways to perform quantitative analysis: hypothesis-driven approach and a data-driven approach. The differences between these 2 approaches is when data collection and hypothesis forming happens. In the hypothesis-driven approach, you first have your hypothesis in your mind and then plan how to collect the data. In the data-driven approach, you already have the data available and try to uncover some interesting trends from the existing data. In this video, I'm going to use one example to go through all the steps of quantitative analysis using the hypothesis-driven approach. After this video, I want you to have a basic idea about how to perform a quantitative analysis. First, assume that you have a hypothesis in your mind and you want to approve or disapprove it. Your hypothesis is female users spend more time on Facebook compared to male users. Once you have the hypothesis, the second step is to decide the independent variables and dependent variables. In our case, the independent variable is the gender, and dependent variable is the time people spend on Facebook. After you form the hypothesis and decide the variables, you know what data you want to collect. Basically, you want to have the data about people's gender and about people's time on Facebook. There are two ways you can collect this data. You can create a survey and direct ask people their gender and time they spend on Facebook. We already learned how to design a survey in previous module. Or, if you are the data scientist in Facebook and have access to the user log data on the server end, you can easily collect millions of users' data on their gender and their time on Facebook. Here is the data might look like. No matter whether you collect the data from the survey or from the log, you will get a data table similar to this one. There are 3 columns: participant ID, gender, and the average minutes people spend on Facebook per day. Note that these are not real data. I just use this as an example to illustrate how to run the analysis. Once you have the data, the next step is to analyze the data. Today, I'm going to focus on linear regression. Linear regression is a technique to understand the relationship between one or more factors of interest, that is, independent variables, and an outcome-dependent variable. In our example, we want to know the relationship between gender and time. So we want to know how gender influences people's time, the time people spend on Facebook. A little bit history about linear regression. Linear regression, particularly multiple regression analysis, arose in the biological and the behavioral science around 1900. However, multiple linear regression was often computationally intractable in the pre-computer age. This led to the development of more computational simpler models such as ANOVA, which is especially applicable for planned experiments. Nowadays, with the fast development of the statistic packages and tools, multiple linear regression becomes standards in most social science areas, including the field of user research. There are many advantages of linear regression model. First, the form of the relationship is not constrained. Although it is called linear regression, we can actually use linear regression to understand the other types of relationships, such as curvilinear relationships. Second, the nature of the research factors expressed as independent variable is not constrained in linear regression. Third, the nature of the dependent variable is also not constrained. You can use any statistical packages such as Stata, JUMP, or R to perform the linear regression. Here is the output of the linear regression models from Stata. This table might look overwhelming to you. So what do all these numbers mean? To interpret the result, we need to do the final step. To figure out the results of linear regressions, you need to understand 3 things: p-value, coefficients, and R-square. P-value tells us whether a relationship exists or not. A rule of thumb is that if the p-value is smaller than 0.05, you can say that the relationship exists. In our example, p-value can tell us whether the female users actually spend more time than male users. Coefficients can tell us how strong the relationship is. In our example, it can tell us how big the differences of female users' usage time and male users' usage time. Third, R-square can tell us what proportion of the variance is accounted by the variables. In our example, it can tell us the proportion of the variance in Facebook usage time is accounted by gender. Now we can interpret this table. First, let's look at the p-value. The p-value is 0.567, which is much larger than 0.05. This means that the differences between male and female Facebook usage time is not statistically significant.
The coefficient here is 16, which means that the differences between male and female users' usage time is 16 minutes per day. However, because the p-value is pretty high, the coefficient becomes less meaningful. The R-square is 0.0197, which is about 0.02. This means that only 2% of the variance in the Facebook usage time is accounted by gender. Overall, this data does not provide strong support to our hypothesis. Female users spend more time on Facebook than male users. Again, this might seem overwhelming for those of you who do not have any experience in statistical analysis. So if you want to know more about linear regression, and you can take a statistics class. A takeaway. Here are the steps to perform quantitative analysis. Form hypothesis, decide the variable, collect data, run statistical analysis, finally interpret data and report the results. Thank you for watching this video. Hope to see you in the next one.
Welcome back, everybody. I'm Lauren, here's Joe. In this video, we're going to take a deeper look at a concept that we introduced in an earlier video, namely personas. So let's review quickly. What we told you before is that a persona is a construct that is based on user research, and it's a narrative description of a synthetic user that represents an important usage pattern. And it's determined by taking your user research data and clustering it, finding important patterns of usage, and then coming up with this description of a synthetic user that encapsulates the important pattern. So let me give you some more details about the concept of personas. So the origin of this concept of persona came from a person named Alan Cooper, who's a designer. He's been around for a long time. He wrote a book called The Inmates Are Running the Asylum, which first really popularized the concept. And I think it's useful to point out that this was developed in a practical setting, in a business setting, not an academic setting. And so what you'll see is this is a very sort of practical, business-oriented concept rather than a formal academic one. Now, personas are realistic and specific. They capture important details of a realistic group of users and group of usage that are an important way of communicating to designers what they should keep in mind when they're designing. Now, typically there's multiple personas for any application, and each of these represents a key usage pattern. And this is important because it helps you remember that when you're designing an application, you're not designing it for everybody, you're not designing it for some vaguely envisioned user group. Instead, there's probably a few key constituencies or usage patterns that you need to keep in mind when you're designing. Now, we might think of a few particular types of things you would put in when you're talking about a persona. You know, demographic information like age, gender, education level, things like that. And that's important, but you also want to put in other more rich information, the motivations, the needs, the tasks, and goals of a particular usage group. And personas tell a story. They describe why people do what they do, what they're after. And really, personas are super useful in design because they help designers focus. They provide a context for design decisions. They let designers say, you know, would this person, Anna is the name of a persona we're going to come up with in a minute, would Anna be able to do this task? Would she understand this? And it turns out that's very useful.
Yeah, and personas can even be used when you're thinking later about testing and saying, well, who should I be recruiting for my tests and what things should I be having them do? I often think about the failures here, and we at a university suffer from financial systems. And one could imagine that somehow out there, the people who design these systems, which will go nameless but sell for millions of dollars across thousands of customers, so they're big, that they probably imagined, well, what do we want to make sure that the human resources department has for finances and payroll, and maybe what do we want to make sure that the management has. But when we humble faculty members try to use these systems, it seems like none of the designers were ever thinking about us. And we sort of wish that they had put together a persona of a sympathetic and humble faculty member, so that as they were designing things, they might have had those thoughts of, wait, maybe what we're designing isn't going to be usable by that really sympathetic character that we have hanging up on the wall.
Right. And we could even give that sympathetic and humble faculty member a name, but maybe we shouldn't at this point, right?
Maybe not this time.
Okay, good, good. Okay, so what goes in a persona? So a bunch of key specific information. What is the role or group that we're representing with this persona, like web manager? A name and a photo. Again, we're being very concrete. The job title, major responsibilities. Demographic information, key stuff about this person: age, education, ethnicity, family status. Again, we really want to get at higher level or more fundamental information, like the goals and tasks they will be trying to complete using this application. A concept that's really important is their pain points, their needs, their challenges that they face. What are they trying to overcome that you might be able to help them with this application? The physical, social, technological environments of this person. For example, are they the kind of people who sit at a desk all day, or are they on the go? Do they work alone or with other people? Things like that. A very powerful thing is a day in the life narrative. Sort of what is their flow like through the day? What are their typical activities? And then a crucial thing is a quote that sums up what matters most to the persona as it relates to this application. A little tagline that designers can keep in mind to help them focus on meeting the needs of this persona.
And as you're thinking about this, of course, we understand you'll recognize these personas might be geared towards a work application. Right. Now, if you were designing Pokemon Go, you might worry less about whether somebody was a web manager or a warehouse worker, and worry more about the depth of their Pokemon hobby and whether they still have all of the cards that they collected, or whether they're new to the game. The key is to get the information that's really relevant as you're thinking about this as a real type of person, even if they're a representative of a group.
Yep. And one other important point to make about personas, I said this is typical information in a persona. There is no prescription. There is no required definition of what is or is not, or what can or cannot be in a persona. Rather, this is best practice. And so you can follow this, but of course put in variation as it's appropriate for your application. So let's talk a little bit about developing personas. And in this example, the next few slides that I'm going to go through, I'm going to use some information from Smashing Magazine, which is a website that provides good information for web designers and developers. So I've got a few URLs that you can go consult if you want more information. Now, the examples that I'm going to walk through for a bit are following a made-up medical software application. So eventually, or at points, I'll sort of refer to concepts like doctors and so on. And that's why, because we're thinking about a medical software application. So when you think about developing personas, really think about beginning with user research, which we've spent a lot of time on in the past. So you have to identify your users first. And if you're thinking about a medical software application, your users will probably include different work roles like doctors, nurses, hospital administrators, things like that. So make sure that you have users from all those roles that you're going to do research with. You next need to decide what and how to ask. What is it you're trying to find out based on what you know, what you think you need to learn, and how are you going to gather the information you need. In business uses, the typical method used is a combination of interview and observation, which is really good, which is really effective. But as we'll see in the next video, any way that you can get user research, whether it's finding quantitative data, doing surveys, doing log analysis, can be valuable input for developing a persona. You then, of course, have to gather the data. And then coming into the last couple steps, which are more specific to persona development, you have to analyze the data and produce the persona description. Now, for analyzing the data, what you typically do is define a set of attributes that you can place the user responses on, and then you cluster together the users as to how they respond, and those then become the basis for the personas. And I'm going to talk about these next two steps in a bit more detail. Okay, again, analyzing the data in the context of developing medical software applications. Now, what you will typically find as you analyze the data is a set of attributes will emerge. And in this example, we see a set of attributes that made sense for this hypothetical medical software application, like how often does somebody conduct surgery? Do they, let's see, do they, I'm having a hard time actually seeing this. Okay, that's great. Do they prefer older techniques for surgery, or do they prefer newer or cutting-edge techniques? Do they work on a small team, or do they work in a large team? So those are the kinds of attributes that you might find emerging from your data. And then as you see those attributes, you can start to place the different user responses on these spectra, on these spectrums. And so as you do that, you then start to see patterns, you start to see clusters. So if we look through these, we see, let's see, Tiffany and Sam are two users that are starting to cluster together a lot. And we see Elliot, Dan, and Whitney as two other users that are three other users that are starting to cluster together a lot. And so we observe those patterns, and those clusters start to form the basis for personas. And once you have that, you can then look at the information you know about those users and start to develop, well, what are the demographic characteristics that really characterize, the key demographic characteristics that characterize Tiffany and Sam? What are their key goals and so on? And that gives you a good basis for writing your personas.
And I think something you should notice here is these don't have to be perfect. Mm-hmm. So Tiffany and Sam cluster together, but they have exactly opposite views on, the tried and true methods and the cutting edge methods. Tiffany's at the cutting edge, though I don't know, as a patient, I might think the cutting edge was the old way and the lasers are the new way, but we won't make that joke here. But Sam likes tried and true, surgery procedures that have been refined over time. That doesn't mean we can't recognize that they mostly cluster together and create a single persona that may represent Tiffany and Sam and may represent one of them slightly better than the other.
Right, absolutely. And it's also worth pointing out, when we say clustering here, often when personas are developed in practice, the clustering is done manually. People are doing it, the designers are doing it, and observing how they think the data fit together. Some of you may have a background with using automated clustering techniques, which, in some cases, if you have quantitative data, you could try those techniques to develop the basis for your personas. Okay, and then let's take a look at, let's go on to the next one.
Oops, sorry. Oh, one more time.
There we are. Let's take a look at an example. This is an example now in a different domain, outside the medical software domain, I think for a simple writing application. And I just wanted to show you this very, very briefly to give you an idea of the actual richness and specificity of a persona. We see a photo, we see the name, Fred Fish, we see the job title, corporate chef. We see a quote underneath that says, "Get me out of the office and into the kitchen." And key types of information underneath that we see the key goals and a day in the life. And by reading through the key goals, we can see this is what Fred is trying to achieve, and a day in the life gives us an idea of what are the typical activities that Fred goes through and what does he like to go through. We sort of close the persona with a little quote at the bottom right that again encapsulates some of the key aspects of the persona. And on the left side, we see a few basic pieces of information about things like computer use and so on. This is a good example of the kind of richness and specificity that makes a persona useful. And as we've said, once you have a persona that looks like this, in your design conversations, you can say things like, would Fred Fish be able to figure out how to use this application? Would Fred be able to be happy using this since he doesn't like to sit in the office, instead he likes to be out in the kitchen? And that is it for this lecture. We took a deeper look at personas, and in the next lecture, we'll take you through an example of developing a persona from user research.
Look forward to seeing you there. Welcome back. In the last lecture, we came back to the concepts of personas and gave a little bit more detail about developing them. This lecture walks through examples of developing personas for a system you've seen earlier, the MovieLens system. So a little bit of a history about this. This is going to be an unusual persona development, but unusual in an interesting way. The original MovieLens system, as it was created, never had any user interface design done. It was a strange situation where a site that already existed, called eachmovie, was shutting down and shutting down quickly, and we had the opportunity to take it over if we could build it. And so the directive was clone it and clone the interface as best we can, and we got something built in a month. That was no time to study users, that was no time to do anything. But none of us ever believed that was the right way to build the site. It was sort of an emergency and an opportunity. So over time, we've conducted substantial user research. And it's a nice example to look at synthesizing personas for MovieLens because we have so many different types of data to work from. We have survey studies, we have interviews, we have usage data logs, we even have data we collected in research studies. And in this lecture, we're going to bring these together to form a couple of personas. We'll also take those going forward, or one of them in particular going forward, as we look at use cases and even into task and scenario development. So let's take a look at some of these sources of user research. Perhaps the most common one for an existing site is usage data, and we're going to talk about both aggregate and user level data. If you have user level data, you can look at correlations and what behaviors happen coincident with other behaviors, much like we saw in our last lecture looking at particular doctors that might have similar patterns in their surgery. We did a bunch of work with web surveys, and I'm going to take you through one of those in a second. We did a little bit of telephone survey work to get a little bit more depth. We have our history of user support contacts, mostly emails, and then other data collected in prior studies, and I'm going to come back to the idea of external data. So here's some examples from survey data that we did. In this case, this survey was conducted as part of a larger study. And we started by asking people why they use our system. That seems like a really useful thing. And what you'll notice is that we had about 330 responses, and almost 60% of them said their main reason for using MovieLens was to view recommendations. That's good to know. But what really shocked us was that about 30% of them said their main reason for using our system was to rate movies. This was a shock to us, and it required follow-up. We never thought of rating movies as something people wanted to do. In fact, when you saw that redesign that we talked about earlier in this course, we talked about how do we get away from forcing people to rate movies. But in fact, the study said that for some people, rating movies is where the fun is. And that's something that causes us to think hard about the fact that we have different kinds of users and different kinds of usage. When we asked people why they rate movies, again, the majority was to improve recommendations, but there were a significant number, about 100 of them, where their first choice was to either keep a list for themselves or because rating itself was fun. And these were popular second and third choices as well. And so suddenly our thinking had to develop. We asked people what they thought of the system. That's lovely. The people who stick around in the system like it. That wasn't that useful. We've asked them a lot of other questions, whether the system is getting better or worse for them. We asked them what they thought the system was worth. This was a study done with economists, and they like to reduce everything to dollars. We also asked how often they do different things in the system, from several times a week to less than once a month to never. And we'd see that all sorts of activities, there were certain people who did them and certain people who really did not. And that gave us some information. We also looked at their beliefs on different things. You can see these are on sort of fun scales where we can look at agree or agree plus don't know, or just look at disagree. And mostly people's opinions were positive. The one thing we found out was people mostly don't write reviews anywhere else. Well, we can also look at very specific data. This is a set of graphs we pulled up for the last month of activity. On our left, we have login count. And the vast majority of our users log in fewer than 5 times in a month. But there's a significant chunk that log in more. And we're going to take a look at that in a bit more detail in 1 second. We have tags. Most people don't tag, but a bunch of people tag significantly. Ratings, the distribution's much broader. Again, most people don't put in a huge number of ratings in a month, fewer than 25. Well, that shouldn't be so surprising. 25 is our quartile. That's a lot of movies, frankly. 25 is the 3/4 mark. For somebody to have 25 new movies to rate in a month, either they're going back or they see a lot of movies. But, the median person rated about 6 movies a month. That's an interesting number to take a look at. We actually can pull that up in the form of a spreadsheet, which I'm going to get you here. And what you're going to see here, I'm going to take you all the way up to the top, is the data that we've dumped out by user, sorted by the number of times they logged in the last month. And it shows some interesting patterns. It shows that we have some really aggressively wonderful super users. The kind of person who's coming in 6 times a day, 4 times a day, 3 times a day, twice a day. But these people aren't all the same. Some of them love to tag movies. Many of them never tag a movie during the month. Some of them rate a movie not even every time they log in. Some of them rate several movies every time they log in. As we go down, we see people who log in less, but some of them have even more activity. This person logged in 55 times in a month and rated over 2,000 movies. With detail, we could look up, is this a new user who was just getting going? Is this somebody who's just insane? In a good way. And we could say the same thing about this person who rated almost 2,000 movies in 45 logins. But of course, we also have to look further down. There's a pretty smooth slope. But as we keep going, we'll see that there's people at relatively small number of logins who rate a lot. There's people who don't rate much at all. And the vast majority of the people who came in this month logged in once and did very little. So knowing that gives us another way of looking at people in clusters. Let me add some other data to this. We did some phone survey data. We actually hired an undergraduate to contact a bunch of our users a while ago and find out what mattered to them, why they used the system, what they thought about how the system worked. And it was interesting. The biggest reasons we heard from the phone survey were that people liked our system because they believed it was independent and therefore trustworthy. We had no advertising. We weren't selling them anything. That was a big deal. That's come up in other forms of input as well. It comes up in surveys. It comes up in unsolicited comments. It comes up in some reviews people have written of our site. We learned that many people who use the site regularly don't understand or really even care how the system works. They're not technology people. One of them actually assumed we sat around in a room and came up with good recommendations and then put them up on the site. Didn't even understand that it was trying to be personalized. We were disappointed that our communication failed, but happy that they trusted us, that well, thinking it was just our opinion. There's a wide variety of use contexts we've learned about. Some people use this as a planning tool. Some people use it more as a reflecting tool. Let me think about the movies I've enjoyed. Some people make active decisions. Some people just use it to browse for fun. And almost all of the people we talk to use this as one of many tools when they're selecting a movie. Some don't use the recommendations at all, and almost nobody uses MovieLens as the only source of information with selecting a movie.
Yeah, I think, Joe, what I've heard you say that is really interesting in this example is how there's different lenses on the users. Each different method of gathering data gives you different types of information, all of which can be useful. You can do interviews and find out about people's motivations, goals, their attitudes toward the system. You can do log data and find out about usage patterns and let you say there's super users versus casual users, different types of usage. And it's really interesting to take all those kinds of data and put them together to get a rich picture of different types of users.
Exactly, and I'm going to even overload us with just a little bit more data. We did a study where we gathered personality data on our users. And we discovered, not really a great surprise, that MovieLens users tended to be significantly more introverted than the population as a whole. I say it's not a big surprise because given the choice of going out with people to see a movie or talk about movies, or sitting on your computer screen using MovieLens to think about movies, the introvert is probably less likely to favor going out and talking with other people and more likely to favor spending time alone. We got behavioral data. We found some systematic differences between people who use the system but never see the movies we recommend. They don't seem to take recommendations. They often don't even ask for recommendations. And people who do take recommendations. We found out that some people view this as a social system and care about the other people that are there, and other people don't care about or even want to interact with social features, and we've had different ones over the years. And maybe the last thing is that in repeated studies, we have found that people care more about MovieLens as a concept, a site, or a community than about the people in the site. And so if we ask people to help MovieLens, they're willing to do work. If we tell them it'll help them, we get less of a response. I think people don't believe us if we say it'll help them. And if we tell them it will help others on the site, that doesn't work as well as just helping the site. So we do have a lot of data, but there's data we don't have. Our demographics are relatively poor. We can and at times have gotten some location data from IP addresses. That can be useful. But even though we've done some collection of gender and age data, it's pretty noisy and pretty sketchy. We also have little data on social movie consumption. I mean, do people go out by themselves? Are they watching at home? Are they watching with friends? And we could do a separate survey on this, and we may at some point, but this brings up the point that sometimes you can find external sources of data. So we could get data from some of the research companies that issue reports, mostly for businesses that subscribe, talking about what are movie ticket sales like? How many tickets are bought sole, pairs, larger groups? How many tickets are bought in advance versus bought right at the theater at the time? How much of movie watching happens on streaming versus cable television versus rental of still existing DVDs or tapes versus in theaters and broadcast. All of that is data we might be able to fold in if we needed it for our design. So let's move towards a set of personas. Much as Lauren showed you last time, we need to identify some dimensions that we might try to cluster people along. Here we have too many people to cluster them by just spotting them. We're going to cluster them by looking at aggregate patterns. And we identified 5 dimensions we thought were relatively important in what we saw. Usage level, ranging from these super users who come in, once a day or more, through average users, infrequent users, and the one-timers, which are a significant portion of our users that at times we care a lot about, and in some features we might not care about at all because one-timers never use them. What about their underlying movie fandom? What's become clear is that we have some people here who are super fans, who've seen thousands and thousands of movies and know a huge amount. We have people who are sort of enthusiastic movie fans, but not devoting their lives to it, average moviegoers, and we do get a bunch of users we've discovered who are technology curious, but don't really care that much about movies themselves. They're more interested in this as an artifact of recommendation, and so that's something we need to know about. In movie tastes, there's this continuum between mainstream and eclectic. That matters for us particularly because people with mainstream tastes, we can do a very good job for right away because we don't have to model their tastes. The average of our community is pretty mainstream. People with eclectic tastes will get more benefit from our site in the long run because it's a personal movie recommender site, but we need to get a lot more work from them to get to that benefit because there isn't one eclectic taste. Every eclectic taste is somewhat different. Second to last, we have usage goals. It's clear we have some people who are here for getting recommendations and decision support. Some people are there for personal logging and reflection. Some people, but a small number, intent, really care about self-expression and influence. How do I say what I think and help other people find good movies or steer them towards what I think is good? And these are not a continuum. These are different attributes that each user might have different weightings among the different goals. And finally, there's a geographic issue that comes up frequently, that because we focus on US movie releases, the North American movie market, which interestingly isn't just in North America, there are parts around the world where North American English language movies tend to get first releases, is a market that's much more likely to have a certain type of usage than people who are in a country where the North American English language films are not the dominant content, even if they are released and often subtitled or dubbed. And so we've noticed that users from other countries tend to be different, particularly other countries where English isn't the first language.
Yeah, I love the title of this slide, Towards a Set of Personas, because it reminds me that you can't just design your system, or if you design your system for one kind of user and one kind of usage, you're probably going to be shutting out a bunch of people. And knowing that you typically need a set of personas is a strong reminder to keep that in mind.
Right, but it's also a reminder that we don't want to just take all these combinations. This is not about factorial design where we say, well, let's find a non-North American who's a super fan, who's a whatever. Our goal is to capture the relevant design dimensions in reasonable combinations. That's what these clusters are. But too many personas is bad. For a site like this, we might have 3, we might have 4. We're not going to have 10 or 20, let alone all of the combinations. And so what we try to do is get the patterns that are really common and the ones that seem to be interesting and important, even if they're not common now, because the reason they may be not common is because we haven't designed well for them. So let's try some combination ideas and then we'll refine a couple of them into personas. So we might have the super fan, super user who really enjoys expression and reflection in the system. That's the sort of person we know we have a lot of. We might have the newbie explorer looking for useful information, who likes movies, tends to find stuff on the web, and is trying to find out whether this is a site that would make sense. That's something we get a lot of people who show up. We don't always retain them very well, so that might be an important persona. We may have the once-a-week movie watcher, sort of the typical person who sees movies regularly but not, obsessively, who values unbiased and maybe a little bit of quirky advice to help find movies that she or he wouldn't see all the time. One I know we've had some people in, and it may be an important category, but it's not a huge category, is the budding film critic. The person who wants to use MovieLens as a platform to help share opinions and influence others. And at various times we've made writing critiques a significant or not significant part of the MovieLens experience as we've engaged with or disengaged from this type of user. So let's try to refine some of these. And I'm going to start with the idea of Victor. Why Victor? Because you have to have a name. If you don't give a person a name, you don't have an identity. And Victor just seemed like a good name for somebody who's a real movie fan. He's 52 years old. He's a super fan of movies, an active MovieLens user from Seattle. Means we know that Victor is in the North American movie market. Seen over 5,000 movies, rated more than 3,500 of them on MovieLens. The other 1,500 either hasn't rated yet or maybe are movies we don't even have in our database. In a typical week, he watches 5 to 7 movies, sometimes in theaters, sometimes at home, including most new releases and lots of older films, because frankly, it's hard to watch 5 to 7 new releases every week. Victor uses MovieLens several times a week or more, mostly to record the movies he watched and what he thought of them. He actually has a collection of tags he uses to help him organize his movie experiences, which is a pretty cool thing to do. When asked why Victor uses MovieLens, he says it's unbiased, it's not for profit. In fact, he actually frequently volunteers for our experiments to support the community. When asked about recommendations, he confesses that he's almost never seen a recommendation from the site that he cared about. He already knew about the movies, but he occasionally looks at them anyway to see how well it models his tastes. Honestly, he doesn't actually think that MovieLens has a hard job modeling his tastes. He just generally likes movies. So if we say it's a good movie, he's going to say, yeah, I probably would agree with that. So let's reflect on this for a second. I got a picture for Victor. Now, I picked this picture up from the free for commercial use section of Flickr. And I want you to remember a couple of things. There is no Victor. We just made Victor up. He's not real. Yet. But much like Dr. Frankenstein, when we put our energy into it, we're going to treat Victor like he's real. And we're going to get our developers and our designers to treat Victor like he's real. Everything we said here, the quotes are made up. The data is not made up. It's a composite from the research that we've gathered. Victor is anchored in truth, but a synthetic composite, and we're going to treat him as real.
Yeah, and we can say, our designers can say, remember, Victor likes to rate movies, to keep track of what he's seen. He likes to tag them because he likes to organize his own set of movies. And he likes what we're doing because we're unbiased. We don't take ads. We're non-commercial. So let's keep Victor in mind. Let's be wary of putting in advertisements. Let's make sure it's easy to rate and tag. Those are the kinds of things that having Victor helps us do.
And if somebody suggests that, we might be able to improve our prediction value if we get rid of user-created tags, somebody on the team's going to say, wait a minute, Victor could care less about prediction quality. Victor cares a lot about tags to organize, and the victors of the site are the people who are putting in all this data. Maybe that's not a good design decision. So let's do one more example. So Anna is a 34-year-old potter. If you're not familiar with the term, this is somebody who creates pottery, clay pots and art objects, plates and other things from clay. She has a quirky taste in movies. In fact, she rarely sees movies with her husband and children, but more often watches them with artist friends or on her own. She's not a major film buff. Maybe she watches a movie once a week or so. And she found Movie Lens from the recommendation of a friend who said it was helpful in finding movies she had liked. And the friend had quirky taste too, so she tried it out. So Anna's been using Movie Lens about 2 years and has been pretty happy with it. She rates movies to improve her recommendations, but has never done anything else with the site. Doesn't care to tag, doesn't try any of the social features or other things. When asked about the site, she indicated she uses it occasionally, mostly to help pick among movies she hasn't heard of. She appreciates that the site helps her find the best choices among movies that might be showing at any time, and that it's unbiased, which matches her artistic values. So as we reflect on Anna, we found another Flickr picture, and Anna, we can tell just looking at the picture that she really wants to be guided towards a movie that would match her tastes.
Right.
We're going to use Anna as we go forward in our next lecture, and we look at some of the use cases. So I'm not going to reflect much more detail on Anna other than to say you'll see her again soon. And with that, we're going to wrap up our examples of personas. See you shortly.
Yep, we'll see you next time.
Welcome back. In this lecture, we're going to talk about use cases, sometimes also called usage stories. And we're going to go through a couple of examples after we introduce the concept. So use cases are specific, motivating narratives that are bringing together a user, a need, sometimes a context, and a system or design that illustrates how things should be. They are aspirational. What we mean by that is that the use case should motivate us to create this wonderful system that makes people's lives, people's existence, people's work better. When user research is available, these can be linked to personas. Even when user research isn't available yet, sometimes the very first step for somebody proposing a project, before they collect any data, is to say, we've got a vision of why it is that we should start down this path and then go and get user research. You can still be an aspirational vision. So here's an example of one that's an aspirational vision. Sam is overweight but trying to get into better shape through both diet and exercise. His doctor recommended the I Eat, I Step tracker app for his iPhone. Isn't that a cute name? I Eat, I Step combines a photo-based food tracker with a motion and GPS-based step and activity tracker. So through each day, Sam takes pictures of the food he eats. Takes a picture before and after to get a good measurement of the quantity consumed. And the app also tracks his activity through the day. At the end of each day, Sam pulls up the app and it asks him a set of questions. For instance, to identify a soft drink from the photo because Coke and Diet Coke look alike but have very different calorie counts. And whether his trip from work to the grocery was by bike or motor vehicle because it was moving at a speed where the system couldn't really tell. Sam doesn't actually understand how this thing works. Behind the scenes, it's a mix of advanced AI and crowdsourced labor. But each day he gets a report on activity and food consumption, and he can see graphs to track his improvement. After 4 weeks of using I Eat, I Step, he's lost 7 pounds and feels better than ever. So what did we get here? This story is aspirational and motivational. Don't you want to be the person who developed this app? Don't you want to help Sam get into shape? It doesn't reflect an analysis of today. It's a vision of what tomorrow could and should be. Now, that doesn't mean it's complete fiction. As we talk about techniques for prototyping, and there are people who've come out and created these video prototypes, people who've come out with movies that show what a future would be, but but they always argue they should be grounded in what we know will be possible, if not today, pretty soon. In fact, this I Eat, I Step, all the components of it people either have or are working on. There are folks who are developing tools where you take photos of food and it identifies the food and comes back with nutritional data. There are people already doing trackers where cell phones do an attempt to measure your steps and other things. So it's realistic, but it doesn't exist. More than anything else, it's a guide to a design and development team, and maybe even the people in marketing and product management who are going to have to make this succeed, that helps answer the question, why are we doing this?
Right. I think aspirational is a great word. And we can think, is this a good thing? Do we think that if we could fulfill this, it would be good? Would it be valuable? Would it be worthwhile? Would people want to buy it? And then once we think the answer to those questions is yes, then we get to try to make it a reality by building an app that will let Sam actually go through and fulfill this vision.
Yeah, you could even imagine putting this up on Kickstarter and saying, hey, contribute money. If we get $500,000, we think we can build this.
Yeah.
And yeah, I think there's a bunch of Sams out there in the world who would gladly have this app. Some of us would prefer if it were running on Android, but we're not going there. So what if we do have a persona? We can shorten the use case a bit by linking it to the persona, and we're going to do this for both of the personas we developed in our previous lecture. So what about Anna at the mall? Remember Anna, who didn't usually see movies with her children and husband because she has somewhat quirky tastes? Well, Anna had a few hours to kill at the mall and was hoping to find a movie worth seeing. She's no film expert, just an artist with somewhat quirky tastes, so she appreciates tools that understand those tastes and know about movies. Anna pulled up the MovieLens mobile app on her cell phone. MovieLens already knows a great deal about her tastes from the movie ratings she's entered previously. The app used her location to identify the theater and displayed a list of upcoming showings with star values suggesting which ones Anna would like. Anna saw Sam the Dragon Trainer was playing in 20 minutes, and that MovieLens thought she'd give it 4.5 stars out of 5. She bought a ticket, saw the movie, loved it, and actually rated it 5 stars. What do we get from this example? We're linking it to Anna. This is consistent with the story of the persona. But we've shifted into something that's, again, aspirational. It's aspirational in part because there is no MovieLens mobile app.
Right.
We're trying to convince somebody to design and build one. MovieLens has no location data. MovieLens has no theater showing data. And what this is doing is saying, wouldn't it be cool if we had all of that? Would it be? That's why we're writing this particular use case. We can circulate it around. See, do people rally and say, I would use that? Do people say, I would never do something like that? I'd never go to the mall without knowing what I was going to see, just go randomly see a movie.
So the use case combines what we know about Anna. It combines this aspirational story that includes her goals, what she's trying to accomplish, and a vision for how a technology could work to support those goals.
And that's the example of why we want a use case. Let's do one more. Let's take Victor. Remember Victor, the film buff and longtime MovieLens user? Well, he's invited to join a panel of experts presenting their all-time top 100 movie lists. If we wanted to localize this, we could put this at the Y in some cities. This might happen at a community college in other places. Different places might have different venues that would be appropriate. Well, a few films come quickly to Victor. The Godfather Part 2, Citizen Kane, but putting down 100 of them, and specifically just 100, seems like a challenge. Victor decides to use MovieLens to help. He asks the site to show him all the movies he's already seen sorted by his rating, and finds nearly 100 that he's rated 5 stars. Just to double check, he's also looks at top unseen movies and top movies by overall popularity, and given these movies, he's quickly able to make his personal list. We could provide more detail here if we wanted to. We really don't need to. We've gotten the essence of what this use case is. So as we reflect on these examples, they're evocative, they're concrete, they involve the system and in some cases specific interface details. And most of all, they show how the system solves a problem or meets a need or in some way makes somebody's life better. They're different from tasks, which we'll be coming back to in our next lecture, because they do involve specific interface details. They span all of the parts. They can involve how, they can involve what, they can do all of those different things while just telling a good story. And that's the essence of this, is that it's going to focus on telling a good story. So that's our use case introduction and an example of one purely aspirational and two persona-linked use cases.
See you next time. Welcome back. In this lecture, we'll talk about tasks and walkthrough scenarios. Now, you'll remember in the previous lecture we talked about use cases or usage stories, which were rich representations that included some information that were often linked to a persona, that included information about goals a person was trying to achieve, and often details about how they might achieve them. Now, if we think about tasks in particular, and we review a bit, remember, a task is a specific description of a complete job that specific users want to accomplish. It is the what, not how. That is, it has nothing to do with a specific interface or way of doing things. It is important to provide details, typical details about how somebody would do the job, and it isn't just a list of features from a system. It instead is the complete job that covers transitions between subtasks. And it's also important to note that once we go to the trouble of sort of factoring out a task, we're probably committed to saying this is something we actually want to design to try to achieve. Hasn't perhaps been achieved yet with the system, but we probably want to do it. So that's a task. It is the what, not the how. Now, a walkthrough scenario, or scenario we typically say, is a specific instance of system use for a particular task in a particular interface. It's how a user would do this task in this interface. So again, this is all review, so some examples that Joe gave in an earlier lecture. Somebody might be told, a scenario might be telling people, click on a calendar icon in this system, hit the next year button to get to May 2017, click on this next link, and so on. Or open fitness tracker software on your desktop computer, select share under options menu, and so on. Now, a key thing is a target user can follow the steps of the scenario without understanding the task. And that, I think, is important when we say target user, because notice what's sort of embodied in these two very simple examples I gave. Somebody can click on the calendar icon, they can hit the next year button. Well, what has to be true for that? They have to understand that this icon is a calendar icon, that it represents a calendar. They have to be able to use a pointing device like a mouse. They have to be able to see the screen. So these are assumptions that we often don't even realize we're making. But later on in future courses, we'll touch on, well, what happens for people who may have motor disabilities, who may be vision impaired, who may be low literacy, who may not understand English. All of those things are very important, and you need to take those into account when you understand who is your target user group.
And for those of you who are taking this course out of order, we did the full introduction to tasks and scenarios in the first course in the specialization. Those of you who went through that probably remember the exercise where you first evaluated a set of flawed in different ways task and scenario descriptions, and then wrote your own and peer-reviewed some of the others for learners who were taking that first course. If you haven't been through that and you don't feel this was enough to feel comfortable with the material, you may want to pause and go back into the task and scenario material in the Introduction to User Interfaces course.
So let's take an example, and this builds on what we have just done in the previous lecture on usage stories. So this is a task description. Anna often finds herself at the mall looking for a way to kill a few hours while her family shops. One thing she likes to do is take in a movie, so she'll head over to the mall theaters. But she's got a problem. Often she's only heard of one or two of the movies. She's not sure which one she'll enjoy the most, and so often she'll end up seeing a movie she doesn't like that much. Anna's task is to find a movie playing at the theater that she will like. Now, if you want to go back to the usage story, it might be interesting to contrast that with the task. In the usage story that we presented for Anna, we heard a little bit more about Anna. We linked it to the persona, and we also saw more about how she might do it with MovieLens Mobile, which did not exist yet, but that's okay because the usage story was aspirational. Here in the task description, we're simply factoring out what she's trying to accomplish. Namely, get a recommendation for a movie playing at the theater that she would like.
Yeah, and I think the sanity check you can always use for a task description is, could you give this to somebody who's one of your target users and say, go do this? And could they do it on different interfaces? And at the same time, would they understand what it means to do it? And with something like this, you might operationalize it for them. You might tell them the name of the mall differently depending on where you were running your tests. Pick a local mall wherever you happen to be. But the idea of find a movie playing at the theater that you'll like is a task somebody can figure out how to do.
Mm-hmm. Okay, so I'm going to walk you through a couple scenarios for this task. And remember, a scenario is a particular way to do a task in a particular interface. Now on this slide, you have a set of step-by-step instructions for doing it using the Google Chrome web browser. Let's go over to Google Chrome, and I'll actually just sort of walk through this myself and illustrate how you might do this. Okay, so the first step would be, and we've already taken the first step, which is to type into the address bar of Google Chrome the name of the theater you're at. Again, this is one way to do this task in a particular interface here at Google Chrome. So I've done that, and I get show times at AMC Southdale 16. And I can start to look and see what's showing. I see Suicide Squad is showing, Sausage Party, Pete's Dragon. If I wanted, I could, here at the bottom I see it says more show times. There's a down arrow here, and if I wanted to, I could click on that. And if I do that, oops, I get a list of all the movies that are playing, including Ben-Hur. And if I look over on the right side here, I see lists of aggregate information from different rating sites. So IMDb rates it 4.7 out of 10. Rotten Tomatoes gives it a 30%, and Metacritic, I think, gives it a 41%. If I scroll down a little bit more, I can see cast information. I can see people also search for, and so on. I could go back if I want and look at information for other movies as well. So if I click on Suicide Squad, for example, and then look over on the right side again, I can get this aggregate information. And if I scroll down, I should be able to get information for critic reviews. Now notice this isn't personalized for me. It does not tell me whether I would like it, how much I would like it. But what I can do is I can click on any of these pieces of information, like one of these reviews. I can get the full review. I could click up on, let's say, Rotten Tomatoes here, and I can go to the Rotten Tomatoes page, and I can see a bunch of information about that movie. I could read through it and make my own determination as to which movies at this theater I might like. So now if we go back to the scenario for Google Chrome, what I would say about this is this is a way that I might be able to satisfy the task, but it's not tailored to it. It leaves me doing a bunch more work. And that sort of takes me to the next point, which is, since this scenario does not fully support the task, I had to specify the theater I was interested in. And then even worse, I had to look through all this information about all these movies playing to see for myself whether I might like them or not. It's not a great way to support the task. And so, let's preview a little bit a technique we'll be talking about a lot in the next course. I could prototype an interface that supports this task much better, and then we'll see how I would walk through that interface with a scenario to do the task, and we hope that scenario would be much easier. Okay, so what I just did was I sketched out on paper a prototype, a design idea for a mobile application that would support this task very well. Now the basic idea here is I created a paper prototype. This is a quick way to capture design ideas, and as we'll tell you if you go on to the next course, this is a surprisingly useful way for testing interface ideas and getting fundamental feedback on whether the design idea makes sense or not. And so I sketched something out. I called it Movie Lens on the Go. And I have a couple things that you can tap or touch to move on. One says, let's see, what does that say? It says recommend near me, and below it is Movie Lens Classic. And I look at those and I think, well, I'm actually interested in getting recommendations near me, so I will touch that. And so the first step in this scenario is to tap or touch the link that says recommend near me. And when I do, Movie Lens on the Go tells me you are near the AMC Southdale 16 theaters. And the options it then gives me are recommendations for movies showing here, more theaters, and again, Movie Lens Classic. Well, the next step in the scenario is to tap on recommendations for movies showing here. And what I see here is a, let's see, yeah, I see in this prototype, oh, thank you, Joe. Yeah, there goes the cursor. I see the idea being communicated here is I have a little graphic for each of the movies. I have the movie title. I have Movie Lens predicted rating for me, which I gave as a number, and I have upcoming show times. And so I can immediately, at a glance, see what are the movies playing, how much I would like them, when they're available, and if I want, I can then touch the title of any displayed movie to get more information about the movie, and I can repeat this step as necessary to give me a little more information to support myself in this decision that I need to make. And so, just to recap what we did, we presented a quick sketch of an interface that makes a lot of sense. Movie Lens on the Go that lets me get information for movies as I'm out, as I'm about. It uses my location, and it makes it easy for me to see my predicted liking for the movies that are playing. Now that doesn't exist yet, but it is a design idea that I have captured with this paper prototype, and it is sufficiently detailed that it lets me specify what a scenario would look like for Anna's task.
So just so we don't lose the context of this in documenting user research, what's critical here is that we've looked at capturing tasks. These are not necessarily all aspirational tasks. Most of the tasks we will capture are what people are trying to do now. Mm-hmm. It just may be that there are certain tasks that are not very well supported. And so we will use scenarios, as we did for Chrome, to show how do people do this now? And by capturing what they do and how they do it, or what they want to do and how they fail to be able to do it, we can identify the opportunities for design that allow us to create this type of prototype and say there's an opportunity to make life better. We could do the same thing in mundane areas like payroll or signing up to For garbage collection or anything else, we look at what are the steps, what are they trying to do, what are the steps today, and when we find out that the steps today feel inadequate, what might we start thinking about as we move towards prototyping of how we could make it better?
Absolutely. And that's it for this lecture. What we did is we took a deeper dive into tasks and walked through scenarios. And as Joe just said, we gave you a quick preview of moving into the design world of doing paper prototyping, which is a useful technique for capturing ideas, ways that we can better support tasks that are not so well supported today. We'll cover that in detail in a future course, and we'll look forward to seeing you next time.
Hello and welcome back. Today we'll be talking about the idea of implications for design, which is another way of communicating the findings of your formative research work. So the key questions and implications for design is how we can get others, so let's say a team of designers or a team of builders who didn't participate in the formative study, to really understand the nuanced findings of our formative work, and to use those understandings to make specific design decisions as they move forward with the implementation or the design process of technology. So we've talked about a few of those in previous videos, so we've talked about things like personas and use cases, but implications for design is a particularly common one in human-computer interaction research. So frequently when you look at papers, and this is an example of a previous paper of mine, I don't expect you to be able to read this, but it has a section titled Translating Themes into Implications and Opportunities for Design. Or other papers will actually just have a section that's titled Implications for Design that help draw out the lessons from this very nuanced formative work into something that others can interpret and act on. Overall, there's 4 types of design implications. There are sensitizing concepts, there are abstractions and meta-abstractions, instantiations of the design, and prescriptions. And we'll talk about each of these in a little bit more detail here. So the first of these are sensitizing concepts. The idea that your formative work could have pointed out to some underlying concept that a designer must keep in mind as they are designing. These are frequently rather broad, so sometimes they point out kind of shortcomings of previous work in the field, or something that previous work in the field hasn't really considered. So 3 examples of this might be considering conflict and non-consensus in families. So this is something that came out of my previous research. What I saw is that a lot of work in human-computer interaction treated a family as a single unit that had kind of harmonious goals. But as I was studying divorced families and families where parents travel a lot, I actually found that there were a lot of examples where the 2 parents don't agree with each other, where the goals of the parents may conflict with the goals of the child. And so a sensitizing concept that I may want to communicate to designers for family technologies is not to assume that everybody's on the same page, to really consider the idea of conflict and non-consensus. Similarly, in a recent talk I heard, it talked about the idea of digital privacy. And particularly it focused on a very important group, survivors of partner abuse. Frequently when you talk about digital privacy to technology researchers, you may get kind of flippant answers like, privacy is dead. If you expect privacy, then that's not something you're ever going to get in the modern world. But the context of survivors of partner abuse is a really interesting one, where we really do want people to be able to feel safe again and to be able to kind of break the cycle of abuse, escape their abuser, and be safe afterwards. But where technology may actually do things like reveal their location or reveal something about them that they don't want their abuser to know. And it kind of flips that idea. It really does mean that we have kind of a moral imperative as designers to consider digital privacy, rather than say, well, if somebody wants privacy, they should not use our system. And as another example, a lot of work on online health support communities. So in my case, this is working with people who use technology for recovery from addiction and alcoholism, finds underlying concepts like the idea of trust. So how people use the community and what they find valuable in it really depends on how much they trust the other members of the community. So if you think about trust as a sensitizing concept, you may design your systems in different ways. You may design your systems in such a way that it increases that idea of trust, or increases the idea of social capital between 2 people, where they continue exchanging support until they can trust one another. But as you see, these are all kind of broad, so they're not saying specifically build X or build Y. They're saying consider these ideas because they're important to think about as you're deciding what to design and how to go about it. The other kind of level may be something like abstraction or meta-abstraction. So what it does is it clarifies important abstract functionalities, but it may not yet specify specific technology or solutions. So, for example, I did a lot of work with cross-cultural families. One of the things I found that one abstract functionality that may help those families is helping them discover shared or conflicting values. So when people come from different cultures, they may not even know ahead of time that they have some values that conflict, but actually asking them to perhaps share those values or respond to them is helpful for them deciding what to do in cases where conflict does arise. Now here I'm not saying, okay, well you should design a Facebook of sorts where you put down all your values and then it compares all your values to your extended family's values and points out the differences. I'm just saying that any way you can find of helping family members discover those shared values could be useful. Similarly, in my work on supporting parent-child communication across distance, one of the things that I found is that a lot of technologies that have been developed for communication really have originally been developed for adults. And so they focus on this idea of conversation and the idea of talking to each other. But I found that the abstract functionality that's particularly important for communication with children is actually shared activities, because that's when parents and kids tend to have their most meaningful conversations, is when they're doing something together, whether that's playing a game or helping with homework or even doing the dishes together, rather than just sitting across the table from each other and asking each other questions. So again, I'm not saying exactly how that shared activity could be supported. I mean, it could be Minecraft, it could be World of Warcraft that you're playing together, it could be some sort of an online help for homework portal. But I'm just saying that the abstract functionality that's important to support is that idea of shared activity. And as a last example, one of the things I find in my work on helping people recover from addiction and alcoholism is that in-person contact is very important for that social support. So you may think about the idea of how to reward people as they spend more time together with other people in recovery, or how to help connect them with other people who are nearby so they can get that in-person contact. But again, the idea is that the abstract functionality you want to support is connecting people in person rather than only connecting people online. So let's talk about the third type of implication for design, which is known as instantiation. So this is perhaps the easiest one to explain. So this is about providing a possible design solution. So these are actually two sketches from a paper on cross-cultural parenting, and they provide two very specific instantiated design solutions. So the one on the right is called Cultural Care Box, and the idea is that members of the family from multiple cultures would sign up for a box to learn more about the other culture, and they would get digital artifacts like recipes for food to make, videos to watch, something like cartoons to share with kids, articles about specific holidays, and so basically information to help them respect the other culture more. Another example, the one on the left here, is called Quizomatic. So this is kind of a specific instantiation of one of the abstractions and abstract functionalities that I was talking about on the previous slide. So before I was saying help family members discover shared and conflicting values, and Quizomatic is supposed to do that by giving you fun quizzes that you can take, which generates shareables that you can share on Facebook, something like the Harry Potter parent I'm most like is Molly Weasley, or something like that, something that you'd have fun sharing. But then it also combines those answers from your partner and from your extended family and gives you kind of points where you can easily compromise. So things where perhaps one person really cares deeply about something. The other person may not agree, but they don't really care that much about the way it's done. That's an easy compromise. Or discussion points, so areas where both people care deeply and may have disagreements that can lead to deep discussions on the topic. And gives them opportunities to celebrate the values that they do share in common as well. So again, these are very specific actual solutions. So the idea here is, I'm saying you make a website, and the person who's using this website goes through this process to actually arrive at identifying these shared values. Whereas the previous abstraction idea was just identifying abstract functionalities that would be useful for people. And the last type of implication for design is known as prescription. So this idea is about prescribing or saying specific requirements for a solution to work. So these can be fairly low level. So for example, if you're designing some sort of a video chat system, you may say that the frame rate should be at least 30 frames per second to support smooth interaction. So it's a very concrete, specific requirement that a system might meet. Or maybe you're doing something like a crowdsourced system, a system where answers for questions are gathered from people online. And so what you want is your answers to be validated by at least 3 other crowd workers in order to prevent spam from being part of the answer. So that's a kind of another example. It's being very concrete. Or maybe you're doing something like experience sampling, which is sending texts to participants to ask them answers to specific questions, perhaps to inform a digital system that you're building. And a specific requirement might be something like not sending any more than 3 texts a day. Otherwise, participants may find that intrusive and not accept your system. So again, these are very, very specific. They're telling exactly what the system should do in order for the system to actually work. So taking all those together, what is it that makes a good implication for design? Because all of these 4 are actually quite different from each other. And so I'd say there's kind of 4 different things that are important for implication for design to have. I mean, the first one is obvious. It should be accurate to your context. So if you're trying to describe and get these implications for design from your formative work, the implication should in fact be true to what your participants shared, whether through interviews or things that you observe the participants do in your formative study. The other thing, it should be, interesting enough that it generates and inspires future work. If you're telling people something that they all already knew, then it's not really going to do that much to inspire future work. It should be actionable. So this is perhaps harder with some of the more abstract ideas like sensitizing concept or feature abstractions. But it should be something that a designer can look at and think, okay, yes, I think I can see which designs would work based on this implication and which designs wouldn't work based on this application. And lastly, it should be original and novel. And this is perhaps the quality that's most prized in research publications on the topic. But I think most people want to be surprised by the findings of a formative study and not just be told things that they already know. Now, the last point that I want to leave you with is that the question of who writes implications for design is actually a very debated question in our research community. In the past, it's typically been kind of the ethnographer or the formative researcher who works on the project. But others have pointed out that perhaps doing good implications for design requires some design skills as well, and perhaps it should be a designer that actually creates those implications for design and then acts on them. Certainly there's a lot of debate, and I'll point you to the paper that has that discussion. I'd be curious to hear what each of you thinks. So for more information, there's 2 papers that I think are really good reads. So one is Generating Implications for Design, and it actually covers all 4 of these categories that I've also covered in these slides, and kind of discusses how other authors have discussed implications for design that come out of their formative work, and in general, which ones are more or less common in our research community. And the second one is a critical discussion of implications for design that kind of follows on to this question of who should be writing these implications for design, and should formative research work be judged based on the implications for design that it provides. So that's all I have for you today, and I hope to see you in the next video. Hello and welcome back. This video is going to serve as your very short introduction to our next series of lectures on getting from user research to design ideas. Now, if you've done a bunch of formative work at this point, and maybe you've done a bunch of analysis, you may have piles of information. You may have interview transcripts, you may have your field notes, you may have logs of system use, you may have both qualitative data and quantitative data, you may have personas or use cases that you generated through this process. And it may be that you might be experiencing a bit of information overload. At least I do frequently at this time. So how can all this stuff taken together, lead to interesting and specific design ideas? How do you go from this to actually deciding what kind of system you should make? And this is the focus of the next series of lectures. We loosely title them Ideation and Idea Selection, and they focus on the following ideas. Ideation is generating many solutions with the idea that by coming up with lots of different ideas and lots of different project directions, you'll be able to identify a good direction. Idea selection is actually about selecting the best ideas from your list, perhaps combining ideas that both hold promise, and deciding which ideas you're actually going to pursue. And the third step is actually communicating which ideas may be on your plate to stakeholders, which I personally prefer to do through sketching, and that's kind of the way I'll cover it here. So I hope to see you in the following few videos. Hello and welcome back. Today I'll be talking about ideation, which is actually coming up with all the ideas for designs from your formative work. Now, one theory behind ideation is that to come up with a few good ideas, you should generate a lot of ideas. So quantity is actually the way to get to quality. Now, there's a few steps to a good ideation, and I really prefer doing this in a team, though it's also possible to do this by yourself with a piece of paper. Typically before the ideation, if you're doing this with a team, I prefer getting the team together, deciding who should be on it. For example, stakeholders may be involved as part of your ideation, or people with diverse skills, so like designers and social scientists and programmers may all be part of your ideation session. Make sure that everybody who's going to be involved is familiar with your formative work results. So if you had your implications for design or your personas or your scenarios, go ahead and send those out to the team ahead of time so that they're familiar with what they should be using to situate their ideas. Everybody should know the goals of a particular research session, a particular design session. So whether it is just kind of blue sky brainstorming ideas for the future based on implications for design, or whether it's something specific, like there's a specific problem we're trying to solve, we hit a wall in terms of how to solve it, how would we go about going around it. And the other thing is very important. It's very important that everybody in your team is fairly comfortable being silly with each other because you're going to be coming up with a lot of ideas and not all of them are going to be good. So generally, I actually prefer if there's some sort of a hierarchy within your company, like there's a boss, I prefer having the boss out of the room during the brainstorming session because it can be very hard for people who sense a power differential to actually be comfortable enough throwing out wild and crazy ideas. So this style of brainstorming is known as IDEO style brainstorming. IDEO is a company that basically does brainstorming for a living. Companies come to them as consultants and ask them to come up with crazy ideas. The goal in this case is to come up with a lot of ideas, and there's 7 rules that can guide action in this situation. So one, and this rule is very important, perhaps the hardest to enforce, is to defer judgment. So in this case, you just want to come up with a lot of ideas. You don't want to necessarily have to come up with a lot of good ideas. The hope is that by coming up with many ideas, at least some of them would be good. So even if you hear an idea that's absolutely ridiculous, so let's say we're designing the shoe of the future and I decide to make hover shoes even though physics say they'll never work, or you think they'll never be safe, or you think that people will never buy them. It doesn't matter. It's an idea and we write it down and we move on. In fact, you want to encourage wild ideas. So I always show this picture of shoes because we don't usually think about shoes alongside interactive technology. But somehow every time I have a wild brainstorming session with students, eventually some sort of a shoe idea comes to the foreground, comes on the board. And I think it's important that sometimes you want to actually throw out a silly idea as a facilitator to get the whole session going so that people know that it's okay to throw something out that would never work, or throw an idea out there that's kind of really out there, like putting a screen on a shoe, or shoe hoverboards, or robot shoes, or something like that. Now, part of this is actually building on each other's ideas. So let's say somebody says something that you don't think is going to work, like hover shoes. Instead of saying, oh, that's never going to work, you should use the yes and rule, which is also common in improv. So the idea is you say, yes, hover shoes, and maybe they can also, before we invent hoverboards, maybe we could also have shoes with wheels, so like rollerblades. Now, of course, that's kind of an idea that's already out there. But the idea is that you take the idea that the other person had, you add something to it, or you build on it in some way, or you change some little part of it in order to add something of your own to the idea. And you write down both ideas. Both of those ideas will count as one number idea for your brainstorming session. The other rule is actually really important, especially in focused brainstorming, is staying focused on a topic. So the images here are of brainstorming sessions that we had around technology to support parent-child communication. So the image on the left was from a kind of the ideas we selected from a larger brainstorming process that was more open-ended. And then we decided to focus on this idea of camera projector systems for parent-child communication. And then we conducted another brainstorming that was more focused on that specific topic. How would you structure camera projector systems for parent-child communication? And so what you're seeing on the right is a lot of different systems that we considered. So would this be something that's a table? Would this be something that's a tent? Would this be something like that would be a box or a toy or maybe a lamp? But all of them focused on this idea of projector camera systems for parent-child communication. This is kind of hard as a facilitator because on one hand you want to defer judgment. On the other hand, if you're sensing that the group is getting away from the topic at hand, you want to kind of corral them back in and say, let's get back to this idea of parent-child communication systems using camera projector systems if they've gotten off on a topic of shoes and it no longer involves the conversation of interest. But usually if kind of the last 5 ideas have been off topic, it's a good point to step in and say, okay, let's get back to the topic of interest. Rule 5 is that you should only have one conversation at a time. And in a long brainstorming session, what will sometimes happen is that some idea will catch the interest of 2 or 3 people in the session, and they'll kind of start having their own conversation in the corner. And you really want to prevent that from happening, because then they can't add their ideas and build on the other ideas that are being currently thrown out on the session. So you really want to kind of corral them back in and say, right now we're focusing on the ideas that are out there. If you want to build on any of the previous ideas, please throw out your idea as a new idea. Rule 6 is being visual. So if you watched one of my other videos, I talk about sketching as a really powerful way of communicating ideas, and that's one way of being visual. Other people actually prefer even having kind of physical props in their brainstorming sessions, whether that's Legos or construction paper or whatever it is, to help people communicate ideas that are not necessarily just on a phone, but some gadget or device that is physical in nature. And all of these can really help kind of situate an idea and make it concrete so that other people can build on it. Rule 7, and I think this is actually the most important rule, is going for quantity. So it's a little bit hard to see here, but what you see in the slide are the actual number of ideas for coming up with technology to connect parents and children. And in an hour, you definitely want to come up with more than 100 ideas. You want to number them as you go along, so you kind of know how far you're going through the process and how many more you have left to go. And what I typically find is that at some point in the process, you'll hit a wall, and you'll need to kind of break through that wall. And frequently, it's after that point of thinking, oh my gosh, this can't possibly be anything else that we can add to this list, that some really interesting ideas, some ideas that other people haven't considered, really come to the surface. I think with any kind of design challenge, all of us have some kind of on-the-surface ideas, some initial ways that we might go about solving the design challenge. And those kind of get stuck in our heads. They're so loud that we can't get to the more interesting and more original ideas underneath. And I think that's really the idea behind going for quantity. So you take those initial ideas and you put them down on paper. And once you get your initial 20 ideas out, then you really have to start thinking hard about new and original solutions to the problem. So I find this process overall very valuable. And it's also a great team building exercise. So in general, you know that this process worked when you've received a wide variety of ideas for the given goal. So it's not just, if you were looking at blue sky ideas for connecting parents and children, they're not all just Skype apps or Skype-like apps. There's like a wide variety of things that these applications do and devices that they may run on. I also think it's a good sign when after the brainstorming, nobody says, oh, that one was my idea. Typically, when people start building on each other's ideas, they very frequently forget exactly whose idea something was. It just feels like the whole team came up with the ideas that are on the board, and I think that's a very good sign. And also, just at the end, you feel like celebrating. You feel like you started this task that's very difficult, coming up with 100 ideas in an hour for some specific technology topic based on your formative research. And accomplishing it feels like an accomplishment because when you start, it really feels improbable that you're going to come up with 100 different ideas to support something. So overall, this is probably one of my favorite processes in human-computer interaction in user interface design. If you'd like more information about it, there's 2 places I think that are very helpful. So one is actually a news segment about the company IDEO, where they show their process for redesigning the shopping cart at a store. And they really kind of follow through all of these IDEO ideas and these IDEO rules in coming up with their ideas. Also, IDEO releases a set of method cards. So these are cards that help inspire you and can help you have new ways of coming up with ideas for your team because brainstorming is just one method of doing this. And these cards are available online, so if you go to the address here, you should be able to find them and use them with your team as well. So ideation, coming up with lots of ideas very quickly and not worrying yet about whether they're good ideas or not. So that's all I have for you today, and I hope to see you in a future video. Hello and welcome back. Today we'll be talking about idea selection. So if you followed the ideation video, at this point you may have hundreds of ideas scattered on post-it notes or whiteboards or in sketches or in a document somewhere. So how do you go through all of these ideas and actually decide which ideas to pursue? So I'm going to share one possible process, and this process really does benefit from going through this with a team of people, but it could be potentially done by somebody on their own as well. So here's the general overview. So first you're going to call and combine ideas. You're going to cluster some of them. You're going to name and describe each idea, and perhaps even sketch it if you have the opportunity. You're going to rate the ideas based on either your implications for design or your design requirements or your personas or however you have kind of formulated your formative data. And then you're going to combine those ratings, discuss, and choose. So the example that I'm going to use in this is an example I frequently use with my class, where we had brainstormed kind of social footwear, the idea of putting technology in shoes or on shoes and seeing how that could improve people's lives. So it's kind of a silly idea, but it really usually leads to a wide variety of interesting ideas, and that's why I use it. And when I kind of go through this process of culling, combining, clustering, I'm really kind of aiming for something like 7 clusters maybe, definitely no more than 10. I think it's hard to really articulate more than ideas than that. And probably not less than 3 because I think that's not enough ideas for a rich discussion. So somewhere between 3 and 10 maybe, and 7 is frequently the number we end up with. So as you go through your idea selection, how do you cull and combine? So the first thing is that since you weren't at all judging during your brainstorming process, or at least you weren't supposed to judge during the ideation process, you may actually have 2 ideas that are essentially identical. So for example, in the class when we did the shoe brainstorming, the idea of a screen being on a shoe and the idea of being able to project information on a shoe is really kind of identical. I mean, there may be kind of different assumptions of technology, but what it does is the same. Somehow information appears on your shoe. So in fact, those 2 ideas you can just pick one of those and keep that one and discard the other. You can remove all ideas that are unrelated to the project topic. So for example, again, because we weren't judging in the process of brainstorming, people may have come up with some crazy ideas for shoes that had nothing to do with this idea of social or technology. May have just been like cool shoes with heels that look like the Starship Enterprise. Well, that's cool, but it doesn't have anything to do with technology and it doesn't have anything to do with social. So all those ideas can be removed from the list and don't have to be included in the consideration. So just going through those 2 steps, frequently your list can be cut down by half. So when you started out with your 500 ideas or 100 ideas, at this point you may only have 50 left or 250 left. You can also abstract ideas that are very similar in function. So for example, 3 ideas that we came up in our brainstorming were shoes that vibrate when your friend is close, shoes that light up when a friend is near, and shoes that get warmer when near a friend. So all of these are really getting at the same concept. So shoes indicate proximity to friends through sensory feedback. And so all of them can kind of be abstracted and combined into a single idea. Now the next step is clustering. You can use something like affinity diagramming, affinity mapping, mind mapping to cluster the remaining ideas. And I really prefer to cluster based on what the idea does. Now, if you need a reminder of how to cluster, this is actually very similar to the process taken in qualitative analysis. So take a look at the qualitative analysis video for kind of the exact steps of doing this. But from the shoe example, you might end up with kind of 4 categories. So let's say a shoe that delivers navigational information somehow. A shoe that delivers, that sends sensory experiences to a friend. Shoes that respond to proximity of a friend. So that may include this idea of shoes that indicate proximity to a friend through sensory feedback, but may have also other ways that those shoes indicate proximity to a friend. Shoes that help teach specific skills, whether that's driving or dancing or running or whatever it is. And in addition to kind of the major clusters of ideas, I also like retaining kind of unique or promising, what I call orphans. So ideas that may not be part of a cluster, but that are kind of interesting and different and are relevant. So perhaps shoes that provide feedback in a social game. We may have only had one idea that kind of got at that concept, but if it was interesting enough, we still may want to retain it. So the next thing you do once you arrive at your clusters, and as I said, somewhere between 3 and 10 is probably the right number, you want to name and describe examples. So for example, maybe the name of this idea is visual friend proximity. You may even sketch it out. So this is kind of like this American shoe called the Croc that kind of took the country by storm for a while, and kids would frequently decorate them with these little kind of add-on objects, kind of like pins. And so maybe the idea is that each toy on this Croc represents a trade with a friend, and then it glows when that particular friend is nearby. So we've named this example, which is visual friend proximity. We've provided an image that's optional, but it's very nice if you do. And we've kind of described it in a single sentence so somebody could understand what that idea is. And then the next step is really rating this idea and other ideas that you may have based on either your implications for design or your design requirements or your personas, or however you actually articulated and formalized the findings of your formative study. So for example, maybe in your formative study from interviewing people about opportunities for social footwear, observing people, you may have found 4 implications for design, such as encourage physical activity, so they have to be physically active. They protect the user's privacy, they support personalization, and they leverage this like urge to collect. So people frequently want to catch them all, whether it's Pokemon or pins or badges or whatever it is. So if those are your 4 implications for design, you may ask each member of your team to rate each idea on a scale of 1 to 5 based on how much it actually sort of builds on that idea or contributes to that idea or responds to that particular implication. So for example, lots of people here may have thought that this is not that great for active use because these traded pins will glow no matter what, but it's very good at leveraging this idea of collectibles. And it's pretty good at leveraging this idea of personalization. Like you can really pick the pins and decide which pins to trade. And in terms of privacy, it's kind of in the middle. You know, maybe you don't want your location shared with your friend just because you've exchanged a pin. So it might violate the privacy of some, but maybe other people would be okay with that. So in essence, each of these ideas is now kind of considered upon all of these dimensions. And you do maybe want to kind of restate or refine whether it's your implications or your personas, or potentially even rank them based on their relative importance before you go through this process, because it can actually really help you quantify which things are important and how this particular idea performs on all of these requirements. Now the next part is kind of subjective. The process of combining ratings or discussing or choosing most promising ideas is really up to you. You may just average those rating scores on the different criteria. Maybe that will lead you to a good response. Or maybe you'll include another round of voting by team members after kind of conducting this discussion where all of these design requirements or personas are really considered. So that voting process, it doesn't need to be sort of one idea per person. In fact, what I find to be one of the most helpful ways of doing this is by giving each person multiple points to distribute among ideas. So let's say you tell each member of your team that they have 10 votes and they can place them however they want among the ideas that are available. So for example, if that particular member of a team feels really strongly about one particular idea, that's the best way to go, they may actually put all 10 of their votes on that particular idea. Now, it could also be that, there's 3 ideas and they're kind of equally split between them, so they'll give each one of those 3 votes, for example. And one of the ways that I operationalize this frequently is with Post-it notes. So here's, for example, an example of where I had students, the ideas were pinned up and students were voting by just placing their Post-it notes on particular ideas. It's very visual, it's very easy to see how many votes a particular idea is getting, and it also helps people make their decisions about how to place their votes. So hopefully through that process, you actually arrive at the ideas that seem most promising, or at least ones that you now want to communicate to stakeholders, to users, or to maybe your manager, or whoever actually gets to kind of figure out what are the next steps, or continue providing you with feedback on what the next steps might be. So typically what designers do next to these steps is figuring out specific alternatives. So maybe you've decided that yes, visual proximity to friends is the way you want to go with shoes, but now you actually need to figure out how that visual proximity will be determined. So you might actually go through another process of brainstorming and refining. So for example, the study I often use is the idea of the share table system that connects parents and kids. So once we decided we wanted to use a camera projector system from the first set of brainstormed ideas, now we went through a whole entire process to try to figure out, well, what is that camera projector system going to look like? Is it going to be a table lamp? Is it going to be a box? Is it going to be a tent? Is it going to be a cabinet? What is it going to be? Sketching and storyboarding is really valuable here. There's a video you can watch on communicating diverse ideas to stakeholders where I really sort of advocate for sketching as a good way of expressing ideas. Critiquing and refining ideas, whether you're doing this with stakeholders, participants, or whether you're doing this within your team or perhaps with a manager, it can be a really valuable process to actually get to the core of what makes an idea good, or perhaps take out some of the negatives of an idea. And lastly, and I hope ideally everybody does this at this stage before they decide on the final idea to pursue, actually getting user feedback. So at this point, your ideas are probably expressed as a single paragraph or as a single sketch or drawing. And so it's really easy to actually take that to some users and say, here's what we were thinking. Do you think this would work for you? Because if something doesn't work for them, something's really going to conflict with the way they live their lives, you want to find out about this when you've committed 15 minutes to sketching something, not when you've committed 5 years to building some new piece of technology. And so, yes, the more you get user feedback, the more you manage your risk. And so that's something I definitely recommend you do. So hopefully this video provided you with some insight on how to actually go from a set of 500 or 5,000 or 100 ideas, whatever it is, down to a more manageable and concrete set of ideas that you may pursue in your designs. And I will see you in the next video. Hello and welcome back. Today we'll talk about communicating all of these great design ideas that you've come up with to stakeholders. That there are a few benefits to actually communicating the ideas to stakeholders early, often, at the right granularity. The idea is that you can actually get a lot of feedback early on in the process before you devote a lot of resources to something. So I'd much rather hear a user say, wow, this will never work, to a sketch that I spend 15 minutes on, than spend 2 years and $2 million developing a very expensive system and then have them tell me this isn't going to work for my needs. So there's many different ideas for communicating how your system may be used. I actually like kind of hybrid approaches. But here's two examples. So one may be something like a use case, and the other one combines a use case with a series of small drawings that we call a storyboard. So for example, in this use case, you describe the individual. So in this case, it's Jeff. He's serving a tour of duty overseas, and he has 2 kids living with his wife. They have a single brightly colored system, which we call remote presence, on their coffee table. And every day when the kids are at school, they decide on a small treat to put in the box, and then they are able to open that box only when their dad calls them. So the idea here is to help Jeff, while he's overseas, to stay connected with his kids and have kind of a fun little thing that he does with his kids every day. And so on the left, you see this described as a use case, described just in terms of just using words. And on the right, you see it described as a storyboard, which combines kind of sentences that say what happens with pictures of how this would actually be used. Now, in this talk, I'll actually focus on the idea of sketching to communicate your ideas. And there's a few reasons why I want to focus on sketching. I think it really gets the idea across in a way that still suggests it's open to edits. So it's specific enough that you're showing the user exactly how somebody would proceed through using the system, what are the different steps of it, even maybe a little bit about what it looks like or how they would go about using it and where. But it still can be kind of low effort enough that the user will feel comfortable giving you feedback. They won't feel like, oh, well, it looks like they've spent hours on this thing. I can't say that it's never going to work. And that they'll give feedback at the right granularity. So for example, if you show a sketch of a system that doesn't really have colors yet, it's just pencil sketch, the users can't comment on colors if that's not the kind of feedback that you're looking on. And that can be really helpful because sometimes if you show a very well-defined sketch, something like a mocked-up prototype in PowerPoint, and it looks fairly complete, the users will comment on kind of low-level characteristics like font size or the buttons or the layout, rather than the kind of feedback you may be looking for, which is this something that you would find useful in your life? Is this the kind of system that you would want to use? So since I'm going to ask you guys to sketch, I wanted to go through a few common myths of sketching. So the main myth that I deal with all the time with my students, who are usually computer scientists and so are fairly wary of picking up a pencil and drawing, is that sketching is about drawing. Now, I don't really think that it is. To me, sketching is about lots of things. So it could be about planning. So for example, here's an example sketch for a website that plans out where the different parts of that website will go, how a user will interact, where you'll have things like the cost of the item, the styles of the item, basically planning out what it's going to look like eventually. You could also say that sketching is really about communicating ideas. So one of my favorite online comics is xkcd.com. The writer always draws the examples using stick figures. So it doesn't require realistic drawing to communicate an idea. You can actually do them very briefly through brief sketches like these stick figures in this drawing. And also, this is a great comic for programmers. I will give you a second to read it. So stick figures can be very effective. I also think that sketching is really about understanding something. So this is an example of a self-powered flashlight. It's a handheld flashlight that can be powered by cranking a handle that I actually took apart and kind of gave an exploded view of to figure out what all the parts inside it were and how they all connected together. So by doing this, by sketching it out, I was actually able to understand how all the pieces fit together and where all of them were. It was very specific, like I couldn't miss a piece of this flashlight because then I'd know something was in the physical model but not on my drawing. And I think that specificity is very important to understanding something. So then, as I provide these arguments for why drawing could be helpful to people in explaining their ideas, I frequently get the argument of, well, but I can't draw. I'm a programmer, I'm a computer scientist, so what do I do? The two tricks that I've covered with my students that I found very helpful, and these are actually examples of real student work, is to simplify shapes and use stick figures. So as you see in the example to the left, hands are represented by a very simple kind of S-shaped. A tablet is represented as a rectangle. People are represented as a circle and an oval. And nonetheless, it still communicates the idea, communicates how the system would be used and what somebody would do with it. The other solution that I really like is actually taking a photo and tracing it. So in this case, the students took a photo of somebody using the phone, and then instead of drawing the interface of the phone as it was on the screen, they added their own interface to it to show how somebody would use the system. So again, there was no drawing skills required here, as just required a photograph that you then trace with a pencil. But both of these drawings kind of communicate the same thing, so they can have a sketchy quality to it that makes participants more comfortable giving feedback that is still formative, saying, no, this will never work, or I don't think you're going about this the right way. They're black and white, so participants can't get stuck on details like color. They are still fairly sketchy in terms of kind of the layout and the sort of things they show. So you might get the kind of feedback that you want about whether the participants would find the system useful, whether they would use it in their everyday life, rather than more specific, lower level feedback that you might not want quite yet. So if you like this, if you think sketching could be something that you could use in your work, there's one book I really recommend looking at. So this is actually my favorite book of all time on user interface design. It's called Sketching User Experiences, the Workbook. It shares lots of different strategies for how you can sketch to communicate your ideas. And it really assumes no knowledge of drawing ahead of time because, as I mentioned in this lecture, sketching is not really about drawing. So that's all I have for you today, and I hope to see you in the future video. Hello and welcome back. We've been talking a lot about how to get ideas, how to select the best ideas from a list, but really the only way to learn this is by doing this. And that's why we have an assignment on ideation and selection for you. So in this video, I'll just be briefly describing this assignment and giving you a few tips for succeeding on it. So here are the assignment components. We're going to provide you with some formative user research. This happens to be an actual research paper that our group wrote. And this research is on how work-separated families use technology. So work-separated families are ones where a parent may travel for work or for studying and the kids are left somewhere else. So you're going to read through this paper and you're going to ideate. You're actually going to do ideation to come up with 100 ideas for technology that can help these families. Then you're going to select 5 ideas and elucidate these ideas as paragraph-long use cases or similar descriptions. So just one paragraph about each idea describing it. If you're feeling ambitious, you can also provide sketches. There's no extra credit for this. I always enjoy seeing students' sketches, so if you're feeling up to it, definitely include those as well. But you're really being rated on that paragraph-long description. And you will be asked to comment on other students' ideas as well. So just make sure to leave some time to do that peer grading. All right, so a few tips for succeeding on this assignment. You're going to have to come up with 100 ideas, which may seem like a lot. What I enjoy doing is giving myself a time limit. So if something like I'm going to sit down for an hour and I'm going to come up with these ideas, rather than kind of writing down a few good ideas, then agonizing over it over the next few days, writing down a few other good ideas. It's important that at this stage you don't actually critique your ideas, judge them in any way, or limit them. Even if an idea seems ridiculous, even if the technology you invented to help connect parents and kids is a teleportation platform and you don't think that's actually technologically feasible, it doesn't matter. Write it down. It's about the quantity of ideas, not necessarily about the specific quality of them. You're going to get 2 points per idea on the assignment, so up to 50 points. So no matter how good or bad an idea is, you're going to get a point for it. So the key is limit your time, try to think crazy, try to think wild, try to think of a lot of different ideas, and don't critique yourself at this part of the process. Now, once you get to idea selection, from those 100 ideas, you actually just need to pick 5 ideas that you want to provide us with more detail on. And so you can combine and cluster your big idea list, and there's a video lecture helping you figure out how to do that. We want you to choose 5 diverse ideas, and this is key. So if you have an idea that's like, oh, it's an app that lets a kid send photos to their parent, and if you have another idea that's like, oh, it's an app that lets a kid send photos with filters to their parent, those are a bit too similar. I would either combine those 2 ideas or only use one of them and use something a little bit more different for a different idea. And the other thing is, at this stage, you can do a little bit of critique and judgment of your own ideas and make sure that they're actually consistent with the findings of that formative user research study that you read. So if that user research study says, you know, kids aren't going to be motivated to initiate a phone call and your idea is a special phone that only kids can use to call their parents, then maybe that's not actually consistent with the findings of the study. So just something to, as you're going through it, being critical of your own ideas and trying to connect them back to that formative research. And then a few tips for writing the idea. So I find it's helpful to name each idea. You can easily refer to it in the paragraph then, and it's kind of like it has a name in your mind, which I think is nice. Describe each idea briefly in one paragraph. Maybe give an example of how a work-separated family may use this technology, like you can name hypothetical people that would use it. And the key is that it doesn't need to solve the problem 100%. So maybe you design a technology that's really focused more on the parent that's staying back at home with the child because they have a lot of responsibilities in actually connecting them with the remote parent. And that's fine. It's fine if it's focusing on like a specific stakeholder or solving some component of the problem, but not trying to solve everything at once. But do consider how does the formative research relate to this idea? How does it inform or inspire this idea? So just to give you a concrete example, so maybe after reading the paper, I would have an idea about these ePet recorders. So the way I would write it up is this way. So I would name it ePet recorders. In this case, I'm going to use a hypothetical family. So Bobby's dad, Richard, is traveling for work for a whole month. Like many other parents, Richard struggles with staying aware of Bobby's everyday life. And so this is actually making a reference directly to the formative work. Parents who are traveling struggle staying aware of the life of the children back home. To help solve this issue, Bobby has several pocket-sized and wearable toy pets with built-in sensors. These let Bobby share recordings, such as audio messages, photos, etc., of his day as he plays with his toys. Now, this doesn't need to be a perfect idea. So for example, somebody may critique and say, well, we know that kids aren't very motivated to stay connected with parents who are traveling, so how are these toys actually going to help build that motivation on Bobby's part? So that would be a fair critique of this. I didn't actually address that in the statement. But I did connect it back to formative research. I did describe kind of vaguely what it does. I even provided a sketch here, which is optional. That's basically what we're asking you to do for each of your ideas. So a few notes on grading. So this is going to be fairly loosely graded, and I do, as you are grading your fellow students' assignments, I do want you to have kind of a bit more of a loose grading structure on this, a bit more benefit of the doubt. So the first 50 points just come up from coming up with those 100 ideas. So you get 2 points per idea regardless of quality. It's really just a counting exercise. And then for each of the 5 ideas that you elucidate on, It's 10 points each. You get 4 points for just clearly describing it in a paragraph. You get 3 points from the fact that it actually relates to the user research. So it's not like the idea is something completely unrelated. So suddenly we're talking about how to help software engineers write code. Like that's not a related idea to how to help parents connect with kids. And the other thing is that it needs to be different from the other 4 ideas. So try to be as diverse as you can. Don't have like 5 examples of photo sharing apps. That's probably not different enough from each other. And there's also a little bit of double jeopardy on that one, because if you have 2 ideas that are identical, you're losing 3 points on each of these ideas for it not being different from the other 4 ideas. So I think that diversity and picking out interesting diverse ideas is actually a key part of this assignment. So there's a few relevant lectures that you may want to review before you start the assignment. The key ones are definitely the ideation video, which helps you come up with lots of ideas, and the idea selection video, which gives you some ideas about how you might actually go about taking your 100 ideas and getting them down to the 5 that you're going to describe. The use cases video may be relevant as a good way of describing in a short paragraph how a specific technology may function. And the communicating ideas to stakeholders video also talks a little bit about things like user scenarios and sketches as well. So hopefully this gives you enough to get started. I really look forward to seeing the kinds of ideas you come up with, and I hope you enjoy reading the paper. It was one of my favorite papers to write. Thank you. Bye.